Hey everyone, welcome to SimpliCode's YouTube channel. Today, we'll be taking you through the Node.js full course. We'll begin this full course video by understanding what exactly Node.js is. Next, we'll go through the installation process of Node.js and make the computer ready for Node.js development. Next, we'll have an in-depth understanding of Node.js architecture and some of its popular modules. Next, we'll see how to interact with APIs using Express framework based on Node.js. Then, we'll see how to use Node.js in web applications and API services. Then we'll look into the web authentication using JSON web tokens. Then, we'll look into using Node.js with database systems like MySQL and MongoDB. At the end, we'll look into Node.js interview questions and answers that summarize every important Node.js concept and serve as a perfect preparation resource for Node.js interviews. So, let's start with an exciting video on Node.js.
So what exactly is Node.js? Now consider a scenario where a user interacts with a web application. The user only interacts with the front end of the application. But there's a lot of work that goes behind the scenes. Now in a web application, there's a front end, a server, and a database. The front end is developed using JavaScript and frameworks like Angular and React, while the server is built on Java, PHP, or Node.js, and the backend database that stores the data usually consists of MySQL or MongoDB. So Node.js is an open source, cross-platform JavaScript runtime environment for running server-side applications. It is used to develop I/O-intensive web applications like video streaming sites, single-page applications, online chatting applications, and other web applications. It is used by large, established companies and newly minted startups. Node.js was developed by Ryan Dahl in 2009, and at the same time of this session, its latest version is v13.3.0. Now that we know what Node.js is, let's go ahead and look at why it was so prevalent in the field of web development. Here are a few points. First up, Node.js is extremely fast. Being built on Google Chrome's V8 JavaScript engine, its library is extremely fast in code execution. Node Package Manager has around 50,000 bundles for developers, so whatever functionality is required for an application can be easily imported from NPM. All APIs of Node.js library are asynchronous, that is non-blocking. It means a Node.js-based server never waits for an API to return data. Node.js dramatically reduces the processing time while uploading video and audio files. It is also an open source platform and is easy for beginners for web development. The above reasons more than justify the popularity of Node.js platform and why it is being adopted by a large number of organizations and businesses today. So now moving on, let's familiarize ourselves with the parts of Node.js. Node.js consists of several components. Now let's look at them one by one. First up, we have modules. Now modules are like JavaScript libraries which are used in a Node.js application to include a set of functions. Now we can use required function with a parenthesis to include a module in a Node.js application. Node.js application has many modules to provide basic functionality needed for a web application. Some of them could be HTTP, util, fs, URL, query string, stream, and zlib. Next up, we have console. The console module provides a simple debugging console that is similar to the JavaScript console mechanism provided by web browsers. Now the console can print messages to stdout that print standard output messages and stderr to print the error messages. The next component is cluster. Now Node.js is built upon the concept of single threading programming. A single instance of Node.js runs in a single thread. To take advantage of multi-core systems, the user will sometimes want to launch a cluster of Node.js processes to handle the load. A cluster can be added to an application in this way. Here's a small code for you. The next component is global. Now global objects in Node.js are available in all modules. Now these objects are functions, modules, strings, etc. Some Node.js global objects are mentioned in the table. You have dir name, that is a directory name, file name, exports, module, and require. The next component is error handling. Now Node.js applications experience 4 types of errors. We have the standard JavaScript errors, system errors, user-specific errors, and assertion errors. Now errors in Node.js are handled through exceptions. Now for example, let's handle an error that would occur when we divide a number by 0. Now this error would crash the Node.js application, and so we should handle this error. Here's a small code for you. Next up, we have streaming. A stream is an abstract interface for working with streaming data in Node.js. Streams are objects that let you read data or write data continuously. There are 4 types of streams. First one is the readable. These are the types of streams from which data can be read. Writable, these are the types of streams to which data can be written. Duplex, these are both readable and writable streams. Lastly, we have transform. These streams can manipulate the data while it is being read or written. Moving on to the next component, buffer. The JavaScript language has no mechanism for reading or manipulating streams of binary data. Buffer is a module that allows handling streams that contain only binary data. An empty buffer of length 10 can be created by this method. Next up, we have domain. Domains provide a way to handle different I/O operations as a single group. Domain module intercepts errors that remain unhandled. There are 2 types of methods that are used for intercepting these errors. Firstly, we have internal binding. In this case, the error emitter executes its code inside the error method. Next up is the external binding. Now here, the error emitter is explicitly added to a domain via its add method. The next component is the DNS. The DNS module enables name resolution. For example, it is used to look up the IP addresses of host names. DNS module is used to connect to a DNS server and perform name resolution by using the method dns.resolve. The DNS module is also used for performing name resolution without a network communication by using the method dns.lookup. The next component is the debugger. Node.js includes an out-of-process debugging utility accessible via a V8 inspector and built-in debugging client. This Node.js debugger is not feature-packed but supports simple inspection of code. It can be used in the terminal by using the inspect keyword before the name of the JavaScript file. In order to inspect a file, say myscript.js, you can use the following method. Now that we are familiar with all the major parts of Node.js, let's go ahead and learn about the Node.js Express framework. Express is a flexible Node.js web application framework that provides a wide set of features to develop both web and mobile applications. You can assume Express as a layer built on top of the Node.js that helps manage the server and the routes. Now let's have a quick look at some of the core features of Express framework. It is used to design single-page, multi-page, and hybrid web applications. It allows the setting up of middleware to respond to HTTP requests. It defines a routing table that is used to perform different actions based on the HTTP method and URL. It also allows dynamic rendering of HTML pages based on passing arguments to templates. Now moving on, let's take a quick example of a simple Hello World program. Now this is developed using Express framework to gain a better understanding. Alright, first up we have the where express. Now this is used to import Express framework into our Node.js application. Now the app.get method is a callback function with parameters request and response. The request object represents the HTTP request and has properties for the request query string, parameters, body, HTTP headers, etc. The response object represents the HTTP response that an Express app sends when it gets an HTTP request. Now the application will listen to the defined port, which in this case is 8081, and variables host and port will contain the address and the port respectively. Lastly, we have the console.log, which is used to show the address and port in the command prompt. So this is what the command prompt would look like. And finally, the output is displayed on the web browser. Having learned about the Express framework, now let's move on and look at the Node.js use cases. Now it is no doubt that Node stands out for its speed and intensive data exchange. So top industry leaders like NASA, PayPal, Netflix among others incorporate Node.js. First up, we have Netflix. The world's leading internet television network with over 117 million users is one of the top companies that trusted their services to Node.js. The reasons why the company chose to use Node.js were application scalability and data-intensive application. Now you must be wondering what application scalability is. It is basically the potential of an application to grow in time, being able to efficiently handle more and more requests per minute. And data-intensive application allows millions of people to stream Netflix simultaneously. Next up is Walmart. Now Walmart is the world's largest company by revenue with around $514 billion according to the Fortune Global 500 list in 2019. Again, the reasons why the company chose Node.js were asynchronous I/O and efficient handling of concurrent requests. Now asynchronous I/O, which is a form of input-output processing, allows other processing to continue before the transmission has finished. Node.js is able to efficiently handle concurrent requests with the use of thread pool and event queues. Uber. Uber is an American multinational ride-hailing company offering services that include peer-to-peer ride-sharing, ride service hailing, and food delivery. The reasons why the company chose Node.js were asynchronous I/O, quick iterations, and active open source community. As mentioned earlier, asynchronous I/O permits other processing to continue before the transmission has finished. Now, quick iterations. Now, Node.js is continually being updated and added new features that help in further improvement in the performance of web servers. And finally, active open source community resolves many problems that an organization may face in a particular scenario. Next up, we have NASA. Now, NASA is an independent agency of the United States federal government responsible for the civilian space program as well as aeronautics and aerospace research. The reasons why the company chose Node.js were reduced access times, handling of data-intensive tasks, and the fact that the servers are active 24/7. Now, NASA has lots and lots of data, and using Node.js has really helped them in reducing the access times. It is also continuously handling and working with large streams of data. Node.js is highly stable, which helps in keeping the server active 24/7. Next up, we have PayPal. Now, PayPal is an American company operating a worldwide online payment system that supports online money transfers as opposed to traditional methods like checks and money orders. The reasons why the company chose to use Node.js were the fact that Node.js has extremely fast build times. It allows tasks to be carried out with fewer lines of code when compared to other server technologies like Java and PHP. And Node.js, being data intensive, efficiently handles a large amount of data. Next up is Medium. Medium is a popular online publishing platform developed by Evan Williams and launched in August 2012. The main reasons why the company chose to use Node.js were A. Data-driven applications. Now, these applications are ideal for being interfaced with Node.js servers. B. To run A/B tests. Now, A/B testing is essentially an experiment where two or more variants of a page are shown to users at random, and statistical analysis is used to determine which variation performs better. Lastly, Node.js server maintenance is simpler than its counterparts. Moving on to the last topic of this session, industry trends. Now, Node.js developers are in demand across the globe since many companies are adopting JavaScript libraries. According to Forbes, it is one of the top 10 most in-demand jobs. According to NodeSource, the total number of Node.js downloads increased by 40% in the last 1 year. The use of Node.js in production has increased dramatically since its release in 2010. With early adopters such as LinkedIn, PayPal, and Netflix, among others, Node.js has seen an exponential increase in its use in web development. The popularity of Node.js is also accounted to JavaScript. Now, since JavaScript is the most popular language, as evident from a survey conducted by Stack Overflow in 2019, many developers can start working on Node.js library with not much of a learning curve. Node.js developers are being offered better salary options than other web technology developers. According to PayScale, the average salary of a Node.js developer in India is around 6,13,000 rupees per year. The average salary of a Node.js developer across the United States is around $105,000 per year. In this video, we'll help you install Node.js on your Windows system. So without further ado, let's begin. The first thing you need to do is download Node.js from their official website. So go ahead and type download Node.js. Navigate to their official website, and here you can see the 64-bit version. So go ahead and download that. Once the download is done, go ahead and run the downloaded Node.js installer. Accept the license agreement. Keep the default settings as it is. And then say install. So with that, we finished the installation process. Once Node has been successfully installed, the next crucial step is verification. Now this process ensures that Node has been properly installed. To do so, we first open the command prompt and then type in a few commands. To verify the successful installation, we type in this command, node-v. Now this command returns the version, and if it returns the version, it means it has been successfully installed. So here we go, it returns the latest version. Now the final step is to update the Node package manager. Now this NPM is bundled with Node.js, which consists of all the repositories and packages required for development purposes. So to do that, type in the command npm install npm -- global. Now that we're done with the installation of Node, let's go ahead and implement a small program. For that, we make use of a text editor. In our case, we've installed VS Code. So go ahead and download VS Code. Once you're done with the installation, this is what VS Code looks like. So go ahead and click on File and create a new file. It's going to be a simple program where you're going to print a hello world message on the web browser. To do that, we make use of HTTP modules. So Node comes with built-in HTTP modules to transfer data across it. So for that, we make use of a require method. We create a variable first, say var HTTP equals require, and just say HTTP within single quotes. Now the HTTP module can create an HTTP server that listens to the server ports and gives a response back to the client. To do that, we make use of the create server method. So let's go ahead and type the code. Say HTTP dot create server, and internally it consists of a function. Now the parameters to this function are request and response. Now the response is basically used to write to the client. So we say response.write, and here we type in the message. We say hello world, welcome to this tutorial. Once you're done with that, you end the response. So the server listens to a port number to display the message. By default, it listens to the port number 8080. So we keep that as it is and we end it. Save your file, say demo.js, maybe demo1.js, and say save. Now to run the program, you have to open the command prompt. So open your command prompt and mention the path to your file. So in our case, it's our saved on the desktop. So cd desktop. And now to run it, say node demo1.js. Now you navigate to your browser and say localhost 8080, and here we go. Our message is successfully displayed.
So let's talk about the Node.js architecture and understand why it's so good. So to begin with, Node.js has what's called a single-threaded event loop architecture, and this allows you to be able to handle many concurrent clients at the same time. It's just a very flexible way of being able to scale up your support for many clients. And then in addition to that, we have the JavaScript event-based model along with the JavaScript callback mechanism that allows you to have this standard approach to being able to connect with and talk and discuss interactions between the client and the server. It's good to have these kind of standards where you're not using something that's unique to a specific framework or a specific technology. This just makes it so it's more accessible for everybody. So if we look at the actual Node.js server itself, everything centers around the concept of the event loop. And the event loop has an event queue, an operation completed via requests, threaded pull, and then it'll actually do the actual computation or the file system interaction. All of this interconnects in a nice seamless loop. The great thing again with Node.js is that it's not new technology. It's been around for almost a decade. It's very well tried out. Many of the largest websites out there are running Node.js. So let's now dig into each of the parts of the Node.js architecture. So let's talk about requests. So the way that the request works is that you have your framework such as Angular on the client, and that will then send a request to the web server. And there's many ways that those requests can happen through web workers, through forms, and through other interactions. But at some point, a request is sent to the server. And so these requests can be for data, they can be for deleting data, they can be for updating data, they can be for interacting with services as mentioned before, but the goal is to have some kind of request. Now, once that request actually hits the server, and then we start actually getting into the queuing and threading process that centers around the event loop. And this is where Node.js really excels because it's able to use that single-threaded model to be able to manage from just even a few requests to tens of millions of requests. So it receives the actual request and starts the event queue. And this is where that single threading process starts, is by queuing everything up appropriately. And then it then maintains the threads within a pool. So you have the queuing process as one action, and then you have a threaded pool which manages those threads as well. And then we have an event loop which goes through and actually receives and processes those requests. And then finally, what we're doing is we're actually then going to be interacting with a system, and that could be a database, it could be a cloud system, it could be an API, file system, but we're interacting with something that's outside of the Node.js server. So the Node.js server itself is doing some actions on the server, but then it's also interact with things outside of its own server environment. And so let's talk a little bit about that workflow. So requests come in, they go into the event queue, and they get spiraled through the event loop. And then we have non-blocking operators, which are going to be doing the input-output polling, such as KQ, ePoll, and other services. And from there, we're also going to be then interacting with the threaded pool, and we're using the blocking operations to manage that threaded pool. And that threaded pool is going to now then go outside of the server and interact with something beyond the server. So whether that is a database or file system or API or microservice, these are the things that can be interacted with. So let's go through what NPM is. So NPM itself stands for the Node Package Manager. No great shakes there. As the name says, it's responsible for all the packages and modules that are bundled within Node.js. So the Node Package Manager itself really has two key functionalities. The first is that it is a central repository for all packages and modules, which you can then search through online. You can go to search.nodejs.org and you can find all of the packages and modules that are out there. The second is that it's also a command line or terminal line utility that allows you to install those packages, so you can actually go through and you can see the version management and dependencies within those packages, and you can control the packages themselves. So why would you use NPM? So NPM is really useful for being able to extend the project you're working on. So when you're building out a project, one of the concepts I like to use is the concept of Lego bricks. Big fan of Lego. And what's great about Lego bricks is that they're all individually by themselves, very small, very specific functionality. But if you actually get a whole collection of Lego bricks together, you can build like crazy cool things. So think of when you're working with the Node Package Manager itself, is that each of those individual pieces that you're working with, each of those individual packages are their own Lego bricks, and by themselves you can then edit and update and maintain that piece separately from the whole environment. As long as your inputs and outputs, really the piece where you snap the Lego in or when you connect the Lego to something else, are interacted and open and well documented, then you can actually then use those modules effectively throughout your project. So you can actually then be able to do that. You can do version control on your codes and dependencies. You can do testing very easily. And then once you actually get to the point where you go, yes, I want to release a new module, you can do that effectively using NPM, and it will actually go through and do the actual deployment for you. So let's go through the NPM installation. So the actual package manager itself is included with the installation of Node.js. So if you've installed and you're running Node.js locally, then you've already installed the package manager. But you can also access it through command line or terminal window on your data server or in your server farm or via the cloud. If you haven't now downloaded Node.js, here's the website where you can go down to install it, and there's Windows and Mac versions of that code as well with the installers, which allow you to get up and going very quickly. You want to be able to run the installer and accept all the default settings. To begin with, you want to kind of have the standard setup so that you are most familiar with the normal settings before you start getting to the point where you're a master and you're tweaking things. There is a way that you can open up the command window or the terminal window. And once you've actually installed Node.js, to verify that it's actually installed, you can write the command node-version, and it'll actually then pull out the version of Node.js that you have installed, and then you'll be able to see that you've got it actually up and running. And then you can also do the same thing for npm. You can do npm -- version, and it actually will then show you which version of the Node package manager you have running, so you can actually take full advantage of that program and verify that it's actually up and running. So let's actually look inside of a package. So packages themselves are actually just JSON files. If you're new to this space, JSON file is a structured file format that's based on JavaScript. It's a very XML-like format for being able to write instructions for the actual package itself. And so the JSON file forms the, really kind of the heart of each package you create. It has all of the metadata that you'd have about a particular object, and then it provides a root directory to any of the applications or modules that the package may be referencing. In addition, it has any other additional information about the project that adds, such as dependencies and other files that need to be included. So here we have is an example of a package that would be created using npm JSON script. And you can actually take this package file as it is right here and use the command npm init, and it'll actually run this package. And so you would actually then have a demo application up and running really quickly. You can then go ahead, if you want to, you can edit any of these parameters. So like, for instance, if you wanted to change the description or the version or what is the main index script that would be written, these are all things that you can edit very quickly and easily. You can just use text editor to make any of these edits. And so we have the different metadata that can be updated. And so this is where we go in and do a full demo of working with npm. So what we're going to do now is we're actually going to go ahead and actually run a demo of using npm. And to do that, I've got 3 windows in front of me right now. So I have this window here, which is my terminal window, where I'll be doing all of my instructions. Then I also have a folder which shows where I'll be putting all of the files. And then finally, I'll actually have a text editor. In this case, I'm using VS Code because it's free, but you can use any text editor you like to be able to go in and show what the code that's been created by npm in the JSON file, so you can actually see what it looks like. And then we'll modify it a little bit. So first thing we want to do is we want to go ahead and create a new project folder. So I'm going to go in, I'm just going to move into, I'm going to do change directory, and go into the project folder, and we'll see down here that we have an empty project folder. But for this one, I'm actually going to go ahead and I'm going to create a new directory in this one, and I'm going to call this one SimpliLearn. And there we are, we've created a new SimpliLearn folder, and we are going to move into the SimpliLearn folder. And so we're now in the SimpliLearn folder. There's nothing in there right now. So the first thing we want to do is we want to go ahead and initialize this folder as a project folder for working with npm. Now to do this, you will have to have already installed npm. If you have Node.js, npm comes with it. And if you want to see whether or not you have npm installed, so you can just do npm -version. And that will actually tell you what the version of npm you have installed is, and it also verifies that npm is installed. So I've gone ahead and I've been able to validate that I have npm installed. So what I'm now going to go ahead and do is I'm going to initialize this folder. So to do that, just do npm init, and you'll see that the path is that we're already in the SimpliLearn folder. And then when you do that, it's going to ask you some questions. So what is the package name? We're going to go with the defaults for right now, and then I can show you how we can edit those in a little bit. We're going to go with, just say yes to all of these just by hitting return. And you'll see here that we're going to create a new folder called a package.json folder. This is the instructions that we have in the folder. Do we want to go ahead and create this? We want to. And it's going to go ahead and do that. And we can see now in our folder here that we actually have package.json. So we go ahead and open this up with VS Code. Here we are. We can actually see what all of the information is. We can go ahead and we can actually go and update this metadata if we want to. I'm going to leave it as is for right now because I want to show you a couple of other things. So a lot of times when you're actually working with NPM, and the reason why you're using NPM is that you want to take advantage of packages that are freely available in the open source community that are supported by Node.js. And one of those is a package called Express. And Express is a lightweight framework for building out web applications, similar in concept to Angular or React.js. I like using it, and it's also a great way to be able to show how we can install this using npm. So to install this, you just start with the command npm and then you type install, and then we type the name of the package and we hit enter, and it goes ahead. And what you'll actually see is a couple of things. One is we have a dependency in our package above. We also have, so this is in our JSON package, that is now a dependency that's written in there. We can also go in and under our node modules, we actually see that we have, we scroll down, we should see Express. There it is, Express. Now, if we decide that we don't want to use Express, we can actually just come in and we can write command npm uninstall. I can type Express. Oops, I did a typo there, so let's try that again. npm uninstall Express. And a couple of things can happen. One is in our JSON file, the dependency for the Express file has now been removed. And we can also see that under our node modules, there are no extensions there. So this is kind of cool. This allows us to be able to see that we can easily add and remove packages. So let's just go ahead and I'm going to install Express again. So install Express. Oops. npm install Express. All right, so it's gone ahead and it's installed Express. Now, one of the things that will often happen is that when you're working with a package, the actual JSON package, so you'll receive this file, and you want to be able to go ahead and install all of the sub-modules that come with it. So you can go through and you can manually install them like this, or you can actually run an install command so you can actually install all of them at once. I can actually show you what that looks like, because we're going to actually go ahead and simulate as if we're going to install Bootstrap, which is another popular framework. Bootstrap. And we're actually going to go with, and then we'll save that. And what we'll see is under the packages that Bootstrap isn't listed in there. We do have Express. There it is right there. So we now come over to our new commands. We can actually write the command npm install, and now slight typo, let's try that again. Let's do npm install Okay, it does help to save your file. So let's go ahead and let's run npm install. And when you do that, what we'll now actually have is not just Express, but we'll also see that Bootstrap has also been added. Now, I don't recommend that you use the star symbol, which will install the latest version of Bootstrap, because you obviously haven't tested your application against that, but it gives you an idea of what's happened here. Now, if we want to, we can actually go in here and we can say uninstall Bootstrap, and it will actually remove that from your JSON package. So there we are. That's how you work with using npm, from getting started with a setup for a base initialization of your package, going through to creating the first package, being able to set up and control the naming convention for each of the items within the metadata that provides the instruction for the package, how you can then put in dependencies such as Express and Bootstrap, how you can install them and remove them, and actually do all of this through command line. If you have any questions, please let us know. So let's kind of jump into the Express.js framework. So Express.js is a really flexible Node.js and web application framework. It is just something you can spin up very quickly and build both web and mobile applications. Just a really great tool. I use it all the time for building up my own applications. The thing that's so great about it is it's really simple, so it's not going to be have all the functionality that you'd have in maybe a larger scale HTTP service. But with that said, it does come with a lot of functionality that allows you to not only create websites, but you can also do APIs and other routing calls. Very, very nice. So let's go through some of the features that Express.js have. So as I mentioned before, it allows you to build simple web applications, and that can be either a single page application or a multi-page application. It also allows you to do middleware requests and responses. So for instance, if you want to do an API and have that be part of your middleware, you can actually set that up real quickly. In fact, in the demo that we'll do later on, we'll actually be building out 4 different API calls that you'll be able to do, and you'll be able to see how you can use Express.js for that. And that in then turns allows you to be able to see how Express.js can help manage some of the routing of the different HTTP methods that you'd be using via URL. And then finally, it's just a great way of being able to dynamically test the work that you are developing. So you can actually build out a solution and test it right away in Express.js, have it in a single packet, and then once you get to a certain point, you can then check in the whole packet, even have it as part of your container, and then check that into your main project. And then if somebody else wants to then take on the work, they can then just pull that in. So let's kind of go step through a basic example. So here we actually have a full script for creating a simple hello world. And this includes installing Express.js, defining the ports it's going to run on, as well as a basic piece of code. So the first thing you want to do is actually go ahead and define how you want to install Express.js. And this is called the very first variable, which is requiring that Express be installed as part of Node Package Manager. npm will then pull in the latest version of Express. If you need to define a specific version, of course, you can do that. In this example, we're just going to pull the latest one. And then we'll go ahead with the second line, which will then install Express. And when you do it once, you'll see how quickly it installs onto your local development machine. The next parameters are actually a callback function. So if something actually happens when you go to the website where we're going to run our web application, you want something to pop up. And in this instance, we'll say hello world will pop up. The third block is all about where you would actually go ahead and host your code. So in this one, you'll see that the server is going to listen to port 8081. So that's what that function actually there defines. And then you can either put in a specific host address. In the demo, you'll actually see how we define that for localhost, but you can actually then point this to a production host environment if you want. And then the final line here is a command that actually sent a script to your terminal window telling you which port and which host that you are listening to. So let's see what that would look like. So here we see have our terminal window, and we're actually able to then run the hello world JS script that we just wrote. And then once we do that, it'll actually then post that we have an example app listening at, and here we don't have a web domain address, but we do have the port 8081. And in our browser window, it says hello world. So that's a quick breakdown of express.js. Now let's jump over and do a demo. So the first thing we want to do to get Express up and running on our system is we have to have Node.js installed. So we're just going to do a Google search to let you know where you can find Node.js. It's actually at nodejs.org. So we select that link, that will take us to nodejs.org. And there are two types of downloads. One is the current download, which has the latest features. And then there's a more stable version that if you're new to Node.js, that I'd recommend you to download. Next, we want to find a text editor, and we're going to go with Visual Studio Code, or VS Code as it's known. It's an open source solution from Microsoft that runs across all the leading platforms. This will default to our Windows platform, but you can run it on Mac OS and Linux as well. I really like it. It's a great code editor. It comes with a lot of extensions, and it's open source. Next thing you want to do is, because we're going to be developing APIs, we want a way to be able to visualize those APIs quickly, and a great tool is a product called Postman. Again, open source, and so you can go out and go to postman.com. Top right hand corner, you'll see a bright orange download button where you can actually go ahead and download and install Postman, and that will allow you to be able to access all of your APIs that we're going to be creating in Express. You can actually use other tools such as Apogee as well for visualizing your APIs, but this one's just great to get you started. So let's go ahead and open up VS Code, and we want to go ahead and open a new folder where we're going to have our project. We're going to, just for our demonstration here, we're going to put this on the desktop. You wouldn't normally do this, but it will work fine here. And we're going to create a folder, and we're going to title the folder Node Express, and we'll select that folder. And that now becomes the root folder for our project in Visual Studio. We don't really need the welcome screen anymore, so we're going to get rid of that. And one of the things that is great about working with VS Code is that you can actually have the terminal window up and running as well. So let's go ahead and open that so it's running at the bottom of our screen, and this gives us a little bit of space. And the first thing we want to do is actually convert the folder we're in actually into a project running Node.js. So we're going to use npm init, and that will actually initialize the project. We have another video that explains how to use npm or Node Package Manager, and you can go ahead and find that in our library here. But as we go ahead and we do that, you'll actually see that it will create the default package JSON file, which has the name of the folder is the default name of the package. But you can actually go in and edit any of these documents. We want to create a default file called index.js. This is where we're going to write most of our scripts that allow us to work with Node.js. And the first is writing a script that allows us to install Express, and we'll use the Node Package Manager to actually pull and install Express. You can default to specific versions of Express if you want. We're just going to go with the latest one, so we're just going to put in Express, and then we'll go down into terminal window and say npm install --save Express, and this will install Express so we can actually test out the code we're working on. And this will take just a moment to install. Great thing we're working with Node Package Manager is that once we've finished with our package here, we can actually wrap it all up and send it over to any other developer that we're working with, and then you can actually run the package and actually have exactly the same code installed. And there we are. We have everything installed and ready to go. We can see we actually have all of the modules installed. You see that we actually have Express installed as well. And we also want to then make this an app. And then we'll do app listen to port 3000. So this is by default, we're going to be running from our local host, which is HTTP server running on this test machine. And we're going to have Express for this project run on port 3000. And once we actually run the script, we'll actually post into the console window a piece of text saying server started on port 3000. So we're going to go ahead and save this file. A lot of Control S to save these files. So let's go into localhost in our web browser. So localhost colon 3000, and you'll see nothing has been reached. That's because we actually haven't done anything to initialize the script. So we want to come in and we're going to go node index.js and hit return. And as you can see, now we have a message in our console window. That means that, yep, there we go. We actually have everything up and running. So we can actually see that the service is running. Not a very pleasant message, so let's go ahead and change that. So let's change that to app get and acquire res. And so if it uses the get message, let's change what we'll print, and we'll type hello there, exclamation mark. And we save that, and we refresh the screen. Oh, nothing happening again because we didn't run the script. So let's go back in and we'll run the script node index.js. And now what you'll see is if we refresh, there we are. We have our new hello there message. All right, well, let's actually start building some APIs in this environment. So to be able to build the APIs, we want to be able to pull content. So we're going to actually create a new file called users.js, and we're going to go ahead and create a users JSON packet. And a JSON packet is essentially an array. Consider it like a small database, and in this array we're going to have 4 objects. Each object is going to have 3 pieces of metadata. We're going to have an ID, name, and email, and there'll be ID 1, 2, and 3, and then you'll see that the names will be John, Smith, and we'll make up a couple of others, just kind of giving them arbitrary email addresses. It's just for our demo here. Let me grab this, copy it, and kind of speed up the script writing time. There we go. And let's just change what we need. One of the things that's nice with working with Visual Studio Code, VS Code, is there's lots of plugins, and so one of the default features is that if you select a variable, it'll actually look for the same variable in the script. So you can, if you need to, you can actually change them all at once. But we don't need to worry about that right now. We're just creating a JSON packet. So we have 4 items, ID 1, 2, 3, and 4 for John Smith and Jack and Chris. All right, so that's our array string, and we're going to then make sure that we can export that as users. So we can actually now, whenever we select the term users in our scripts, it'll actually pull in this packet. All right, looking good. Now let's go over to our main index.js file, and we're actually going to go ahead and we want to store where the API is going to be. So we're going to create a folder called routes, and then a subfolder called API, and then we'll call a file in there called users.js. So as we're updating our scripts, we know where to pull the data from. It's just a standard way of being able to pull out the values. So in here we're going to say, in this instance, Express is required for our scripts. And we're going to also say that router within Express, router correct naming convention. and the script is case sensitive. We'll also want to create a value later on that will have a unique ID. So we're actually going to pull in a UUID package that will actually then allow us to install unique identifiers. So we can use Node Package Manager to install UUID. Again, this is a great example of how you can go from nothing to something very quickly with Node.js, because we installed Express, we installed UUID, and we're off to the races. So let's have users require the path for where our API is going to be located. All right, so let's do a basic get, which will be to pull the records. I'm going to have it pull all the records. So router.get, and we're going to require it to pull all of the records in the JSON packet that we created. So there should be 4 items that come back. Save that. Looks good. Make sure that users is consistent. There's our JSON packet. And yep, everything looking pretty good. All right, let's go back to index. And we're going to switch out this function here from just a generic get with a generic statement to actually being able to pull in the users. So we have to go app, use express.json, app.use URL encoded, extended, false, app.use API users. So we're going to be pulling them all from the same location. Require, and where we have our API scripts. Okay. And then let's go ahead and open up Postman, because we're going to actually use Postman to actually show us what the results look like, because right now the results won't show up appropriately in our browser window. So Postman, again, is just a API management tool. If you used Apigee or other similar tools that are on the market, MuleSoft, you'll see it's very consistent. Again, this is open source. And what you want to be able to do is you can actually go to the path where the API is stored, and then you can use all the different types of commands within your environment to be able to, test out the scripts. So let's go ahead and create a new project, a new request, and we're going to go with the default get, but there's actually quite a lot of different commands we can use. And these are just HTTP commands. And we're going to type in the request, and in this instance, it's going to be, let's run our script first. Do we need to run our script? I think we're good. Let's make sure we're exporting the data correctly. Okay, so we want to run our script, so let's do node index.js, and that will run the changes that we just created. So we can now come over to get, we can select API, localhost :3000 /API users. And when we do, that brings back the JSON package with our 4 entry points. There we go, there's all 4 of them. So that's your first action. Now let's kind of get this a little bit tidier. Let's actually go in and see if we can filter by ID. So we're going to go in and we're going to modify our script. So it's going to be route, and then we're going to put in the filter, and in this instance it's going to be ID, which would allow us to be able to just put a backslash against the end of the URL string we just had and put in a number or a unique identifier, and then that will actually then allow us to pull in that unique record. Pass the data. Okay, so found. I'm going to take the JSON and print it. So we're going to filter here against user ID and then publish the results. Else, if it doesn't work, then we'll just have a generic error message. We shouldn't see this though in the demos we're creating. This is just good practice. So save that. And let's go ahead and rerun our node index file against that folder. And now we can actually come in here and we do \1, and that will give us just one record. And we could change that to 2 or 100 in this instance. And if it's 100, we'll just get a bad request error message. There's 2. All right. So that's get. So we've been able to pull all of the records. We've been able to filter against one specific record against a specific parameter. In this instance, it was ID. So let's go ahead and create a new user. And so what we're going to do for this is we're going to use the post command from HTTP to actually push and post data into the data source. The data source is our JSON packet, which means that we'll have to then push a new record into the JSON package using our array statements, because JSON is just essentially an array. And so we're going to post, and when we do this, we have to create a unique ID. So this is where we have to reference the UID. I'm going to do a v4 unique ID, which will be 4 groups of 4, so it'll be 16 characters. And then we'll have name and email we'll post. Okay, looks good. Okay, so if new user, I'm going to put .name and new user .email, and then we want to return the results. Okay. Right. And so users dot push. So we posted, which is a HTTP statement, and then pushing into the JSON packet array. Okay. Okay, it's looking good. All right, so I think we're good. Let's go ahead and rerun our script, nodeindex.js. Now allows us to do that. So let's go over to Postman so we can actually connect to the URL. And we're going to change the HTTP statement to post, and get rid of that. We'll go back to users. Now, if we just do this, nothing's going to happen. So we actually have to go in and we have to update the body. This will be the content that will be passed through, and we're going to go through with a raw statement here. And we're going to do JSON. This will be, that's the packet we're sending. So let's go ahead, and the records we want to update, we only have to update two, which is one is name and the second is email. We don't have to do an ID because we're using UUID to generate an automatic one for us. And we're going to create records for Steph, and her email address is steph@gmail.com. Yep, looking good. Okay, so let's go ahead and send that. We sent it. And if we look at the bottom, we can actually now see that we have 5 records. So a new one's been added. We have our unique ID at the top. And then we have name and email, which are the ones that we just created for Steph and steph@gmail.com. All right, so that's posting. Now the next thing we want to do is to update a record. So that means we need to select an ID and then be able to update the content. And for that, we're going to use the HTTP put command. So we'll use ID as our way to be able to filter. And then we'll be able to update against that filter. So construct found equals users, and then we'll have that going against users ID, so we know how to get the correct record, and then pass the record back onto the screen so we know what we're editing. So if found, I want to update the user, and I'm going to go that pull information from the body for what will be updated. And for each if user ID, and pass the integer. Okay. So this is our values to pass against the ID. And in this instance, we'll make sure that we're updating the values of username. So if we are updating user and we're just updating the username, we want to make sure that that's the value that gets updated. And then we also want to do user email. We don't want to update the ID because it's going to remain unique and consistent. Okay, and we're going to make sure that everything is pushed to the JSON package. And then we'll also have a message saying that the field has been updated in the JSON package. Okay. All right, so we'll run that script again. And looks good. So let's go to our folder. Let's change the HTTP post. Let's put it as get. just so we can see that we have all of the values in the array from the JSON packet. And now we want to select put, which allows us to update just one record. So let's go ahead and select one record. We'll select ID1. So we have one record. We can go ahead and for name, we can change this. So let's go ahead and change these. So now you see that the email has changed. So we have Steph as the new account. All right, our final API that we're going to create is to delete an account. And in many ways, it's actually a very basic API because all we're doing is we're grabbing the ID and then we're saying that all the associated records with that ID within that row, as it were, in the table, just to delete the whole row. And so we want to use, again, our ID as the unique value that we're pulling against. So we're going to, if users are found, and we're going to filter those users. I'm going to do that filter against user ID. Pass that. And then go and post a message to our JSON packet saying user deleted. And our generic message if things fail. Okay, let's save that, and we'll see. We're going ahead and we're just deleting the record now, and we're going to do it by filtering against the unique ID, and then it will then just eliminate that record, and we'll pass the message that it has been, the account has been deleted. Okay. So save that. Let's go run our script. Node index.js. We're good. Okay, let's come over here and we're going to show that we can pull any of the accounts. So let's just take one of them. One, I think that's good. So let's go ahead and we're going to change the HTTP command to delete. And we actually have to select an account, so we just do one. When we do that, it'll actually delete that record. And here we are. It says that the user has been deleted, and we now only have 3 records in the JSON packet. And we can pull all the records, and you'll see that there's only 3. So being able to pull all the records from a JSON package, we'll be able to create a record, update a record, and delete a record. And we can just step through. So here's our JSON package that we created originally. Again, this is just an array. It's just a different way of setting up the array. And then we have our index files, which identifies what are the apps that need to be installed and where are the APIs going to be serviced out of. And that we're going to be doing this on the port 3000. Again, these are additional tools that we need to make sure that we have up and running in our script. And so the first script was to get all the records. The second was to filter against a user ID for just a specific record. And then for creating a record, we actually went in and we used the UID tool to create a unique identifier, and then we posted in the data for the new records. We did something similar with updating the record. We didn't have to update the user ID. We just had to update the values in the two fields that we needed to be updated. In this case, name and email. And the final step was to go ahead and delete a record. So these are all APIs that you can now pull into your own applications. So you can use them in web applications, or you can actually go ahead and use them in other applications, such as mobile applications, local applications, other scripts. And this really allows your application to become more scalable and more useful. Hello, we're going to go through and do our demo of building a RESTful API with Node.js. So the first thing we want to do is go ahead and install all the correct pieces of software. We're going to start with Node.js. So let's do a Google search on Node.js, and you'll find that Node.js is at nodejs.org. So we select that link. And that's going to take us to the Node.js website. There are two versions of Node.js you can download. There's the stable version, and then there's the latest version. I'd go with the stable version. You'll find it available in Windows, Mac OS, and Linux as well. And if we go to the next piece of software, we want to go ahead and install the text editor of your choice. I'm going to use Visual Studio Code, VS Code. It's an open source solution. It works on all leading platforms. Works really well. I like it a lot. Microsoft did a good job with this. I also really like it that it's open source. But there's lots of extensions you can get for VS Code. So it's a great text editor. And we'll also need Postman. Postman is a tool that allows us to be able to view the APIs that we're going to create. So let's go ahead to postman.com. And again, it's another solution you can download for free. And so we're going to go ahead and select the download button. And it will automatically detect which OS you're on. So in this case, it's going to be Windows, but you can also get Mac and Linux as well. So we'll go ahead and download those. And once we have everything installed, what we're going to do is we're going to create a project in VS Code. And that's actually really easy to do. All you have to do is create a folder. And we're going to do this right off our desktop. And we're going to call the folder Node REST API. And we're going to select that folder. And you'll see on the left-hand column that we have the new folder that we created. We still have the VS Code welcome screen. We're going to get rid of that. We don't need that anymore. So let's go ahead. And one of the things I like with VS Code is you can actually toggle the terminal window. So let's go ahead and open up the terminal window so we can actually run that at the same time. And so we're going to move our cursor to the folder we just created. And there we are. You can see that. And what we're going to do now is we're going to initialize this with Node Package Manager to make this a package. And it's going to go ahead and we're going to ask for a name. We're just going to go with the default. So we're just going to say yes, yes to a couple of these. Yep, enter, 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 enter. And is this okay? Yep, enter. All right, so now we have a new file, and this is our JSON package. It has all the defaults in it. We can go in and modify these if we want to. No need to for this exercise, but you may want to for the solution that you're putting together. And we're going to create a new file called index.js, and this is going to be the reference file that's in the JSON package for npm. And here we're going to put in our solutions that we absolutely have to have for this to run. So we're going to install Express, and Express is a web service application, but it's very flexible, and one of the things that we're going to use it for today is build APIs. So in our terminal window, we're going to type npm install --save Express. This will install Express locally on our machine. And it takes a few minutes, but it's going to go and download all the latest features This is going to be the latest version of Express. You can, if you want to, specify a specific version of software. For these examples, there's no need to do that. So you'll see that everything has been installed. If we expand the Node module, we can scroll down and indeed, yep, there we are. We see Express has been installed along with some other pieces that are useful. All right, so that's our first piece. The next is we're going to define our app, and our app is going to use Express. And we want Express as a local host on our local machine on port 3000. So we've identified port 3000 as the default port for our application. And we are going to now create an array for some movies. And we're going to have ID, title, director, and release date. Inception, great movie. And director, Christopher Nolan. And that was released in 2010, yes, 10 years ago. Okay, so we're going to do a couple of items here, just so that we have more than one entry in our array. And array is a JavaScript. You can think of it as a very simple table. It allows us to have structured data. You can also do a JSON file. You can also connect to a database, MongoDB or something like that. 2019. Okay, so we have two movies in our little array. That'll be more than enough for right now. Key part is that we have a consistent structure for the array of ID, title, director, and release date. And so we're going to create two APIs. One's going to be a get API where we'll get the list of the items in our API, and the second will be a post where we'll be actually pushing in a new item. So let's go ahead and start with the get. And what we want to do is we want to select get/movie, and we are going to have this run as an API. And so what we'll do is we will test this in a moment. This will be running from our web browser. Actually, we'll probably open up Postman and run this through Postman. So, okay, that pulls all the movies. And we'll do another get in a moment where we'll filter by movie ID, but let's just get them all for right now. And we are going to listen on a server port. In this instance, it's going to be port 3000. And we already had defined the port as a variable earlier, so we're just referencing the variable, and the port number is listed at the top in line 4. Just a text string that's going to get put to the terminal window, and it is going to dynamically grab the port, the value from the variable from 3000, and place it in our text string. Easy. And we want to save the file, and now we're going to go ahead and run it. So we're going to do node index.js. That runs the script and tells us that we're listening on port 3000. That's great. That means now that we should be able to go into Postman and grab the data from an API. So here's Postman. If you've not used it before, it's a great tool for being able to manage APIs. Strongly encourage you to have a go with this. So we're going to get the get command. And if you've done any applications, web applications, you've probably used get and post for the data that you're pulling and pushing from forms online. Same principle. So we want to go ahead and we're going to go and grab get. I'm going to type in localhost, and it's going to be :3000/movies, because that's the name of the file. And we're going to hit send, and what we get as a response is the data in our query. Sorry, in our array. Here we go. So there's our array, and the data values have been pulled back by Postman. That's great. So now we want to go ahead and add a movie to our array. And we're going to do that. We're going to use the post command, and get and post are HTTP commands. And so we're going to use movies, and in this instance, we're going to push the value into our list. So construction movie requires, we're going to need a structure here, and that structure is going to be the information that's in the body, and then we're going to push to the log, our terminal window, and we're going to push. So here we're using push, and that's a term for arrays within JavaScript where we push the data into the actual array itself. There are lots of ways of being able to control data within an array. If you're new to arrays with JavaScript, I strongly encourage you to learn more about them. There's just an awful lot you can do with them. And then we want to have a validation message come up on the screen saying, yes, movie has been added to the list. So we'll save what we've just created. If we don't save it, it won't show up. And then we're going to rerun the node index.js file. You can see this is, we've created here already an API that allows us to pull and push data in and out of a variable. Okay, so let's go back, and we're going to change the header from being get to being push. So we're going to use, not push, post. So we're going to select post, and then what we want to do is the value inside of the body. And so let's go over, and we want to select body. And we're going to put in text and select JSON. So it's going to be structured. And so here we will essentially copy the structure we have here. So let's go ahead and just copy these elements. And we have to give it an ID because we don't have an auto-generated ID. So we're going to make this ID 3. And it's going to be a number 3. And then we want to put in title. New movie. And we'll put in director. And we'll have this as, I don't know, new director. Not very creative here today. And then we need to put in a date. So release_date. And let's just put in a date. Today's date will be fine. Just so you know that we're not formatting the date column. So let's go ahead and we'll select send, and this will actually go, and we can see below, boom, movie's been added to our list. And we can go back and let's go ahead and validate that. So we're going to change from post to get, use the same, and now we go to below. Oh, looks like we put an error in our formatting. So let's go to parse the JSON, and we'll parse it using Express, and this will clear up any formatting issues. So app.use express.json, express URL encoded extended false. And this should help us pass our value. And then we'll rerun that script. Make sure you save the previous file, otherwise it won't run the new script. All right, looking good. So let's go back and let's go back to our localhost 3000/movies. And there's only 2 values here. So what we need to do now is change from get to post. We'll go to body. And what we're going to do is we want to have raw JSON. And what we want to do is capture the values that we have below and insert this file into this new JSON packet into our array. We can actually just copy that. It's a little bit cheating, but it's the main same. So let's go ahead and get everything consistent. And we're going to change the number to 3. We're creating a unique title. Actually, sorry, a new title. It doesn't need to be unique. Just the ID needs to be unique. So title new movie. New director. We'll change it to new director. And we'll change the date. I'm not doing any formatting on the date, so it can be any date, any number really. Hit save. Movie's been added to our list. Woohoo! So it's been added. But now let's go back to get and let's see if we can actually see the third entry. And scroll down, and there we are. We've actually pushed that JSON package into our array. So we now have 3 items in that have been added via our API. Okay, so now let's go ahead and search our movie database. Yes, we only have 3 entries, but we want to be able to. So we can do that by using the get command. And what we'll be doing is we'll be validating against a specific ID number. So we have 3, and we're going to validate against just the ID number. In this instance, the way to do it is through the URL. So beforehand, we had localhost :3000/movie. Now we're adding in /movie/ and then whatever number after that will actually filter against the ID. And that's essentially what we're doing here right now. So we're going to go into if movies.id. Again, we're using the ID value to actually pull from our array list. With my variables and arrays mixed up here today. And then once we actually have the value, we'll actually post back as a JSON packet. And if we have any errors, then what we'll do is we'll throw up a message movie not found. So there we are. We're going to pull against an ID. And we should be able to then pull that up through Postman into our terminal window. Again, the reason why we're using Postman is that this is actually just showing the values going back and forth. We're not having to render a whole web page. It's extremely fast, very efficient. All right. So we saved and reran our script. All right, let's go back. And what we're going to do is we're going to change the value. So we're going to hit send. Here we are. We see all of our movies using the get command. Now what we're going to do is we're going to use a filter on just ID 2, which is the Irishman. So do /2, and there we are. We have just the information on the Irishman. So now you can see how you can create a simple search. All right. So the final action we want to do is to delete a record in our array. And so we can go ahead and do that. And we're going to use the delete command to actually do that. So we'll be able to push in a record. We've been able to view records, filter against records. Now we're going to go ahead and do delete. And so we can do app delete, and then we're going to filter by specific ID number. And when we do this, we'll actually then, when we put in the URL path, which will be localhost :3000/movie/ and then the ID number. So in this instance, either 1 or 2, probably use 2. That will then delete from our array the record for the Irishman. Let's save our files. I do the shortcut, a keyboard shortcut of Control+S to save files on Windows, or Command+S on my Mac. And once we've deleted a record, we want to send a message saying that the movie has been deleted. All right, so we want to go ahead and let's just check our code. Looking good. Save our file. And we want to rerun the index.js file. Yep. Rerun. Okay, let's go to Postman. Let me grab the delete. So again, we're filtering against a movie ID, and then we'll delete that ID. Okay, so we went against the Irishman, and we hit send, and there it is. Now we're going to change the command to delete. So we hit 1, we'll actually delete Inception. The movie has been deleted, it's great. And let's go ahead and grab use get to pull in all the movies that are listed. And it's not going to find movie number with the ID 1, it's not there anymore. And if we get all the movies, we see we only have one movie, and that's The Irishman. And so our delete function has worked. There we are. So we've installed Express. We're using Express to build all of our applications. We have our app running on port 3000. We are using Express to pass the JSON effectively back and forth. We have a simple array That array is then being used to create an API to pull the details. And then we're being able to add a movie, then search for a movie, filtering against an ID. And then we can actually finally go ahead and delete a movie. All this using express.js. Today we're going to be covering Node.js authentication using JWT or JSON Web Tokens. So let's get started. So why are we going to go down this path? So let's cover the key things that you need to be asking yourself, such as what is a JSON Web Token? What is the value of using a JSON Web Token? And then what does the actual structure of the JWT look like? And then let's go through some use cases of where you'd actually use JWTs, both in the enterprise and in the real world. And then finally, we're actually going to go through a demo on how you can actually install a JWT using Express and Node.js. So let's dive into what actually is a JSON Web Token. So a JSON Web Token is actually based on an open standard. It's one that you can actually go ahead and research, and it allows a definition of a compact, self-contained way of being able to securely transmit information between parties using a JSON object. And a JSON object is a JavaScript array, and it's very compact. It's a very tight way of being able to send data back and forth. The thing that's great about using a JSON Web Token is that the information itself is encrypted, and it can only be verified and trusted through a public-private key pair. And we'll get into that about how you can actually get to those. So, why would you actually want to go ahead and use a JSON Web Token? Are there other formats that you can use? Well, yes, there are other formats you can use, but what's great about a JWT is that it is a great way to be able to pass data from HTTP servers. So if you're building a web application and you have a web application where you need to pass authentication of it, using a JWT is a great way to be able to do that. So for instance, you may have a number of enterprise applications that run across your cloud environment. You may have some enterprise applications that run in your data center, and you want to have people come in, such as your employees or your customers, authenticate once and then be able to have their ID transition from one to the next. JWT is a great way to do that. The content is extremely secure, and we'll get more into that in a moment, but it is the highest level of security you can have right now. And the final great thing about working with JWT is that the actual tokens themselves are very well documented, and so there's actually a lot of passes that you can use. So being able to add in JWT into your application is very, very easy to do, which makes it very easy for you to actually implement at a large scale authentication and authorization. And so authorization is a key word there. That's something that you're probably coming across a lot. Instead of just being able to identify who you are, we want to be able to authorize what you have access to. So let's have a look at the structure of a JWT. There are several key elements. The first is the header, and that's actually going to break down what kind of token it is. By default, it's going to be a JWT token. And what is the signing algorithm? So SHA-512 is a very complex and secure algorithm. Certainly the one that I would recommend that you use. You can even go higher than that, but SHA-512 is a great place to start. And then you have the payload, and the payload is the information that's been actually encrypted within the web token. So in this instance, we have a name, the admin type, subname, just really you can put whatever kind of information you want in there, as long as it's applicable to the service that you're passing the data into. And then you have your signature, which is encoded header and payload with the algorithm that you've sent. So in this instance, it's SHA-512 algorithm. So let's look at some of the use cases that you'd have for JWT. So a couple of use cases would be authorization. So say, for instance, you have a application and you want to be able to authorize somebody to have access to different parts of that application. A JWT is a great way to be able to encrypt that data and be able to pass that data back and forth. Examples would be jumping from different parts of Office 365 and being able to have access to different features within the system. And then another area would be if you're doing information exchange. So if information is being securely exchanged from one person to another. So a blockchain scenario, a multi-distributed environment where you want to be able to have a way to be able to securely transmit data back and forth and know that that data is being encrypted is another good example. So with that, let's take a pivot and we'll go ahead and we'll look at creating a demo using our standard stack of Node.js, and we'll use Express and Postman. And these are tools that you may already be familiar with if you've seen other videos that we've created in this series. And we'll go ahead and create a JWT token. So let's go into our demo of how to create a JWT JSON web token. There's going to be some tools that we need to get started with. Node.js is the first, so let's go ahead and find Node.js at nodejs.org, and you can either download Windows, Mac, or Linux code. Obviously, you'd install the one that would be for your operating system. The next tool that we want to install is a text editor. We're going to use Visual Studio Code or VS Code. Go to code.visualstudio.com, download this. This will run on Mac, Windows, and Linux. Really great text code editor. And then we're also going to use Postman. Postman is a tool that allows you to access and view APIs that we'll be creating with Express. And you go to postman.com, hit download. And again, there's versions of Postman for all leading operating systems, and have those installed and up and running. So we're going to go ahead and let's open up Visual Studio Code. And we're going to start by creating our project. So let's go full screen on this, get rid of the welcome screen. And let's go and open up a folder where we'll actually have our project. We're going to put this on our desktop for right now. Let's go create a new folder and we'll call this Node JWT for JSON Web Token. Select that folder. And we're going to want to go ahead and use npm to initialize this folder for Node. And so let's get rid of the welcome screen again. And let's go ahead, and one of the things I love about VS Code is you can actually run the terminal window right from in here. So let's go ahead and select npm init, already knows to pull from the folder that we're in. And we're just going to select yes here in a second for our, let's go ahead and create that. And you'll see that the packet has been created. And there is a JSON packet with just default information about the npm package that we created for Node. And we're going to go ahead and create an index.js file. That's what we've been pulling from the package. And the index.js files, we're going to actually write all of our code. And what we want to do right now is install Express. And Express is going to be used to create the APIs that we'll be able to test our JWT against. And then we'll also want to install a JWT file. So let's call this JSON Web Token. And from our terminal window, we'll just go ahead and install both of those. And do that by typing npm install --save. And then we're going to put Express and JSON Web Token. Express and JSON Web Token. And we'll just go ahead and let those install. It only takes a moment for those to get installed. All right, we're up and running. Okay. So let's go ahead and start bringing in some of our apps. So we're going to create an Express app. And we're going to use the get HTTP header to have everything go from the, we're going to actually have everything running on our local host and we're going to run everything off port 3000. We'll do that in a moment here, but we'll have everything running off a sub folder called API. That's where our web application is going to be running from. And we'll put in a message that, hey there, to show that everything's up and running. Okay. And save that. And save. You can do Control+S to save your files, as you can with a lot of Windows applications. I encourage you to do that a lot. So let's go ahead and open up Postman. We're not even going to go to our web browser on this one. And we'll open up Postman. Takes a moment to run the first time. Here it comes. And Postman, again, is a tool for being able to manage API calls. So you don't have to write a script. So here we are. And we can go in here and that's where we're going to write our script, but we have to do a couple of things first. Let's get everything running. So we want to listen for port 3000. That's where we're going to run everything off of. And in the console log, we'll actually throw in a message to confirm that we are running on everything is up and running. We'll just say, okay, server started on port 3000. Again, we're going to be running everything off localhost, so you'll be able to see this. And this is, as you imagine, just a test environment. So let's go down into our console. We'll run this script, node index.js to run the script. It runs really fast, not a whole lot going on there. And we're having everything running off the API file. So let's go and we'll type in under our get localhost :3000 /API. And we hit there's lots of different HTTP headers we can use. We're going to use get for right now. We'll send that. And hey there, welcome to the API service. So to be clear, this is just an API we're creating right now. This is not JWT. We'll get into that right now. All right. So we want to be able to post data, and post is actually pushing data in. So we're going to go into, going to create a login screen. Again, this is all API, so it's not real, but you get the point. And then we can construct a user. And let's go ahead and what we're doing here is we're creating an array of a random user, and they can have a name of ID1. The user's going to have an ID value, which is 1, a username value, which is going to be John, and an email value of john@gmail.com. And then we'll make this a JSON web token JWT sign-in, and they'll have to sign in with their user. And this is going to use a secret key, which will be our hash 512 token. And we'll respond to the JSON with the token. Okay, so let's see now. Okay, and we're going to and this will be our post API posts. And what we're going to be able to do is we're going to jump from one app to another app, and you'll be able to see how we can move the token with it. And the message will read post created. All right. So let's just run that script. Index.js runs real quick. Okay. So if we come over here and we go to posts and hit send and say message posts created. Good. So let's go ahead and try that again. And we want to go to the login. So we're going from one app to another app. Select post. And here in the login, we should be able to request the token. This will be our GWT token. And we hit send, we should get our token. And here you can see the whole token is encrypted. It's that huge long line. It's very unique. And now we want to be able to go in and say, okay, let's verify the token. So we've gone ahead and we've created the token, but now we need to, as we go from app to app, we need to actually verify the token. So we're going to get an error message if we don't verify the token correctly. So we're going to put in a function to verify the token. And we're going to create a bearer header value, which will be the headers and the authorization for that. And if type of bearer header, we're going to either have it, if it's not correct, it'll be undefined. Otherwise, this bearer token, it will be split. And we're going to require the token for our bearer token. Else send status 403. Okay, so bearer token is what we're going to be calling against to verify our token. I'll show you how that works in just a moment. And this will be to authorize. And to authorize, we'll need to actually go ahead and use the token. So we can actually put in here. All right, so I think everything's looking pretty good. Oh, and if we get the error message, it means that we'll see the message forbidden if we don't put in the code correctly. So let's double check that everything is looking good. We're going to verify that the token is required. Okay. So if it is, then jwt.verify. And this will connect our token appropriately. And we'll be able to put that in as a part of our secret key. And if it is successful, Put in that message there. And we're also going to put in the authorization data. Yep, looking good. As you can see, a lot of the work is just making sure that everything is aligned up correctly. Okay, so let's run our code, node index.js. There we go, nice and fast. And we go in and localhost API posts. We'll change this to post. So this one API, which is the API posts, which is up here. We're going to hit send. And you can see that we have the error code forbidden has come up, which is what we were expecting, because we haven't been able to put in a secret key. And put in the comment there, forbidden, so as we're stepping through the code. But now what we can actually do is we can go back and we can grab the token. And here is our token below. And we just want the token itself, we don't need the wrappers. And copy that. Come over here. And if we write again, it's going to say forbidden, but if we go into our headers, we can put in authorization, and then the value, we'll do bearer, and then the key. And once we do this, we now get all of the data that we were asking for pulled back, which is exactly what we wanted. So you can see here how we can actually securely use a JWT to pass values back and forth across the application. Okay. And we hit authorization and we select that and approve it. Yep, we keep authorizing. So if you don't authorize, then you don't get the data. Okay, so we have everything against the API. And we have one application which is called API post. We have another application called API login. And we're able to move the data back and forth using our secret key and our JWT token. And we have everything running on port 3000 of our localhost server. And that's our demo. So first of all, let's cover why you'd want to go through this tutorial. So we're going to cover what MySQL is. We're also going to tell you how we're going to connect with Node.js and why you'd want to do that with MySQL. And then finally, we're going to do a demo taking you through all the steps on how you can actually do that kind of connection. So what is MySQL? Well, basically, MySQL is probably the world's most popular relational database. So if you think of relational databases that are table-driven, MySQL is arguably the most popular database out there for RDBMS systems. It is by far the most popular open source relational database. The entire database is written in C and C++. It's been around for a really long time. Again, it's open source, which is great, which means that there are no licenses or costs for actually using MySQL. And you'll find that companies of all sizes, from small mom and pop shops all the way up to massive global enterprises, are all using MySQL. So, why would you want to then take that next step of connecting Node.js with MySQL? Well, fundamentally, it comes down to the basics of the differences between the two products. MySQL is a database, and Node.js is an architecture framework for building out web applications. Again, with MySQL, it's open source. It's free to use. You don't have to pay anything. There are no licenses, which if you compare it with other solutions out there, is a big deal. MySQL, even though it is open source, is incredibly powerful. It's one of the more mature open source programs out there. I think Apache is probably arguably more, Apache web server is probably more mature, but MySQL is very close behind it. So it has had a huge amount of investment. This is not a solution that's only a couple of years old. We're talking about a solution that's more than 15 years old, very, very structured, very powerful, and you can do a lot of really good things with it. You can actually then build solutions with it using PHP, Java, really any kind of database, even other systems and other frameworks will allow you to interact with MySQL. And it just allows you to work with just huge amounts of data very, very quickly. So let's go through a demo of how you'd actually use Node.js and MySQL. So we're going to go ahead and we're going to get started by putting our Node environment together. So let's start by selecting Node.js and downloading it. So we'll go to nodejs.org. And there you have your options for Windows, Mac, or if you want to go for the source code, you can go ahead and download and install that. The next is to install XAMPP. And so we're going to go to XAMPP installers for a quick search, and that's on our ApacheFriends.org site. And here we have XAMPP available for Windows, Linux, and Mac OS X. And then finally, we want to go ahead and install Visual Studio. So Visual Studio is going to be our IDE, our integrated development environment. In this instance, we're going to use Visual Studio Code. If you don't use Visual Studio Code, it's a great free open source solution for being able to build applications. I'm a big fan of it, so I encourage you to use it. Go ahead and download, install that. And we have Visual Studio code up and running. So go ahead and we're going to open up a new folder. And let's go ahead and create a new folder. We'll just put it straight off our desktop here. And it's just for kicks and giggles. So we're just going to type in Node MySQL for our source code. And we'll open up that folder and select that. And so we now have this folder selected in our Visual Studio Code editor. And what we want to do is we want to get rid of the welcome page. We don't really need that anymore. And we're going to terminal window so we can actually see the scripts that we're writing. We're going to be using terminal quite a bit in this. So for instance, we're just going to test that we have npm installed. We do, so that's great. And we're going to go npm init, and that's actually going to set up our own node package module. And we can actually see that the JSON file for that package has been created. So we go in there, we can see that all the defaults are selected. You'll see that index.js is the default file that will be created. So we're actually going to go ahead and we're actually going to create our own index.js file, and we're going to add in some instructions into that file to actually install the correct software from the npm package. And the first thing we want to do is install Express, which is a package that's great for building lightweight web applications, not mobile applications. I suppose if you're doing a responsive design, then I guess it would be mobile. But in this, it's a web application environment. So we're going to put in the requirements for that, and then we're going to also go and require that MySQL gets installed. And you'll see that for both of them, we're just going to use npm's default commands for creating that, and we'll go down to the terminal window and we'll do npm install, and it's going to install the Express and MySQL environment. And as that installs, you'll actually see on the left-hand side under the folder, you'll actually see the files starting to be installed. So for instance, we have the node modules, and underneath that will be all the subsequent files that we need. And there we are. Everything is installed. All right, so let's go ahead and validate some of these commands to make sure everything is installed. So we're going to open up XAMPP, which allows us to go in and view and see that everything's installed. So we have MySQL installed, we have Apache installed, We can start and stop the services with XAMPP. Go ahead and do that. You can do this through terminal window as well, but the UI interface is really nice. So let's go into my SQL interface, and you'll see that we don't have any databases. These are all just the standard test databases, and so we have to go ahead and create one. And so let's get our SQL database connection created. So we're going to write const db equals MySQL create connection. And we want to connect to the local host in this instance. And user is just going to be a root user account, which is the standard user account that comes from MySQL. There is no password for the root user when you're running it locally, but I encourage you to change that as quickly as you can because you don't really want to have a password-free environment. And now we want to be able to then connect to the MySQL environment. So we'll write db.connect, parentheses error, and we want to throw an error message if the connection isn't good. So if we do error, we will throw the error message to the log window. And if we don't, then we'll write MySQL connected. All right. And then we want to connect that to our Express app. The next step we want to do after we made our connection is to go ahead and create a database. So we're going to do both steps at the same one. So we're running the script right now, and then we'll run the commands in the terminal window so we can actually create the database. And so we're going to go ahead and we want to create a database. And let's write let SQL equals create database. And we're going to call the database Node MySQL. You can call it whatever you want, but this is just a Node MySQL script. So db query SQL error throw error message res.send database created. So we'll throw a message saying that database has been created. Let's go save that to demonstrate that we've connected and we've created a database. So let's go ahead and we'll do node index.js to run that, and we've connected to MySQL. That's great. Good first step. And then we'll go to the window and we'll go to localhost 3000, which is the default connection. But what you'll see is that we've actually created the name of the database has been changed to Node MySQL. So we've got an error message, which we expected. And so what we're going to do is we're actually going to go ahead and we're going to say we want to listen. And if the error message comes up to 3000, then in the console window, we want to put a message of server started on port 3000. So let's try that again. Node index.js. Yep, and server has started in port 3000. We'll refresh that. I'm still getting an error message. And what we want to see is, let's go ahead and see our database hasn't been created. So let's go and connect to database. The database is, let's go ahead and click create DB on port 3000. All right, so by doing that, we write that command and that function, and that goes ahead and creates our database. And we'll actually see that we have now Node MySQL has been created, which is a great first start. Now we have to go in and create some tables because we have no tables in there. All right, so let's go down and let's go ahead and create a table. So what you're seeing right now is that we're using the index.js environment within a package on Node.js to actually create and control everything that we want to see in our windows. So all of the work that we're doing for creating a table, for creating the database, for initializing the core files, it's all being done through JS. And so here we are, we're going to create a new table. We call it it's going to be called the employee table. And so once we run the command create employee, it's going to create a table, has the employee fields, which is going to have an ID, which will be an integer that will go into auto increment. They'll have a name field, and we'll also put in a designation field. And we'll have a primary key as well. Keep it very simple for right now. And let's just put our DB connection so that everything connects effectively. Okay, so if everything goes correctly, then we'll have the message employee table created. So let's test this out. And Node.index.js. Make sure that the data we have now actually a database field that we can connect to. So we've got Node MySQL, so we're connecting to the correct database. Otherwise we get an error. And then we'll try that again. Yay, we connected to the database. So the database has the name. And because we've got Node MySQL, there's no fields in there yet. So let's go ahead and put in create employee for the fields, and let's run the function that creates the new table. And then voila, we have a new table. And so the next action we want to do is actually populate the table with a record. So this starts becoming familiar. So we're now going to put in a single record. We'll call it employee 1 for right now. And we'll write the function employee 1, and when we run that function, it'll actually go ahead and it'll actually insert the record into MySQL. And the name will be Jake Smith, and the designation will be a Chief Executive Officer. Certainly encourage you to put your own name into this, make yourself your own CEO, because why not? And we're going to make this as an insert record. I'm going to insert into the employee table. And we're just using some basic SQL scripting here. And what you'll see actually with Visual Studio Code is that it's actually providing a lot of prompts to make it easier to write your code. Microsoft is looking to actually add some AI to Visual Studio Code to actually start auto-completing scripts, which will make it even easier to write your code. All right, so let's go run node index.js. We see we've got everything connected, and we'll grab the function employee1, and let's go over to our express site. Let's just go and we'll insert the command employee1. Employee has been added, and we will just validate this by going back to MySQL, and we'll refresh it, and you'll see if we click on the employee table, we should now have an employee in there. Yep, there we do. Jake Smith. Well done, Jake. First record. All right, so we want to be able to now select the employee. So let's go ahead and do that. And we want to be able to easily get the employee list. So let's use our SQL command and we'll do select star, which is everything from the employee table. So we're actually pulling everything from the employee table. We're going to query the database. Let's throw a message to confirm that the query is successful. We'll put everything in the console log results. All right, let's give this a whirl. Okay, so let's go and run our command. Localhost 3000, but get employee, and it says employee details fetched. Now we go to the console window in Visual Studio. Yep, there we go. We have now all the packet information, including the ID about Jake Smith. Okay, so let's go ahead and see if we can actually update the employee information. So as you can see, now we're starting to run into just our standard SQL commands. And so we want to be able to update the employee from a browser. And as you can tell, we're not using any forms or any other types of records. We're just simply interacting between the browser, the server, and the database. And the new name will be updated name. And we have to make sure we're updating the appropriate record. And we want to make sure that we're matching against ID 1. Right, so let's run that. And the JSmith is there. Now go and select JSmith :/1. We've now gone ahead and updated the JSmith information. So let's click on employee table, and we now see it says updated name. I know, not very creative, but it allows you to see a change. And finally, we can go ahead and delete the record as well. So it's going to be similar to update, but I'm deleting instead. I'm going to delete the record from the employee table, where name equals, where ID equals, sorry, and ID. And then we want to be able to show that the record has been deleted. Okay. Just like delete employee deleted, and we go to database. We can actually see from the employee table that there are no entries. The one only record that was there has been deleted. And so this shows you how you can very easily control everything from using your connection into MySQL right from Node Package Manager. You can create a table, you can select your records, you can then update any record that you selected, and finally you can delete any record that you want to be able to delete. So what we're going to do is, so what's in it for you? So in this presentation, we're going to go through three key things. What is MongoDB? How do you connect to MongoDB with Node.js? And MongoDB is part of the MERN stack. So we're going to cover what the MERN stack is and how it applies to Node.js. So what is MongoDB? So MongoDB is probably the most popular NoSQL database out there. It's cross-platform and very easy to scale. It's available on all cloud systems. You can also run it locally, which is what we'll be doing later on in our demo. But it's just a very flexible database environment for modern applications. It works on the concept of collection and documents. What you'll find is MongoDB was originally written in C++, and it is what's referred to as a NoSQL database. So this is different to a relational database, which is built up of tables with rows and columns. This is a NoSQL database, and it's simply a lot faster and more powerful for the work that you're doing. And you're able to use MongoDB very easily. You can actually go ahead and download it. We'll actually do that as part of our demo. So, why connect Node.js with MongoDB? Well, the reason why you want to do this is that MongoDB is a modern database. It's not restricted by the challenges of scalability that older relational databases have. It's really designed for building mobile applications and websites that scale into the millions and millions of users. So MongoDB, probably the most important feature is scalability. The performance of the database is phenomenal, and it is extremely highly available for the solutions that you'll be creating. So when you push it out your solution to the cloud, you can almost guarantee it's always going to be running. You also have the ability to be able to scale to very large, complex, multi-site solutions. In fact, one of the very first MongoDB applications I built was a multi-tenant environment, and it just worked really well. And you'll be able to easily deploy your solutions across Microsoft Azure, AWS, Google Cloud, etc. So, why do you want to keep connecting to MongoDB? I think probably one of the other areas that probably is often forgotten with Mongo is just the concept around big data. And when you talk about big data, you're talking about absolutely massive databases, and MongoDB is front and center for all of that. You can do your effective content management and delivery. It has an effective mobile and social infrastructure. So by that, it allows you to be able to build out solutions that can go to all modern day types of applications. And the data is actually very easy to manage through your central data hub. And then finally, being able to connect to MongoDB is very easy, particularly as there is a client called Mongoose that makes the connection extremely easy. So, finally, let's kind of look into how MongoDB is part of the MERN stack. So MERN stack is a JavaScript stack, and it's of JavaScript solutions that are built for modern single-page applications. And there are 4 key solutions in the MERN stack. There's MongoDB, which is your database; Express, which is your server-side HTTP environment; React, which is the solution for being able to create your solutions on the client; and then Node.js, which actually manages the whole environment. It's really an environment that's designed to make it very easy to be able to build out modern day solutions. So MongoDB is the M in MERN, Express is the E, React is the R, and Node.js is the N. So again, as you start working with some of our other videos that we have here, you'll be able to see how all of these tools really complement each other. So we've done an introduction on MongoDB. Really, the best thing now is to get your hands dirty by actually doing a demo. So we're going to go through a demo. What I would strongly encourage you, however, though, is that this demo really does build on a lot of the other videos that we've done in this series. You really do want to spend some time on the Node.js video, the Node.js for Express video, the Node.js for APIs video. Really, all of those videos help complement the work that you'll be doing. Those Linux, Mac OS, they're all supported. You can also get the original source code and recompile your version of Node.js if you want to. Now we're just going to install the Windows version. And the next thing you want to do is install your favorite text editor. I'm going to install Visual Studio Code, VS Code. It runs on all leading platforms, Mac OS, Windows, and Linux. It is open source. You can edit it. I like it because you can do an awful lot with it. Just a lot of extensions. It's just a great tool all around. So that's the next thing you want to install. And then we want to go ahead and we want to go to mongodb.com so we can install the MongoDB database. So you want to go to Software, Community Server, and you want to then select the MongoDB Community Server, which platform you want. and where it's going to connect with. And you want to select the download to install that. And that'll take a moment or two for you to download and get that up and running. Once you've done that, we want to go ahead and we're going to open up VS Code so we can start editing and the code that we need for our new solution. So let's go ahead and create a folder off our desktop that we'll use for MongoDB. So I already have a folder created called demo. I'm just going to select that. And then inside of there, I'm going to put in Node MongoDB and select that folder. And that's going to open up VS Code. It's going to have our folder in here. So we're going to get rid of the welcome screen. We don't need that. We do want to, however, open up our terminal window. So we're going to run that. That's one of the things that I really like about VS Code is you can actually have your terminal window or command line window actually inside the development environment you're working in. So you don't have to be jumping from one solution to another. And then we're going to initialize our package. So npm init for the folder that we're in. It's going to create our Node package manager. It's going to create our default package. And we're going to hit return. That's going to go ahead and start the process. And we're just going to go with the default settings that npm is going to give. So just hit return, return, return a few times, and that'll get up and running for you. And our entry point for the application is going to be index.js. Yeah, that's our JS package, and there we have everything. This is just the JSON package that provides the instructions that npm would use to pass the program. Now you notice that we have index.js as our leading file, so we actually have to add a new file here, and we're just going to call this one index.js. So we actually have a file that can be referenced. And now we're going to go ahead and we're going to actually put in our default application. So Express is going to be required. So we're going to make sure that that is included in our first line of our instructions. And then we're also going to have a path that's required. And we're going to require handlebars. And these are all part of our Express environment. And don't forget to save your file as you're going along. And we're also going to have Express PHBS. And this is going to be our Express handlebars. And we're all going to allow insecure prototype access. You wouldn't normally do this, but because we're running everything locally, it just makes it easier for you to actually get all the code in. And then we're also going to add in our body parser. And these are all the required solutions that we need to be installed when you're running this package. And so let's save the file and then let's go ahead and run it. So we're going to do npm install, and we do --save, and this will install Express. And we're also going to have an install path, handlebars, Express handlebars, and this is where we'll install prototyping. And we'll also have the body parser installed, and we're just going to run that. This will just take a moment or two to install. All right, there we go. So we have everything installed, which allows us to now start working with our scripts. So we're going to create an app in Express. And we're going to listen on port 3000. And we're going to have a message, then go to our console log. And we're going to have everything running off our local host on port 3000. So let's go, and we're going to select node index.js, and it shows us everything's running, which is good. We can actually test this in our web browser if we wanted to. Okay, so let's start working on our app. So our app is going to use body parser, and we're going to encode our request. And the goal here is we're going to create a file that's going to go back and forth to MongoDB. So body parser is going to use JSON to encrypt the content. And we're going to do a get command to get our results. And if you've seen the API video, then we did that here. In fact, it's probably a good idea to actually sit down and look through some of the other videos that we've created, such as the Node.js for Express, Node.js for APIs, and Node.js for Authentication before doing this video. We're going to create a default page, and it's going to say, welcome to the students database. The principles that we're putting down here, you'll be able to apply to any solution that you're creating with MongoDB. And so we want to have a simple action that we're going to put on here, which is going to be click to gain access. Okay, we're going to put in the path and where to get the list from. Okay. All right. So here is our basic web page that we're creating. Nothing fancy, but it's going to take you to a place where you can actually get all the content. Now, what we're going to do is we're actually going to go and pull the content from Mongo. So run this, and we can open up a web browser, and you'll see what it looks like. So let's go to localhost, close out these other tabs, don't need them. Localhost 3000. And there we see, welcome to the student database. Click on the database. And you click on, if you clicked on it now, nothing will happen. So, yep, nothing there. So let's make something happen. Okay. All right, so let's begin extending our app. So what we're going to do is we want to set the views. And we're going to do a join on our directory name. And app engine. So let's go for our views. We don't have an app engine yet, but let's go ahead and create a new folder. We can call that one views, and let's expand that. Actually, that should be okay. HPS. Express handlebars. And we're going to allow prototype access for our express handlebars. So with express handlebars, if this is new to you, it allows you to separate your content from your layout, which if you have developed with Swift for a mobile application on the Mac using Xcode, is the same principle there, but for a web application. So we're just putting out here some of our default environment settings. And we're going to set our view engine for handlebars. And just checking through our code. It's looking good. Okay, so that provides that. So let's create a new folder under our views, and this one we're going to call layouts. So again, this is where we are splitting our layouts. And we're going to have a folder called models at the root of our application, and under models we're going to put in db.js. So the db.js file is going to be where we put our instructions for our database. And so here we're going to go ahead and we're going to require to import Mongoose. And Mongoose is a tool in Node.js that allows you to connect to MongoDB. So we're going to require the use of Mongoose. And so we're going to do npm install -save mongoose. And that's going to run and install on our local machine. So we can actually test this out. And once we've got this installed, what we're going to do is we're going to start connecting to a database that we're going to call StudentDB. Okay, we're already installed. So let's go mongoose.connect. And we're going to call it MongoDB. And we're going to run this off our local host. So we installed the community version that allows us to run off our local host. And it's going to run from the port 27017. And we're going to call this one StudentDB. So again, with our application, we're splitting out all the functionality. So if you want to reuse elements, you can. So we're going to have a user URL parser. And we'll make sure we capture everything correctly. Okay, so if error, then we'll send a message to the console log. And we have either connection is successful, or if things go wrong, error in connection. And then if there is an error, then what we'll do is we'll have the error message posted. Okay. And then we're going to do require student.model. So this will actually pull the model we're going to create. And so what we need to do now is create under models, we're going to create student.model.js. And this is where we're going to do our instructions for our student model. So first thing we want to do is we want to import Mongoose, Express, and the student model. So we've got to let's make sure we have everything. Let's capture that. So let's go over to our student model. All right, so let's make sure that we have everything. So we want to have Mongoose. And I'm going to create a new variable called student schema. This will allow us to structure what our model will look like. And this will be a new schema in using Mongoose. And our new schema is going to be full name. And we're going to break down our JSON package. So we're going to put in the instructions for what the schema would look like. So we have the type, we have required, this field is required. And the second value is going to be email. Type string. This field is required. That's the message, error message you want to send if the field isn't filled out. Mobile phone number, this will be just a number. And we're going to have city, and the subtype will be, let's just make this a string. We're just going to try and keep this simple for right now. And this field is required. All right, so here's our schema. Looking pretty good. All right, mongoose.model. And connect this to our student model. So we want to go ahead and save that. Okay. Okay, a new folder, and this new folder is going to be called controllers. And we have a new file under controllers. And that new file is going to be called student controller.js. Let's go in and see what we're going to add here. So we want to import, make sure that we're running Express. So Express is required for our controller. We also want to set up a variable for router. So router express.router. And we want to make sure we're also connecting with Mongoose. So we have a connection to MongoDB. And we also want to make sure that we have connection to our student model. So mongoose.model and our student model. And this allows us to make sure that we have this student model pulled over effectively for our controller, for our student controller. Okay, so let's go to router, get, I'm going to render this. And student/add or edit. We'll come into that in just a moment. So we want to be able to view title, and this will pull in the insert student. And we're going to use, under our views, we're going to create a new folder. And this one's going to be called student. And we're going to create a new file. And this one will be add or edit.js. Oh, HPS, sorry, for our handlebar. So you notice we don't have to put the file extension. Node.js manages all that for us. So router.post. So this will be we're going to get our content, and then we're also going to post content. So the post will go back as part of our body, and there'll be an ID. So we want to then insert the record that we'll be creating. So again, if you've worked through the Node.js API video, then you'll start seeing that there's some commonalities here of being able to insert or update a record. And we actually cover that using just a sample JSON package. This really takes it to that next level. Okay, so we want to put in a new student record. And so be student, and we're going to have their full name is going to come from our body. And we're going to also capture the email. Essentially, we're going to follow the model that we created. And our mobile phone. Finally, with a student city. And then we want to save the record that we create. Okay. All right, so we're going to manage our error message. And we're going to put in similar messages that we've put in before. So we want to redirect to our student list. And we're going to go ahead and create that in a moment. So let's create a new file, student list.hps. So list.hps. And here, so what we do is with student list, that's actually going to manage then the controls for being able to display the records in the database. And then we'll put our message. If there's an error, then we'll put an error message there and ask it to report the error message. We're going to try and not do that. All right, so now the next step we need to go through is we want to call a function to update the record. And let's go ahead and we're going to update the records, and we do the student.find1 and update command. Okay. Okay, so we will redirect to our student list as needed. If not, we'll throw an error message to our console log. Yeah, looking good. And again, this is just an example, but something that you'll be able to do yourself with your own solution. And then we want to go back to our list to then render the records. All right. And here we want to put student, and then how we're going to find the record. We'll throw a error message to our console log. So as you can see, we always throw an error message to the console log. Error messages are really useful. Okay. All right, looks good. Save that. Okay, let's do another router, and this is we're going to do the router against ID. So allow us to get the content. So we'll be able to get the information by ID of the student. And what you can see is there's a lot of the work we're doing here is very repetitive, and you'll find as you create more modular code that it makes it easier for you to write your code and update and manage your code. Okay, so we're going to get our view title. We're going to put that into our document. Okay. All right, so our next router is we want to be able to delete a record by ID. And so what we're going to do is we're going to find our records, our student record, and we're going to find it by ID. And then we're going to do find ID and remove. Okay, so we're going to once we've removed a record, we're going to redirect to our list so we can show our student list. Otherwise, we'll send an error message to our console log. Okay, so I think we have what we need. Maybe there's one more thing. Oh, I think we need to. I think this is good. Okay, so let's go to our layouts, add a new file there. We're going to call this one main layout.hbs. And here we're going to put the skeleton of our web page together. Let's write this out. So we're going to put in our HTML code. And we're just going to keep this real simple. And our header. We want a title, and this is going to be students database. Oh, maybe we'll just call it students. So we now go to, we're going to try and find out Bootstrap 4. We're going to just grab that, and we're going to use Bootstrap to get started. And there are a couple of components. There's the CSS component, and then there's the JavaScript component. So let's just go copy the CSS component. And then we're going to just link that into the header section of our web page. So, and then here's an example of different components you can create. If you haven't used Bootstrap before, it's an open source framework originally developed by Twitter. Great tool. So here in our header, we want to put in the link to the CSS. There's that. And now we'll need to also put in our own styles. So we've got here some styles that we created earlier on for the work that we're doing. You can just paste those in. So we have a box style that we want to use that will extend the box style that you get with Bootstrap. All right, so we're going to start working on our body content. Class BG info. So this is actually BG info is a CSS class file from Bootstrap that you can use. And you have the ID of box. And again, we're going to do another class. This allows us for our table structure. So a little bit of knowledge of Bootstrap is great here. So what we're going to do now is we're going to put in the content, which we're going to call body, and this will show up on the screen. So again, we're pulling from records within Bootstrap. Dig through Bootstrap, there's lots of content there for you to be able to take advantage of. Okay. So now we want to be able to add or edit a record. View title. And the French brackets allow you to be able to pull records and content directly from the code that we're writing. So we're pulling title from insert record, and that's part of our router command. And then we'll put in our form. Which will be student post. I'm just going to do a basic form here, nothing fancy. We will put in the first record will be a hidden field, and this will be for ID. So we want to generate the ID. We don't want to have somebody put that in. And then we will put in our form elements. So we'll have, first will be a label, that'll be full name, and there'll be an input field. So it'll be text in the input field. Again, we're using form-control, which is from Bootstrap CSS. And then we'll have the full name and placeholder will be full name. So where we have name there will actually match up with the value that we're putting in our model. So here we have student full name. So we're matching everything up to the model that we created. Okay, so let's do this for our remaining form elements. And again, as you see, we can put this together really quickly. So we're going to put in form, this one will be email, and then we'll do mobile and city. And here we keep going. Put in form group. And we'll be able to have the type of tool for putting in mobile. So as you can see, because we're using just standard HTML here, you can actually reference external libraries such as JavaScript libraries for formatting the field that you're in, regular expressions, things like that. And let's put in our final value, which will be for city. And normally when I'd be writing this by hand, I would actually be copying and pasting sections of code and just changing the values as necessary, just to make it easier on myself. But here I'm just typing out everything for you so you can see the whole process. Okay. All right, so there are our values. Of course, remember, save your files as you're going along. Everything looks good. And we're matching up our values with our records. And we want to have a button that allows you to submit. We also want to have a button to select view all if you want to be able to view all of the records. Okay. Looking good. Okay, let's go back over to list. Now we want to be able to pull our records. So this will display the list of students. in a table. Right. Let's go ahead and format that table. So we're going to put together our format here, but then we're also going to add buttons at the bottom so we can actually add a record to the database, or if we want to add or delete a particular record from the database. I'm going to call this one create a new student record for our student list. I'm just going to type all this in for you. And you'll see how we put placeholders for the values as we put them in. These are our table headers. Okay. Putting our body content. And what we're going to do here is we're going to add in an element that allows you to create a row for each item listed. So if you have 2 or more items, they'll appear as an individual row on here. And again, what we're doing is we're pulling in the values to be able to pull from the model that we created earlier on. So this being the data that's been submitted, so we're going to have it pull in the value for the email, full name, and mobile and city. We're not going to show ID. So it's pulling out all of this data that we created earlier on. So we have everything posted into our list as documents. So let's go into a HBS file, and it's our list. Let's put in our file entry here. This will be for city. Then this is just a placeholder at the end of the list. Oh yeah, what we're going to do is we're going to add in reference for the ID. So if we want to edit the document, we can. And then we want to do the same thing if we want to delete the document. So href equals student, and then just delete. Now delete based on the ID. There we go. Passing that instruction over. So click, turn, simple. I'm going to ask them, are you sure you want to delete? If somebody clicks on the record, they hit cancel, then it won't get deleted. If they hit OK, then it will get deleted. This is why you can actually write JS inline. Okay. And then we want to close out where the row will end. So have each opens and closes the record. Just tidying up some of the HTML there. Save that. Okay, looking good. Back to our root index file. So let's see now. We want to also require our model, and then we'll have our student controller also be a require, and where it's going to pull the student controller from. Okay. And this is just the instructions on where we can actually find content. Okay, looks good. So let's do Node.js. Everything's saved. I'm going to rerun everything. And we got an error. Let's go check out where our error came from. So let's go into our files. This is one that we created. So error is in student controller. Let's see, where's the error? Oh, we need to have our module. We need to export our module to our router. All right, let's go open up Mongo database. And we can just start seeing where the records are. It's just installing the latest updates here. So we need to go ahead and put in our connection string. So it's on localhost, and that's the port. Let's just double check that, make sure we're completely aligned. So here's our database connection, and there's our port and student database. And we did this with Mongoose for connecting to Mongo. So I'm going to connect, and here are where our records are being stored. So we're going to create a database, and we're going to call this database. It's going to be called StudentDB. So StudentDB has to be case sensitive. And the collection name is students. Let's go ahead and create a database. So there we are, there's our database. And let's go rerun our index.js file. And everything was successful. This is good. All right. So everything should have passed successfully. Good, good, good. Database connection is good. So let's go to localhost. And here we are. So we can start actually navigating through our application. So we see we have our setup. We have no records. So let's go ahead and create one. And we go through, you can actually start stepping through the different layouts that you've created. So here's our layouts, they're separate to our code. So there's some spacing we probably need to add there. So let's go ahead and just add that. And let's rerun our code. This is the fun bits where everything is just tidying up. Okay, so it puts in one space because we didn't put in the actual HTML code for creating multiple spaces. So we're going to go in and select insert. So let's put in Smith, and we'll do smith@gmail.com. And let's just put in, random phone number. There we go. We don't have any formatting, so we could put anything in there. And the city, I know, where am I? I'm in Delhi, so submit that. Hit submit, and it takes us to a list, and voila, we actually have a list with a record in. And if we go back to our database, we can actually refresh it, and now we actually start seeing our records being created. And we see the ID is automatically created, and there's our records. Okay, let's go back. And now we can select edit. We can edit the record. So let's change our city to Bangalore. Hit submit. All right, city is now Bangalore. And if we want to, we can edit again. And so this is pulling in, if we do a delete, it's going to ask us, do we really want to delete? Okay. A little bit of formatting applied there. And the records are all good, so we can make that Smith Jones. But because we need to hit submit, we need to update the record. So we hit submit, it updates the record. We hit delete, it's going to say, are you sure? We say, yes, we are. And, it has, couldn't grab that record. Okay, so let's go back and look at my code. And because we have everything separated, we can actually now just go to our student controller, and we'll find our delete. There goes delete. And we had a couple of minor errors there. This is where it's good to test out your code. Okay, let's run that again. And refresh everything. So we go to our database. We're going to go create a new entry. Let's call this one john@gmail.com. We'll put in a phone number. You see the formatting is just playing from our Bootstrap. So there we have. There's John. Do we want to delete? Let's say yes. Ba-boom! Yeah, easy. There we've got it all solved. And we hit refresh, the record should be gone. Yep, it is. And so we've created an application where we can update applications. We can create an application, we can list all the items. And we did all of this using just open source solutions through Node.js. And that was with using Express, some of the components that come with Express, MongoDB for our database, and then Mongoose to connect to our database. We're going to be going through some of the simple questions that you would be asked during a Node.js interview. So let's just get started. So the first question you're probably going to be asked is, what is Node.js? Do you know what it's for? And essentially, Node.js is one of the most popular, if not the most popular, open source cross-platform JavaScript programs. It allows you to build out web applications that run on the server. It's extremely flexible. It allows you to implement a lot of solutions outside of just the core programming runtime. And it allows you to build solutions extremely quickly in an open source mindset for DevOps. It is used essentially for creating client-side web applications. We'll see this later on, and you may want to talk a little bit about using express.js and how you can build out APIs to work with Node.js and connecting to databases such as MongoDB. And that is also really good for being able to store data-intensive applications that are asynchronous and event-driven in their model. And this is important when you're talking about creating applications that can scale rapidly. So you're going to then be asked, how does Node.js work? Well, Node.js itself is actually built on the V8 engine, and the V8 JavaScript engine is the same engine that runs JavaScript in your Chrome web browser, extremely fast. It allows for high output and non-blocking through your I/O input and outputs, and is single-threaded event loop. So you're going to be then asked, where can you use Node.js? And the reality is the applications for Node.js keep expanding, but there are some core applications that you can work with Node.js right now. So such as web applications, distributed system, and network applications. Probably referencing the web applications is a really good starting point, because here you can actually talk about maybe some examples that you've done where you're building out some of these web applications. Indeed, one of the things that you want to be consistently doing and peppering your answers with is examples of work that you have done. Now, it doesn't matter if those examples are purely experimental or training examples that you've done. The fact that you've actually worked with Node.js and created a distributed system or a web application is really valuable, because it shows the person that you're meeting with that you have knowledge and understanding and practical experience of applying the theory of working with Node.js with the practice of working with Node.js. So be asked about, essentially the I/O refers to the transfer of data in and out of a system. And that's really it. And there's a reason why Google calls their conference I/O. It's the transfer of data in and out of our brains at their conference. The application is the same here. It's about moving data in and out of systems through using Node.js. And that every event can be tracked, whether it's on a physical device, a network, or files within a system. Again, it's input and output. So let's go through, and you're going to be asked, can you explain the difference between front-end and back-end development? And this is a question that I get asked a lot when I'm meeting with clients. People get really confused about what is the difference between front-end and back-end development. Bottom line, front-end is what gets resolved inside of your web browser or the app on your mobile device. Back-end is what gets resolved, essentially what we call the back office or server-side applications, but that's becoming more and more synonymous for what gets run in the cloud. So web applications really get a lot of the functionality of a web application gets run in the front end. And I think with CSS, HTML5, client-side JavaScript, it's all going to get run in the front end. Everything else, such as connecting to a database, gets run behind the scenes in the back end. And anything that's going to have like graphics is going to be on the front end. APIs are going to be run on the back end. And then just finally, some of the scripting languages that you use on the front end. So HTML, CSS, JavaScript, those are all common core scripting languages that you would use. You can use frameworks such as AngularJS and React.js or Vue. Those would be front-end frameworks. Back-end frameworks would include Java, PHP, Python, and Node.js are some of the back-end technologies. You'd also throw in there .NET as well. It's just a whole litany of front-end and back-end technologies and frameworks that you can use. And this is actually a good point to kind of explain the experience you have outside of just working with Node.js, but other technologies that you've been working with that potentially that the client is also using. So another question you're going to be asked when you're looking at Node.js is, can you tell me about NPM? And so when somebody asks you what is NPM, the first thing you're going to respond is, do you mean Node Package Manager? And the reason why you want to respond like that is that you want to qualify their question with understanding that you know what they're talking about, but you want them to verify that. And so Node Package Manager is NPM. And it's responsible for packaging all of your modules that you're working with in Node.js. And we have a whole series of videos that we've done on Node.js, and every single one of them includes references to NPM. So you're going to be asked, okay, you told me what it is, can you go into a little bit more details, so you can provide two main functionalities. And so one of them is being able to manage online repositories of modules and packages. So you can go to like search.nodejs.org and you can find packages that you can install into your solution, such as express.js. And it also provides a command line utility that allows you to manage your packages very quickly through terminal window or command line. I use VS Code a lot, Visual Studio Code, and it has a command line utility built right into it that allows me to interact with NPM. So what are some of the modules in Node.js? And so, modules in Node.js, they're essentially like JavaScript libraries. So you can think of some of the JavaScript libraries that you may have used. The functionality is somewhat the same, but they're designed for Node.js and to run on the server. And there are ways in which you can go ahead and create some of those modules. So for instance, if we're creating a web server, you can actually use the require command to be able to require that the server be there. So the example we have on the right-hand side shows that we really do need to have HTTP, which is a web server, and we require that to be installed. And so that if you're running that npm package, it will actually install the HTTP server, and then you can actually write some code to actually then listen on the local host port 2000 for where you'll be running your application. And there are just, there's a whole bunch of modules that come with Node.js right out of the gate. And here are some of the modules that you have. We also referenced just earlier on, HTTP is a core module for running a web server. You have a utility function that is useful for developers to assess features within your Node.js project. You have a URL module for any URL parsing you'd be doing. And you also have a stream, which allows you to be able to stream data in and out of your system and be able to manage how that's being worked. And then zlib, which allows you to compress and decompress files so that you can keep your storage of files to a minimum. So a question you're going to be asked is, why is Node.js being preferred over backend technologies such as Java and PHP? And particularly with Java, it's a very mature, stable language. It's been around for more than 20 years. PHP runs some of the most powerful and largest websites out there, such as Facebook. So why would you use Node.js? Well, the first response is kind of a gimme, but it is really fast. And if you watched any of the videos that we've done on Node.js, building out solutions and developing the solutions, you'll see just how fast it is. The second is the really kind of the secret sauce with Node.js is the Node Package Manager. And the Node Package Manager allows you to install additional functionality such as Express or Mongo as a database into your solution really quickly. And there's over 50,000 bundles available for Node Package Manager. If you're building out a real-time application that's data intensive and you need to have APIs quickly developed, then Node.js is really the great solution for you. It allows you to build out these solutions really quickly. And there is a easy synchronization between the server and the client due to the code base. And then finally, because the structure of Node.js is JavaScript, if you are making the pivot from being a front-end web developer to Node.js, it's just going to make it a lot easier for you to pick up Node.js because you have that common language of JavaScript. And on top of that, JavaScript is the world's most popular scripting language. So let's talk about some of the differences between Angular and Node.js. And so the reason why this question may come up is the person interviewing you is seeing whether or not you do know the difference between a front-end framework and a back-end framework. And this is one of those questions where you can go, well, there are differences, but the differences are because they complement each other. So Angular is a front-end development framework, whereas Node.js is a server-side framework. Other differences, though, between the actual frameworks themselves is that Angular is written in TypeScript, which is a modification of JavaScript. Node.js is written in C and C++. Angular is used for building out single-page client-side web applications. And so that's the key word there is client-side. whereas Node.js is about building out fast and scalable server-side network applications. Again, the two complement each other. Angular splits web applications into the MVC and model view control components, whereas Node.js generates a lot of database queries. It does more than that as well, but you can think of Node.js as that glue to your database. So let's talk a little bit about when you're connecting to a database with Node.js. And so you're going to probably be asked, what is the most popular database used with Node.js? And there are a couple. MongoDB is largely the most popular NoSQL cross-platform database. MySQL is also very popular, and that's a more traditional relational database. You would go with MongoDB for really more modern solutions. When you're looking at creating an application that's going to really scale into just managing masses and masses of data that has to be created, read, updated, and deleted very, very quickly. For some of the other popular libraries that you use for Node.js, express.js is a very popular one. I really like working with express.js. It allows me to build out web applications really quickly. More importantly, it allows me to build out APIs very quickly, and which, APIs are essentially web applications themselves. But being able to do that very quickly with a framework like express.js is very useful. Mongoose is an application that makes connecting to a Mongo database really easy. So here is an example of express.js, which is in itself really a flexible but a solution that you can do lots with, and Mongoose, which is a more focused solution, which allows you make it easier to connect to your databases. So, what are the pros and cons of working with Node.js? There's lots of ways, and we explained this earlier on, that you can actually build out applications that run on the cloud. Why would what are the pros and cons? So a pro is that Node.js is extremely fast at processing an event-based model. It really is fast. A con is if you have something that is a very heavy computational task, it's not so good at that. Now, I will caveat that Node.js is getting better all the time. And so you might have to provide an example of what a very heavy computational task is. And that may be calculating a risk on an insurance application against many, many variables. That may be something that's seen as computationally very heavy. But what you can do in that example is you can then offload the task to another solution that's designed for it and use APIs to pass the data back and forth. JavaScript is used for building out your applications with Node.js. Great. Lots of people know JavaScript. A restriction, and again, this is evolving as JavaScript itself evolves, is that when you do a callback, you may end up doing lots of nested callbacks if you're doing something that's very complicated. Again, another way around the con, and so this is one of the things that I always look for, is if you have a blocker or a barrier, how do you get around that barrier? And so, for instance, when you're talking to your recruiter, you can say, look, the reason why I use Node.js is that it's fast, it's event-based driven, I can use JavaScript. There are some challenges, but what I do to get around those challenges and that's where you can say that, you may run the complex script off and you may write that in .NET or Java or PHP and then use an API to do the response back into Node.js. So you get the benefits of both worlds, but minimize the investment in having to manage a complex environment such as Java versus a relatively simple environment with Node.js. The Node Package Manager makes it extremely easy to access just an awful lot of functionality. With over 50,000 packages, there's a package for that. So from being able to have a tool that creates unique identifiers that you might need to have for generating content that gets posted into a database, through to being able to connect to databases, through to running so many different solutions. the NPM package manager, with its access to so many different packages, makes it great for getting access to all that content. Now, a con is working with relational databases with Node.js isn't as easy as a NoSQL database. Now, you can do it, and there are ways around that. And what I would do when this question comes up is always kind of pivot to say, hey, this is how you can actually then get around building out that application. Pro for Node.js, designed for streaming huge amounts of data in and out. A con is that Node.js is single-threaded, and so it can be CPU intensive. But again, there are ways around that, and a good way around that is scaling your solution in elastic environments such as the cloud. So what is the command used to import an external library? And so to import an external library, the command is the require command. So an example we have here is you can start a variable, and the variable is going to be for HTTP. And you're going to then require the HTTP service. That means that the application itself won't run unless the external library, the HTTP library, is installed. Okay, so those were our introductory questions for Node.js. Let's kind of pivot and take a look at the intermediate questions that you would be asked. So what does event-driven programming mean? So event-driven programming means that if something happens, something else will happen in response. So for instance, if you click a mouse, that mouse click is an event. That means something has to respond to that event. Just think of it as cause and effect. It's just the basic motion of physics. So that's what event-driven programming means. You also look at it as a callback function so that when an element is executed, something will happen in response. So what is an event loop in Node.js? So an event loop in Node.js is when you do an asynchronous call. And what that essentially means is that you are sending out data, and then a non-blocking input-output from Node.js is pulling data back in. What is an event emitter in Node.js? So an event emitter has really two areas of focus. One is that it manages the classes that hold all the objects within your event. And we have an example of this on the right-hand side. And then whenever an event actually is thrown, the functions are then called on that event synchronously. So for instance, we have in our example on the right-hand side, we create an event, and then we have the functions that are executed in a series from that event. So let's talk about the API functions in Node.js. So there are two types. One is an asynchronous non-blocking function, and the second is a synchronous blocking function. And the difference between the two of them is asynchronous is that there is no structure to the order for how the API is resolved. Synchronous means that when the feedback from the API is received, you have to execute the response in a series for how the response is sent to you. So what is a package.json file? So the package.json file is at the heart of our Node.js package, when we actually will initialize a solution, a folder to be a Node.js package. You'll find that the package itself holds all of the metadata that's particular to the project you're working on, such as project name, version, requirements. You have to have it installed in the root of the directory for the project. And again, look at any of the videos that we have on Node.js. We do have demonstrations within those videos that actually then go through and break out how to create that root package. And you'll see how you can actually then go ahead and update the instructions or the metadata within the package. So here we have an example of what that metadata looks like. So again, this kind of continues that question of what is a package.json file? And you may be asked, what is the metadata and why is it important? And the metadata is a basic JSON collection of pairing of key details such as name, version, description, and then the custom version that you put. So for instance, Under name, you could create a name for your project. There can't be any spaces. What is the version and the description? What is the main or starting path for the solution? Typically, that would be index.js, but it could be anything.js. But index.js is typical simply because index.html is the starting point for a typical web application. So how would you use a URL module in Node.js? So with a URL module, what it allows you to do is really two things. One is that it provides the resolution and parsing of a URL for utilities in your application. And then it allows you to extend your module with built-in solutions and split up the web address into a readable format. So in this example, we have the URL and the response it would give for that URL, which would then be a year and month, and it would be in a readable format. So it would read out as 2020 and then the month. So what is express.js? Now, you've heard me mention this a couple of times in the video, and we actually have a separate video on express.js. But express.js is a web application framework that allows you to build out web solutions for both mobile and traditional desktop right inside of Node.js. So it's very easy to use. Being able to install WebJS is as simple as requiring Express to be installed. In the example that we have here on the screen, it's a full solution of showing how to actually build out a solution with WebJS. So in this example, you start off the first two lines, require Express to be installed, and the install comes from Node Package Manager. Then we have a simple application that will then send to the browser window a hello world message confirming that Express is up and running. And then the third block of content, starting with var server, actually will define the port where your application is going to run. So in this instance, the port is going to run on localhost, and the port will be port 8081. And so you can actually go to localhost :8081. And when you do that, that will trigger the application that will forward up the message hello world. And it's all coming from express.js. So what are streams in Node.js? So streams are objects that allow you to read and write data continuously back and forth within your application. And there's really four different types of streams. There's readable, writable, duplex, and transform. The readable one is streams for which data can be read. The writable is streams that you can actually write to. A duplex is a stream where it is both readable and writable. And transform are streams that can be manipulate the data while it is being read or written. So how do you update and delete a dependency? So say, for instance, we want to install something like Express. So if you wanted to install Express, what you would do is you would just write inside of your project. You want to go to terminal window and write in the command npm install Express. If you want to update the dependencies within your Node Package Manager, to update all of them, all you have to do is write the command npm update all dependencies. And then if you want to explicitly uninstall a dependency such as express.js, that's using the uninstall command. And so that would again be going to terminal window and you would type npm uninstall express. And again, it's really easy to create a simple server in Node.js that will run a simple command. The HTTP service is actually built into Node.js. You don't need to use Express.js. I typically use Express.js when I want to do a web server, because typically what I find is that I will want to go and do something more complicated. But if you want to do something that illustrates just the core functionality within Node.js, you can actually just require the core HTTP service that actually comes as part of Node.js. And then you can actually then go ahead and tell it to create a service and then to write in plain text a command or a text string, such as this case, it'll be hello world, that would pop out. And then the final line is to then listen that if you go to a web browser that's on port 127.0.01 or localhost, and go to port 8080, once you actually go to that, that will trigger this application and you'll get the text hello world pop up on your screen. So explain synchronous and non-blocking APIs in Node.js. So all the APIs in Node.js are asynchronous, which means that they are non-blocking, which means you can run them continuously and scale around that, which is just fantastic. It's one of the reasons why Node.js can scale so fast. And the means that the APIs can return data, send data after it's been called, and really increase the efficiency of events as they are triggered within Node.js. So how do you implement async in Node.js? And so the example that we have on the left-hand side allows us to trigger async, and it's using the async function. And as you can see in this example, it's actually something that can be done very quickly. In this example, we're actually making a command to localhost and an app that's running on port 3000. And then depending on what we get, if there's an error message, then we'll have error message go to the console log, which is the terminal window. And if we get a response to an application, then we'll actually get a positive response, which would be fetched response. So again, very quick and easy that you use the async function to be able to build out and to get your asynchronous code. So what is the purpose of module exports? So a module export is a way to encapsulate the entire code for a solution in a single package, in a single file. And then you can then share that with other developers, so you're all working from the same environment. So what is a callback function in Node.js? A callback function is essentially that once you run and you've triggered an event and the response has been given, you want to be able to then have a callback to validate that the task is complete. All right, let's move on to the final set of questions, which is advanced Node.js questions. So what is REPL in Node.js? So REPL stands for read, eval, print, and loop. And this is a reference to the Unix and Linux background that Node.js has. So REPL will perform the following tasks. The read will be actually parsing the JavaScript. You'll read that and store it in memory. Eval takes and evaluates the data structure. Print will then print the results, often on a console window or onto a web page. And then loop loops the above command until the user presses Control-C twice. What is the control flow function? So the control flow function is a piece of code that runs between several of the asynchronous functions. And that's it. It actually controls how those functions execute. So how control flow controls the function calls? And it does it through four ways. One is it controls the order of execution. It collects the data. It limits the concurrency. And then it also calls the next step in a program. Again, this is a management tool for how your functions are called within Node.js. So what is the difference between fork and spawn methods in Node.js? So the essential difference between the two of them is that if you use the fork method, it will actually trigger and create a new instance of the V8 engine, the engine running Node.js, and will then run the application in that new instance. With spawn, it's somewhat similar. It doesn't actually generate a new V8 instance. So it's actually creating a new process, but it's within the same V8 instance as the previous application that it was spawned from. Explain to me, what is the use of buffer class in Node.js? So with the buffer class, what you're looking at doing is you're actually controlling the raw data of a set of arrays and integers. and the memory allocation outside of the V8 heap. Buffer class is used because pure JavaScript is not compatible with binary data. What is piping in Node.js? So piping is the ability to connect the output of one stream to another stream. That could be a data stream, it could be any stream that you're working with. But it does normally get used to pass data from one stream to another. So what are some of the flags used in the rewrite operation files? So R- is used for read, W is for opening a file for writing, A- is opening a file for appending. So the collection that you have here, you don't have to really memorize all of them, but to have a few of them in the back of your mind is always a good reference point. So how would you open a file using Node.js? So the syntax you would use would be the fs.open, and that would then open up a file. Explain to me what callback hell is. So callback hell, also known as the pyramid of doom, is when you have too many nested, unreadable, and unmanageable callbacks intensively cycle within each other. They're constantly reading to each other, and they're not able to resolve the solution. And this is it's a big problem, and this is why it's called callback hell, because you're not able to finalize the app you're working on. What is a reactor pattern in Node.js? And so a reactor pattern is a concept of non-blocking I/O operations. Can you explain to me the test pyramid for Node.js? So the test pyramid, and this is standard for testing for all DevOps, is really split into three key areas. You have unit tests, integration tests, and then end-to-end or E2E tests. The unit tests are tests that you actually do in your raw code that you're working on, and the goal there is to be able to validate that the code you're writing is consistently working. Integration allows you to have tests that integrate your raw code that you're working with in your application with other areas of an application. And then end-to-end is the whole system, the whole interface, as it were, for your solution. Describe the exit codes of Node.js. So an exit code is a specific code that identifies the end of a specific process. And examples of exit codes are unused, uncaught fatal exception, fatal error, internal JavaScript evaluation area. These are all good examples of exit codes. So what is middleware? Can you explain the concept of middleware in Node.js? So with middleware, it is the ability to be able to connect to a system and get data from it that's outside of Node.js. So this may be executing a type of code, or updating and modifying a request and response to a specific type of object, finishing the request response cycle. Can you explain to me what are the types of HTTP requests that you may use when working with Node.js? There are actually quite a lot, but 4 of them that you might use would be get, post, head, and delete. And these are, if you've done any web application before, particularly if you worked with forms inside of a web application, you're probably very familiar, certainly with get and post. Get is the request to retrieve data. Post is generally used for changing state in the data. Head is similar to get, but also asks for a response if there's no body content. So if you're developing an API, this would be a good one to use. And delete is used to delete the predetermined source. So how would you connect to MongoDB database and with Node.js? And you use that using the Mongo client. And the example we have on the left-hand side illustrates that. What is the use of Node_env? And so the Node_env is an environment variable that stands for Node Environment in Express Server. So the example we have on the right-hand side allows you to illustrate how you would do that for, say, a production environment. So what are some of the various timing features in Node.js? So The timing functions that you could use here, set timeout and then clear timeout, and use to schedule code execution that you'd have inside of your application. You also have set interval and clear interval to execute a block of code up multiple times in your application. Set intermediate and clear intermediate to execute code that is at the end of your application.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
Let's go ahead and begin with what is React. React is a JavaScript library used to build fast and interactive user interfaces for both web and mobile applications. Now, one thing that makes React extremely powerful is the fact that it's open source. Any user can access its source code, modify it, and enhance it. In a typical model view controller architecture, React defines the view part of the application. It is also responsible for how the app looks and feels. Fun fact, React was built by Jordan Walke, an engineer at Facebook. Now let's go ahead and see how React works in real time. Consider a typical web application, say Instagram. The entire UI of the web page is divided into several components. We have the search component, a profile description component, stories component, and a post list component. These components make the code easier to debug and always remain discrete. Components also make development and maintenance of web applications faster, as multiple developers can work simultaneously on different components of the same web application. Now let's see why React is so popular these days. React helps in creation of dynamic web applications. It also provides performance enhancements. Now there are several performance enhancements like virtual DOM and one-way data binding. We'll learn about these topics a little later in the video. React uses reusable components. Now this helps decrease the development time. React involves unidirectional flow of data. React also has a small learning curve. Compared to other frameworks like Angular, React is much easier to learn. React can also be used for mobile applications. React recently released an extension called React Native that is used for developing mobile applications that are cross-compatible. It also has dedicated tools for easy debugging. Now let's dive into the features of React. First, let's understand JSX. JSX is a syntax extension to JavaScript. Using JSX, we can add HTML to the JavaScript file. All coding in React is done using JSX. It also helps in making the code easier to understand and debug. Ultimately, JSX is a combination of JavaScript and HTML. Now let's consider a small example. Const simple here is a JavaScript notation. H1 tags indicate HTML. Again, the semicolon indicates JavaScript. Note that the semicolon is not mandatory. However, it's a good practice to include it. Moving on, the next feature is virtual DOM. DOM, which is an acronym for Data Object Model, actually defines how documents are accessed and manipulated in a web page. It represents the entire structure of the web page in the form of a tree. Now let's see how this actually works. React creates a virtual DOM that is the exact copy of the real DOM. Traditionally, whenever something changes in the web application, all objects in the real DOM are updated. This makes it extremely slow. Let's see how React counters this. Now consider two objects whose states have been changed. React now compares the virtual DOM with the virtual DOM snapshot that was taken right before the update. By comparing the new virtual DOM with the pre-update version, React figures out exactly which virtual DOM objects have changed. Now React only updates those objects on the virtual DOM. This makes a big difference when it comes to speed. Coming to the next feature, performance. React uses virtual DOM. As discussed earlier, virtual DOM impacts the speed of the web applications. We also took an example of Instagram and learned how multiple components can affect the development time. They help improve performance drastically. The next feature is one-way data binding. This means information flows in only one direction. One-way data binding is specifically used when information is displayed and not updated. Remember that the components of React are functional in nature. That is, they receive information through arguments and pass information via their return values. The next important feature is extensions. React has many extensions that we can use to create full-fledged front-end applications. It provides server-side rendering, which means that the application is rendered on the server rather than in the browser. React Native, which is a React extension, is used for developing mobile applications. There are many other extensions that React provides for every scenario in web development. Now let's look at a few of them. React Native lets you build mobile applications using only JavaScript. A React Native app is a real mobile application and not just a web application running on your mobile devices. Thousands of applications like Facebook, Instagram, Pinterest, Skype use React Native. The next popular React extension is Flux. Flux is the application architecture that Facebook uses. Flux implements a unidirectional flow, which makes it easier to understand what actually is going on. Now let's see how it works. When we trigger an action, the dispatcher will get notified. The dispatcher receives actions and dispatches them to the stores. A store is what holds the data of an application. Stores will register with the application's dispatcher so that they can receive actions. Data from stores is displayed in views. Actions define the internal API of your application. They capture how anything might interact with your application. The last feature of React is debugging. React applications are easy to debug thanks to the large and active developer community. You can practically debug React codes within your browser. Now notice the small React extension icon at the top right corner. This developer tool allows the user to inspect the code and also easily debug it. Moving on, let's learn about the building blocks of React. Components, state, and props are the essential concepts that one should know before implementing React. They are the foundation on which React is built. Now, what exactly are React components? Components are the building blocks of any React application. React divides the user interface into multiple components, wherein each component defines how a particular element is viewed in the application. React components remain discrete and are processed independently. Another feature is reusability. Components can be reused multiple times across the application. This reduces the development time. Consider the following code snippet. A component is implemented as a JavaScript class having some state and a render method. State is the data which we want the component to render. The render method is responsible for how the UI looks and feels to the user. The next concept is state. State of a component is an object that holds some data. This data influences the output of a component. Every time the state of an object changes, the component is re-rendered onto the screen. Now let's see what props are. Props, or short for properties, allow us to pass arguments or data to components. Properties help make components more dynamic. It is important to define all the properties, their types, and their default value. Props are passed to components in a way similar to that of HTML tag attributes. Now consider the following code snippets. This shows exactly how properties are passed to components. Also, detailed illustrations on components, props, and state will be shown in the upcoming videos, so stay tuned for that. Moving on, let's go through some of the things that you should know before you can actually start working on React. You should be familiar with programming concepts like functions, objects, arrays, and classes. One should also have a basic knowledge of JavaScript and a familiarity with HTML. Don't worry if you feel like you're not good at them. Once you start working on them, you'll get a good hang of it. Finally, let's go through the impact of React on the IT industry and get insights into the salaries of React developers. Statistics show that React developers earn way more than other web developers. According to PayScale, the average salary for a React developer in the United States is a whopping 91,000 US dollars. The average salary for a React developer in India is 7.25 lakhs per annum. Over the recent years, React has gained immense popularity and is being adopted by many companies. According to the data by Google Trends, React has had a better growth scale compared to other frameworks like Angular and Vue. Statistics show that front-end developers have wholeheartedly adopted this lightweight framework, foregoing other available options. If you are skilled and have a knack for front-end development, React can help you gain fantastic career opportunities. Lastly, talking about a few companies that use React devotionally, we have Facebook, Instagram, Netflix, Dropbox, WhatsApp, among others. To set up the React development environment, we need two things installed: Node and a text editor of your choice. So let's begin by installing Node.js. We can head to the official Node.js website, say download Node.js. So here you can see the Windows installer. Depending on your system, you can either download the 32-bit version or the 64-bit version. So I'm going to go ahead and click on the 64-bit version. Since it's already installed on my system, I'm not again installing Node. You can follow the installation guidelines and download it. Once you're done with Node installation, you can go ahead and download a text editor of your choice. So I'd suggest VS Code. So let's head to the VS Code page. Say download VS Code. Click on the first link and download the 64-bit version for Windows. Once you're done with the installation of both Node and your text editor, you can start creating your first React application. So for that, let's create a folder. I'm creating it on my desktop, while you can create it in any of your drives. Let's call it first React. Now open your command prompt. Now you can type in the path for the folder that you just created. So say cd users first React. Now go ahead and type in the command npm install -g create React app. Okay, so this command installs all the necessary React.js modules. Now to check if the version is correctly installed, you can type in create React app version. So you can see the version here. Now let's continue and develop your React application. Type in the command create React app and you can give a name to your application. So I say my app. Now this should take a couple of minutes. Okay. Once you've successfully created your application, they say to begin by typing the following commands. So let's do that. Say cd my app and npm start. This should typically start your application, and here we go. Alright. You can also open your application in the text editor that you've downloaded. So let's go ahead and open VS Code. VS Code, file, open folder, go to your desktop or the drive that you've saved your folder in. First React, my app, and I say select folder. So as you can see, all your modules have been imported. You can click on app.js and start editing. What exactly are components? Components are the building blocks of a React application, wherein each component represents a part of the user interface. Now to make it more understandable, consider the Facebook homepage. The entire UI can be broken down into several elements. Say we have the credentials component, the sign up component, the image component, and the logo component. Notice that each component adds something to how the homepage looks. Alright, reusability is one of the salient features of React components. One component can be reused several times across the application, and this improves the development speed. Components can also be nested. One component can internally consist of several other components. In its minimal form, a component must define a render method that specifies how exactly the application looks and feels. A component can also receive properties from its parent components. Also, you'll get a better understanding of all of these when we start working hands-on, so don't worry. So, moving on, let's look at the different types of components. First, we have the stateless functional components, and then we have the stateful class components. Now, functional components are typical JavaScript functions that return HTML. Now, they can be contained in a .js or a .jsx file. Coming to class components, these are regular ESX classes. However, it's mandatory that they contain a render method that in turn returns HTML. They can also be contained in .js or a .jsx file. Okay then, let's go ahead and build our first React application using components. Alright, so I've opened my text editor, that is VS Code, to build my application. Also, I suggest you watch the React installation on Windows video to help you get started. The video briefly explains how to install Node and how to start building your first React application. In my case, I've opened a folder called React Component Tutorial, and here in my source folder, I have app.js. Now, app.js is the main component that gets rendered to the DOM. Let me show you that. Here in index.js, you pass app.js, which is a component that gets rendered to the React DOM. So app.js consists of several other components that can be nested. So as you can see, app.js is a functional component. And before moving on, let me get rid of all the unnecessary code. So let me delete all of this and return an h1 tag that says hello, welcome to SimpliLearn. Let me save it, and if you look at the browser, you'll have hello, welcome to SimpliLearn. Now let's go ahead and display another message. Say h1, this video is about components. Right, let me save it and let me check the browser. It gives you an error. So JSX uses a conventional rule which states that all HTML tags have to be enclosed within a div tag. So for example, I say div and I enclose it. So let me save and check my browser again. Here you go. So multiple HTML tags have to be enclosed within the div tag. Moving on, let's create our first functional component. To do that, I'll first create a folder in my source folder, say components. Within that, I'll create a file, say functional component.js. Alright, so the first thing we have to do is import React. So I say import React from React. The general syntax for a functional component involves the keyword function and say functional component. Now you say return an h1 tag, or I've already used h1 tags, so I'll say paragraph and I say this is a functional component. Alright. Before explaining to you how these components are exported and imported, let me show you the general syntax for a class component. So I create another file, say class component.js. I again import React from React. The general notation is using the class keyword followed by the name of the class extending from the base class React.component. So going ahead, I say class component extends React.component. Now the key feature of a class component is the usage of a render method. So I say render, within braces I say return a paragraph tag saying this is the class component. Alright. So moving on, let's see how these components can be nested into the main component, that is app.js. Components can be nested into the main component using import and export keywords. So as the name suggests, export feature is used to export a particular file or a module, and import is used to import a particular file or a module into the current existing module. So we have two different types of exports. You have default export and just export or named export. So a default export is used to export just one object, be it a function, a class, a variable, from the file, and there can only be one default export per file. And when you're importing it, you can specify the address and use the word import before it. So let me show you how it works. Let's go back to our editor and then functional component. And here I say export default and the name of the functional component, that is functional comp. So let me save this. And going back to my app.js, I say import name of the functional component, that is functional comp from, and I pass the path, this components / functional component. Also, let me get rid of these unnecessary files here. Now let's define functional component in our app.js component. So here I say functional comp. Let's compile it and check our browser. Here it says this is our functional component. Moving on to my class component, it's the same syntax here as well. I say export default name of my component, and in my app.js I import it. Import class comp from the path. And again, I'll have to define it in my return method. I say, so let me compile it and check my browser. It says this is the class component. One unique feature of default export is that I can rename the file while I'm importing it. So for example, I can rename it as say FC, and while I'm defining it, I'll have to make sure I use the same naming conventions. So I say FC again. And when I check it, it says this is the functional component. There's literally no difference. The next type of export is the named export or just export. So a named export can be used to export multiple objects, be it functions, class, etc. from a file. Now there can be several named exports from a single file. One hack is that while you're importing, it cannot be renamed. So let me show you how this works. Okay, so let's create another class in our class component. So I'll just copy paste this. Let me give it another name, say class comp1. And the message that I want to display is, hey, I'm another class. Alright, so when I'm exporting it, I don't want default. So let me take it off and say export here. Alright. In my app.js, while importing it, I want to import both the classes. So I'll include them within curly braces here. I say class comp, comma, class comp1. And then again, I define it here, class comp1. Let's compile it and run it, and here we go. Here you can see, hey, I'm another class. So we've successfully exported both the classes from the class component and imported it back in our app.js component. One advantage of using named export is the fact that I can choose to import the classes that I want to. Now say for example, I do not want to import class component here. So let me take it off, and here let me comment this. Now let's compile and see. hey, I'm another class. The second class got imported while the first class that was defined earlier is not imported here. Alright, so next up we have higher order and pure components. Now I won't get into the nitty-gritties of it because they're advanced topics, but to give you a brief insight, higher order components are basically functions that take in a component and return a new component. The whole ideology behind higher order components is to facilitate the reusability of component logic. Okay, so let's see how this works. Let's go back to our code editor. Let's create a component. In our components folder, let's call the component click.js. Alright, so here we define a class. I use this snippet RCE. Here we go. We get the entire format using the small snippet RCE. And here I'm going to make use of a button. Now say I use the tag button and I'll say clicked one time. Every time the user clicks on the button, the value gets incremented. So for this, I'm going to use a variable say count, and I'm going to use the concept of states. So let's go ahead and define our variable count and initialize it to 0. So for that, I'm going to use another snippet called rconst. And here, this dot state equals my variable count, initializing it to 0. So let's define the count variable in our render method. So I say const count equals this dot state. So every time we click on the button, the count value has to get incremented, right? So we make use of an event called onClick equals this dot update click. Now update click is going to be another method that we have to define now. So every time the button gets clicked, this method is called. So let's go ahead and define the function. So it is update click equals, is going to be an arrow function, and I say this dot set state is nothing but count this dot state dot count plus 1. Okay, and here we say count times. Alright, so once this is done, let's import our component in app.js. So here again, I say import click from components click, and let's define it here. So let's check our browser. Every time we click on the button, the value gets incremented. Alright, so let's go ahead and create another component, say counter.js, wherein every time the user hovers the mouse on the button, the count value increases. So let's go ahead and do that. I say counter.js. I'm again going to use the snippet RCE to create a class component. And here in my div tag, I define a button and say incremented to, for now I say X. So now let's go ahead and add the event. Say button on mouse enter. I'm going to call the method this dot increment count. Okay, so once you're done with that, let's go ahead and define the increment count method. I'm going to copy the same code that I've mentioned in my click.js. So I say copy this. Alright, so one change is that I'll change the name of the method and call it increment count. Again, let's define the count in our render method. So I say const count equals this dot state. And here I change X to count. Now let's go ahead and import it in our app.js. So I say import counter from components and counter. And let's define it here. Alright, let's save it and let's run the code. Okay, so as you can see, you see another button here incremented to 0, and every time I move my cursor on the button, it increments. Mind you, I'm not clicking, I'm just hovering my mouse. Okay, to learn how higher order components work, we'll have to pass counter.js and click.js as parameters to give birth to an entire new component. So for that, let's go ahead and create another component for our HOC. Let's call it higher order.js. Okay, so I say import React from React. After that, I say const updated component equals original component. That's going to be an arrow function again. And within curly braces, I define my class. That is class, say, new component extends React.component. Inside, let's define a render method that returns the original component with a modification, that is, I want to type the user. I want to append the user before the actual message is displayed. Alright, so let's go ahead and close the tag and return new component, and let's export this. Say export default updated component. Now we import higherorder.js in our counter.js and click.js and pass these components as parameters. So let's do that. Let's go to our counter.js, and here I say import updated component from ./higherorder component. And here while exporting I say updated comp and pass this as my parameter. Let's do the same to click.js. Here I import updated comp from higher order component, and here I pass this as a parameter. Now here in our higher order component, we've defined a property name and initialized it to the user. So we'll have to include this in our other components, that's counter and click. So let's do that. And here right before incremented to, I say this dot props dot name. Let me save it. Let me do the same thing here and save this dot props dot name. So if you go back to our browser, here you can see it says the user clicked 0 times and the user incremented to 0. Okay. So this basically shows how React implements reusability of components. Moving on, our next topic is pure components. Now another way to create class component is by extending pure component from React. A pure component avoids unnecessary re-renders. Now how does it do it? It does not implement the should component update method. Now you'll learn about this method a little later in the video. Now this method enables re-rendering of components to the DOM. But a pure component on the other hand ensures a shallow comparison of states and props and checks if a re-render is actually necessary. Only then does it render to the DOM. A React component can be considered pure if it renders the same output for the same state and props. So let's take an example to explain pure components. So let's go back to our VS Code and create two component classes, one for a regular component and the other for a pure component. Now using this example, I'll show you exactly how pure component is more helpful. Okay, so let's create a pure component.js file. I say purecomp.js. So here I'm going to use a snippet rpce that is going to create a pure component class. Let me get rid of this export. And here in my div tag, I'll display the text, say I'm the pure component. Alright, now let's go ahead and create a regular component. I may call it regular component.js. And here I'm going to use the snippet RCE. And the message that I'd want to display is I'm the regular component. So to draw a comparison between the regular component and the pure component, let's create a parent component for the two. So let me create one here. I'll call it parent component.js. And this is again going to be a regular class component. And here I display the message, I am the parent component. To change the state of the component, we're going to make use of a constructor. So let's use the snippet rconst. And here let me create name. You can give anything and I say simply learn. Now we make use of the component didMount lifecycle method to set a time interval. Now don't worry about this. We're going to learn about it a little later in the video. So moving ahead, I'm going to make use of the method and say component didMount. And here I say set interval. And the first argument is going to be an arrow function and the second will be the time interval. And I'm going to be setting it to 3 seconds. Now within the arrow function, I'll make use of the setState function to set the state of my property. However, I do not change the name. I keep it simply learn itself. Moving on, let's import pure component and the regular component into our parent component and then pass name as a property. So to do that, first import purecomp from pure component and then I say import regular comp from regularcomp.js. And here let's say regular comp name equals this dot state dot name and I say pure component name equals this dot state dot name. Now let's include the property name in both our regular and pure components. So to do that, let's just say this dot prop dot name and here I again say this dot prop dot name. And finally, let's import parent component into our app.js component. So here I say import parent comp from, okay, and here let me define parent comp. So now if you look at the browser, we have I'm the parent, I'm regular component simply learn, and I'm the pure component simply learn. We've got the result as expected. Now to check if the pure component is actually re-rendering or not, let's include simple console.log statements. So here I say CLG snippet, and here I say pure component render. And in my regular component, I do the same thing. I say console.log regular component render. Now let's do the same in our parent component as well. Here I say parent component render. Alright, so let's go back to our browser and inspect it in our console. First the parent component gets rendered, then the regular component, and then the pure component. After that, for every 3 seconds, only the parent component and the regular component is rendered. For the same state and prop, the pure component is not re-rendered. So in conclusion, pure components optimize React codes and also improves performance. So coming to the last topic, component lifecycle. So basically, component lifecycle explains the stages the component goes through. The entire lifecycle of a component can be divided into 3 parts. We have mounting, updation, and unmounting. So the first thing that gets invoked in the life cycle is component will mount. It is invoked right before the initial rendering occurs. Then we have the rendering method. Now once a component is inserted into the DOM, component did mount gets invoked. Coming to the next phase, we have updation. When a component receives props, component will receive props gets invoked. Set state is called when the state of the property changes. So every time there is a change, React decides whether the next component's state should trigger a re-render or not. To do that, should component update method is called. Component will update is invoked right before re-rendering. After re-rendering, component did update is called that makes updates to the DOM. And the last phase is unmounting. Component will unmount method does all the necessary cleanup and erases all the allocated memory and cycles. Moving ahead, let's learn about another striking feature of React.js called props. Props, short for properties, allow the user to pass arguments or data to components. A parent component can pass additional information to its children using props. Properties help make components more dynamic. Props are passed to components in the way similar to that of HTML tag attributes. Now we'll look at this a little later in the video. Props in a component are read-only and cannot be changed. One thing to remember is that props are sent by the parent to the children components. Hence, the children components cannot make any changes to these props. Now that we've learned about props in brief, let's go ahead and create our application using props. If you're new to this tutorial, I suggest you go to the React installation and React components video on our channel. So back in my code editor, that is VS Code, I've opened a folder called React Props. And now I'm going to create a component, a class component, and I'll call it class props.js. So let's create the class component. I give RCE, the snippet. And here I display a message saying an h1 tag basically. Alright. Now let me get rid of export here and import it in my app.js main component. Here I say import class props. Alright. Now we define the class component in our render method. Let's say. Alright. Now if we go back to the browser, you see hello learners, welcome to SimpliLearn. Now let's say we want to individually welcome every student. Instead of retyping the message for everybody, we can pass their names as props. Now let's see how to do that. Now we pass the name as a property from the main component, that is app.js, to the child component and render this onto the browser. So let's do that. So here, while I'm defining my child component, I say name. I save it, and here in my child component, instead of learners, I use the keyword this dot props dot name. Let me save it, and if you look at the browser, we'll have hello learner 1, welcome to SimpliLearn. Now let's go ahead and welcome learner 2 and learner 3. So I again say class props name equals learner 2. Alright, so if we save and look at the browser, we'll have all the 3 learners displayed on the browser. We can also pass multiple props to the child component. Now say for example, we want to welcome the student from a particular place. So we say welcome learner 1 from place X. So I can here define another property, say place, and say place. Similarly, I can do it for the rest too. Say place y. Now let's go back to our class props.js component, and here say hello learner1 from this dot props dot place. Let me save it. And if you look at the browser now, we have hello learner1 from place X, place Y, and place Z. We can also display whatever we want between the opening and closing tags when invoking a component. Now this is facilitated using props.children reserved keyword. Now let me explain to you how it's done with an example. Here, let's split the self and closing tag into an opening and a closing tag. And in between them, let me display a message within the paragraph tag. Let me say, and in my child component, after my h1 tag, let me use a paragraph tag, and here let's use the reserved keyword this dot props dot children. So let's save it. And now if you look at the browser, you can here see the message displayed child component. So props.children can be used when components do not know about their children ahead of time. This is commonly seen in components like sidebar and dialog that represent generic boxes. So let's go ahead and create a button tag and check again. So here I'll split it and add a button tag and say click. And let's check our browser. Here we go. We get the output as expected. Alright, we saw the usage of props for class components. Similarly, we can use it for functional components. So let's go ahead and create a functional component. Let me call it, I say import React from React. And then I say function props. And here I return an h3 tag. I'll say this is functional component, and I'll return another h3 tag saying hello learner. So let me save this and let's export it. Export default function props and import it in our app.js again. Import function prop from function prop. And here in our render method, let's define it. Let me call function prop name. Let me give learner 4 and place say A. Let me close it. And back in our functional component, instead of learner, I say props.name. Let me save it. Now, if you look at our browser, it gives us an error. It says props is not defined. So let's go back to our code editor and pass props here to our functional component. Also, let me define hello props.name from props.place. Let me enclose it within the div tag here. Let me save it. And now if you look at our browser, here we go. We get the output as expected. Let's begin and learn what exactly is a state in React. Typically, a state is an object that stores the values of properties belonging to a component. Now, these values can change over a period of time either via user interactions or network changes. And the state helps facilitate this functionality. Every time the state changes, React re-renders the component to the browser. The state is initialized in the constructor. A state can also store multiple properties. A method called setState is used to update the value of the state object. Now this function performs a shallow merge on the new and the previous state. Conventionally, a shallow merge ensures that the previous state values are overwritten by the new state values. Moving on, in our previous video, we learnt about props. And although props and state dictate and control the behavior of a component, they have significant differences. So let's go ahead and draw a comparison between the two. Firstly, props in a component are used to pass data and event handlers to its children, while state on the other hand is used to store the data that has to be rendered on the web page. Props are immutable. Once set by the parent, they cannot be changed. State holds volatile data and can be changed over time. Props can be used in functional and class components, while state is restricted to class components. Props are set by the parent component, while a state is generally updated by event handlers. Now that we've learned all about state, let's go ahead and build an application to see the working of state. Alright, so in my code editor, that is VS Code, I've created my application, say state, and here in my source folder, I have my app.js file. Now here, I'm going to get rid of all the unnecessary code that I'm not going to be using. Also, I suggest you go through the React installation on Windows video to help you get started with creating your first application. So let's create our class component, say class app extends react.component. Inside, I have a render method that returns an HTML tag. Let's display a message, welcome. Let's follow the JSX conventions and enclose all the HTML tags within the div tag. So I say div class name equals app. We also have to import the app.css file, import app.css. And so we save it, and if you look at the browser, we have welcome. Now let's beautify our code. To do that, let's add some styling. So here in my app.js class component, I say styles equals, and I say font style, and I set it to say bold, and I say color, say teal. And here in my h1 tag, I say style equals this dot styles. So let me save it. And if we look at the browser now, we have welcome in teal and it's bold. Now let's go ahead and create a class component to understand state. So first I create a folder and I call it components. And inside this folder, I create a class component and I call it new comp.js. And I use the snippet RCE to create the class component. To give you an insight into what we're doing today, we'll display a message asking the user to subscribe to SimpliLearn. Once the user clicks on the subscribe button, we instruct them to click on the bell icon. And finally, we display a thank you message. Now to do all of this, we're going to make use of state. And as mentioned earlier, we initialize the state object in a constructor. So let's use the snippet rconst to create our constructor. Now in the state object, we initialize a property, let's call it message, and we display a message saying subscribe to SimpliLearn. Let's save it. And here in our render method, let's say class name equals app, and let's create an h3 tag, and within the tag, I display the message. So I say this dot state dot message. Let's save it, and now let's import it in our app.js component. So I get rid of export here, and here I say import new comp from components and new comp, and let's define it here and say new. So we save it and look at the browser, it says subscribe to SimpliLearn. Alright. Again, to make our code look more presentable, let's add in styles. So I'll just copy the same styles that I've added here and I paste them here. And instead of bold, I make it italic. And I change the color to say purple. And again, in my h3 tag, I define style and initialize it to this dot styles. So let me save it. And now if you look at the browser, it's in italic and it's in purple. Okay. So moving ahead, let's create a button that reads subscribe, and once the user clicks on it, the button should read subscribed, and the message displayed above should instruct the user to click on the bell icon. To do that, let's first create a button. The message that I want the button to read is subscribe. However, this message gets changed once the user clicks on the button. So instead of explicitly mentioning subscribe here, I create a prop. I say sub and I say subscribe here. And back in my render method, I say this dot state dot sub. So let's save it. And if you look at the browser now, you have a button which displays a message subscribe. Now once the user clicks on the button, the message displayed should change to click on the bell icon to never miss an update. So let's create an event handler for that. So here, button on click, I call another method, and let's call the method button change. Okay, so this method should update the state and change the message and sub values. To do that, we make use of a setState method. Now a state can be updated in response to event handlers, server responses, or prop changes. Now all the updation can be done using the setState method. Now this is the general syntax used by the method. We'll however look at this further in the demo. Now the setState method conventionally enqueues all the updates made to the component state and instructs React to re-render the component and its children with the updated state. Now let's go back to our code editor and look at the working of this method. Now here I define the arrow function button change. If you are not familiar with arrow functions, I suggest you read up on them. And this is the general syntax. And here I say this dot set state. And inside I change my message to hit the bell icon to never miss an update. And my sub value changes to subscribed. Let's save this. And now if you look at the browser, when we click on the subscribe button, the message changes to hit the bell icon to never miss an update. So moving ahead, let's use a bell icon so that the user can click on it. Once he clicks on the image changes and a thank you message appears on the screen. So for that, I have two images. I have bell A and bell B. So I drag and drop both the images in my components folder. Alright. Now let's import these images into our new comp.js file. Here I say import bell A from bell A.png, and again I say import bell B from bell B.png. Alright, let me save it. To display the image on the screen, we make use of the image tag. Now this tag has two attributes. One is the source attribute that specifies the URL, and the other is the alt attribute that specifies an alternate text for the image. So here in my component, I make use of a paragraph tag that will help display the image in the next line, and then I use the image tag. Now since my image changes once it's clicked, I have to define a property and pass the event handler click that will update the image. So here, before specifying the source, let's go back to our state and define another property that is image URL, and let's set it to bell A, since that is the image that I want to display first. Let me save it, and here in my image tag, I say source equals this dot state dot image URL. And then we have the alt tag, and I do not want to display any message, so I leave it as it is. Now let's save it, and if you look at the browser, we have a bell displayed. However, now let's change the dimensions of the bell. I do not want such a huge bell. So back in my VS Code, I define style with width, say 30 pixels, and a height with again 30 pixels. Let me save this. And now if you look at the browser, we have a smaller icon. So once the user clicks on this image, the image changes and the message displayed here gets updated. To do that, we'll have to define an event. So let's go back to our VS Code, and here in my image tag, let's say on click, I define a method, say this dot image change. And now we define this method here. I say image change. I make use of an arrow function again, and again I use the setState method. I update the image. So I say image URL is now set to bell B, and the message is updated to thank you, happy learning. So let's save this now. And if we look at the browser, we see the image, and once clicked on it, the image gets updated and the message changes. So finally, let me refresh the browser once and show the full execution. Let me refresh. Following the instructions, let's click on the subscribe button. And now it says hit the bell icon, and once I do that, the image updates and the message changes. This video on React.js helps you build two fun applications using the library. As you all know, React is a widely used JavaScript library to build user interfaces for applications. This video will make you realize why it is adopted so widely. So first, we'll build a calculator app, and then we'll move on to building a Spotify clone.
This time we're going to introduce you another very interesting project using this JavaScript, HTML and CSS, so-called calculator application. So let's get started. let me try to delete first those files which we really do not need it now. We delete those all. Yeah. Now I'll be creating a new folder now and give the name called calculator app. And in this calculator app, once again we need some new files which is called index.html, and we also need one more that is called app.css, and another one that is called app.js. So these three files required. Now first of all, I would start with index.html file where we'll be creating a template of my code. Now let me go and create this template, and here I have got body with me. Let's start with the first tag here that is called h1, and this h1 we are giving the name called calculator app. So that will be my h1 heading. After that, we'll start working with the div tag. Now within this div, I have to create lot many classes. I may not have lot many CSS classes, but we can give some classes here. So we can say class equal to container. Okay. So within this div tag, we're going to create a table now because I want to organize it. So I'm starting with the table. Within this table, a tr tag, and within this tr tag, I need a td. Now in this td, I need few things call span equal to 3 as a value, and here I want to offer the text box input type equal to text. Okay, input equal to text, id equal to, give the name called result. That will be the final outcome while pressing all the different buttons, id equal to result, and class equal to screen. Remember, I haven't created those CSS classes, but we're giving some names, but later on we can utilize it while creating those CSS classes. Table data is getting closed. Let's get started with another TD. Now inside this TD, we need another text box. Input type equal to text, and here in this input equal to text, sorry, I would like to better say button because I'll be having buttons. Okay, input type equal to button, value equal to C, and on click equal to, I may not have any function right now, but yes, I can create a function, but let me give some dummy name here. I'm saying clear screen. Okay, so that will be the function we get called, and after that class equal to clear. Yeah, so this is my button tag. After this, the TD tag is getting closed. After the TD tag, the table row is also getting closed. After the table row, which is getting closed, we're going to start working with another table row. Okay, and in this table row, I'm going to create one more TD. So let's go and create another TD here, and inside this TD, I'll be having another button to be get created. So I'll just say, this is my another button now. Input equal to button, value equal to 1. On click equal to, I'll be calling another function called display. Okay, and inside this we're giving the value called 1. Okay, and class equal to number. Class equal to number. And here after that the TD tag is getting closed. Okay, now we have to start another TD tag here. Okay, like that we have to keep on creating the multiple buttons. So let me copy and paste another table data. Now here again value equal to 2, on click equal to display, give the value called 2, and class equal to what? Number. Like that I'll keep on creating multiple buttons, but first check how it actually looks like. Now I can see the buttons like in C 1, 2, 3. But yes, I'm going to create few more buttons one after another. Okay, so I'll go here and create few more buttons. So this is where the table data is getting closed. Okay, I'll copy this and paste it again. So I have to create the button like in 3, 4, something like that. So after this 2, we're giving the value called 3. Yeah, I'll give the value called 3. So value equal to 2, value equal to 3, display 3. And then afterwards, just giving the value called forward slash. And here also we're going to give the value called forward slash. And here class equal to operator. After that, we have to give the value called 4 and then followed by 5, 6, 7. So here we give 4, 4, 5, 5, 6, 6. After 6, we're giving called minus. Okay, once again it will be what? Type of operator. Okay, after this minus, we'll be talking about called 7. Then we have to have 8. Okay, 9. Okay, after that we're giving called plus and display plus class equal to operator. Okay, so here you can see the table data is getting closed, and here the table row is also getting closed. And after this table row, you can start working with another table row here. And after this table row, we can start working with again TD. Let me have this again. Inside this, I'll be giving the option called decimal, which is value equal to dot, and here we give the value called decimal. Okay, now display 0. So after giving this dot, it will basically take what? The value 0, which we haven't put now. We'll be talking about value called 0. So here the decimal value we've given it, TD is getting closed. Let me have the another one. Zero. So like that we have to give this now. After that, we'll be once again taking this time, rather than giving this 0, we'll be using this call as a button and value equal to on click equal to solve. Okay, and in this solve will not be passing anything. It will be like a normal function, and class equal to equal. Okay, so table data is getting closed, so we will be using another table data now. So here it will be the button only. Okay, we will be using value equal to multiplication, display asterisk, and here we'll be using operator. Okay, so table data is getting closed, table row is getting closed, table is also getting closed here. Okay, so your div tag is also getting closed here. Okay, that's it. Okay, so that's the only thing which we wanted to make. Let me try to refresh and check. Awesome. So we have got all those necessary calculator behavior which we wanted to reveal. Okay. Now our next statement will be, once we are giving this C, then we have to call 1, 2, 3 and then forward slash followed by 4, 5, 6 will come down. Okay, so let me check whether we have used 6 or not. Okay, so we haven't used 6. So let me check here. 4, 5, 6. So let me go back here. 4, 5, 6. Let me copy this and paste it later on. Before minus. Six equal to number. Okay, so we're almost set now. So we are having this look and feel. In this we are giving 1, 2, 3, 4, 5, 6, and after this we have a call minus and then plus related behavior. So we are all set now, and after that we'll be basically applying the CSS as well as the JavaScript look towards my code. Okay, thank you. Well everybody, we're all good to go now, but I just want to first check whether my this outlook is looking properly or not. See, what my expectation is, after 1, 2, 3 forward slash, I really want to bring 4, 5, 6 to the next, and then 7, 8, 9 and again forward slash, but I can think this is absolutely unorganized. So after this, when we say this forward slash which we have used after hyphen, okay, your TD is getting closed here. Okay, so here the TR I also want to close here. Okay, and after this TR I also want to start another TR here. Okay, so that I can put them into the another level now. So under this TR I can use this TD now. So after this minus, after 4, 5, 6 minus, once again I would like to start another table row here. Okay, so that it likes go to the next row. So here after TD we're closing this TR and starting another TR now. Okay, we're starting another TR. After that we talk about 7, 8, 9. Okay, plus, see here, talking about 7, 8, 9 plus, here the table row is getting closed and it is starting right now like this. See, that looks better now. Okay, but still few more things which I would like to make it even more organized, but that's not a problem. We will do it little later on. Okay, because you can see 8 is missing right now. So here 7, we copy this, equal to 8. Yeah, that looks better now. So now they are basically completely organized. So the moment I expect my application, so we have a call dot here, then 0, then equal to, and then we have a call multiplication. Okay, so looks better now. Now I just would like to perform the overall look and feel. So I need to go ahead and use what CSS, because without CSS I really can't utilize this in a proper way. So I have to start working with the CSS front now. In CSS front, how to start? First we will go back to my code, and here in my CSS we'll start working with font family. But before font family, I would like to start with the body part now. Body, background color I'm using called teal. That looks nice. Okay, so I will be using this app.css in my HTML to see the look how it is being appeared right now. So in my index.html file, on the top under my head section, link, style sheet, okay. Now see, it looks better now. Going forward, in my CSS, we want to use some H1 color too. So here, we would like to use the H1 text align, center, color, white, margin top, we would like to use 50 pixels. This is for H1. Let's check. Perfect. So it is now coming in between. Next statement will be called screen. So we say dot screen. So in this screen, we use the background color gray, and after that border solid, black, and with 2 pixels. After that color white, font size medium. Next width, we are using this 100%. Then we talk about cursor. We'll be saying what the default cursor is. Okay. Then padding, we would like to say 10 pixels. And then margin, say auto. Then margin bottom, that I'll be using 10 pixels. So it is a proper alignment. Okay. Look, that's how exactly we want. That's for a screen where the exact outcome will be visible to me. And rest of the details will be showing you one by one. Now we'll be talking about called input. Okay. Input type equal to button. For input type equal to button. Okay. Input type equal to button of type what? Hover. The moment I hover on my button, I say background color change to what? White, or else I can say white smoke. Okay. And when the button is active, what I want, let me copy input equal to button, and here I say active. In this color should be orange red. Like this. You can see now how it is basically looking like it. Okay, active, the color will be like this. Okay, now I'll be talking about called operators. Operators should behave different. So I'm saying dot operator. In this operator, we are saying background color orange. Okay, then padding, I want 5 pixels. Okay, then I want color, that should be black. After this, I'm using called border. That border, I'm using this called solid, and then black and 2 pixels. After this, width, I'm using 100%. Then height, we're using 40 pixels. Then cursor, it has to be pointer type. Okay, that's it. Let's check. Perfect. So they should turn back to what? to your orange color. And you can see the moment I take my cursor on it, turns to white. Perfect. And now those who are type number, I also want to change them. So for number, I want to say the same option. Padding I want 5 pixels. Then I need height of type 40 pixels. Then I say color. It looks, I want to say called black. Then border. I want solid. Black and 2 pixels. Solid, black and 2 pixels. Then width. I would say 100%. And cursor, once again, point. That is for number. Let's check. Awesome. So they looks nice. Now we left with few other type of options like a dot and equal to. Okay, that I'm talking about called decimal. For decimal, I need to have a different options with me. Okay, so let me try to copy this, paste it, and I say for decimal. So for decimal, background color will be light blue, padding 5 pixels, color black, border solid. Okay, black 2 pixels, width 100%, height 40 pixels, fine, and cursor pointer. Perfect. Okay, looks nice, but I have changed the color to light blue now. Now I talk about clear. Okay, now come back and say clear. Okay, in this color, background color is I'm changed to light salmon. Padding 5 pixels, color black, border same, width 100%, height 40 pixels, fine. So cursor, pointer, fine, margin, auto, and margin bottom 10 pixels. Let's check. Perfect. Now it looks beautiful. Okay. Now here, after giving these details, we're talking about called equal part, dot equal. So for dot equal also, I'm just copying the same. So give a call, background color, padding color, just change to light green. And after this, since it is an equal, so we say padding 5 pixels is okay, color black, fine, border, fine, width 100%, height 40 pixels, color and cursor pointers, just I don't need to. This is for dot equal, and I want for container. In this container, width I want 40%. Width 40%, background color white. Okay. Now here, padding is 15 pixels. So display block. So first of all, we have call width. We say display block, which we're taking margin. Okay, in margin we say 100 pixels. Auto. Okay, now align self equal to center. Okay, border radius, which is say 10 pixels. Okay, now we're saying box shadow 5 pixels. Black. And padding, so these are the details I have it now. Okay, we have it. Background color, we are taking it now. Align self, display block, border radius, padding, and now padding 15 pixels we have given already. I don't need to give it again. Margin, okay, fine. Box shadow, let's try. Awesome. So it's looking beautiful now. Okay, so this is where exactly my application works like that. And table, when we talk about, here we're saying width 100%. Okay, that's it. Super. So it's now giving me the proper look of how my application should behave like it. Just see about the container what we have done. With 40% we're taking background color. Let's bring it below. Then align self, display block, okay, margin, okay, and border radius, and fine. So I think we're all good now. So that's it. So we'll try and implement the JavaScript part. Well, everyone, so our CSS file is ready, our HTML is ready. It's time to just go ahead and talk about my final portion, that is called JS part, where I want to basically perform some calculators. Now here I just say function display which takes var as in parameter and say document dot get element by id. Here I'm saying result, okay, dot value, okay, plus equal to var. Whatever value we are adding it, just it basically try to apply calculation on the top of that. Okay, that is the function. After that, we have another function available here called function solve. Here in the solve, we just use the value called let x equal to document dot get element by id result, okay, dot value, dot value, okay, and say let y equal to perform the calculations. For that, we'll be using one function called eval and type x as an parameter. Now the next statement will be again document dot get element by id result dot value equal to y. Okay, now later on I'll like to use another function here, function clear screen, and here we say document dot get element by id. Here we say result dot value equal to, like that. So clear screen, solve, and display, three functions are associated with me, and these three functions are the part of this JavaScript file which I'll be calling it at the end before the body tag get closed. So here script equal to app.js. That's it. Okay, let's try to execute now. Here, 2, you can see the values. I will say plus 6 equal to 8. Absolutely clear. I say C is clear the screen. 6 divided by 2 equal to 3. Awesome. So friends, your calculator application is ready. Congratulations to all. So it is a very simplest form which we have developed. This is your HTML, which is a template for you. This is the CSS, which is your complete the area of like how the look and feel will look like in of this template beautification. And here last we have a JS, which is smaller logic but really meaningful. Okay.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
Let's start with creating a simple demo on React.js, and we are going to create a simple application that will connect to an online music streaming service called Spotify, and we will call our application Music App. So let's get started. The first step is to first get the Node.js platform and server installed. To do that, let me go to Google and let's just type Node.js, and here is the website nodejs.org. There are two versions available, the LTS, which is the stable version, and the current. We'll prefer the stable, so we'll click on that, and you can see we have an option which is called save file. The moment this file is saved to the disk, we just need to double click on it and keep clicking on the next button to get it installed on our system. And we also have a documentation available here, so which explains most of the features of the Node platform, and there are binaries available for different OSs, Mac, Windows, etc. So you can select the right bitness, 32-bit, 64-bit, and the right OS, and then go ahead and download the specific version that suits your platform. And you can see here that there are different, there are also help files available that will allow you to go through the installation documents for Node.js installation on Linux, etc. So to start with, I'm opening up the command prompt, and here is where we're going to call the Node Package Manager. Using the Node Package Manager, which is pre-installed with your standard Node.js installation, we will initialize our React application. So we would say React-app, and we want to now go and create an application called Music App in this folder. So as a prerequisite for the demo, all we need to do is install Node.js from nodejs.org, the official website. Just download it and install it, and that's when you open the command prompt, you fire npm, which stands for Node Package Manager, init for initialize. React-app is a standard keyword to initialize and create a skeletal structure of a React.js application, and the name of the app is Music App. So we'll hit enter, we'll give this some time, and you can see it's started downloading the core React.js libraries, and it is attempting to create our application. So it's installing all the prerequisite packages and scripts that are required to initialize and create a new React.js application called Music App. Now once this application is created, all we would require is an online editor. So you could use an offline or an on-premise editor as well. So any editor of your choice, it could be Atom or Sublime Text or WebStorm. And for this demo, we're going to use Visual Studio Code, which is a free editor available by Microsoft, and you can just Google for Visual Studio Code. Again, this is not Visual Studio Professional Edition, etc. that we use for building our C# or MVC based applications. This is a lightweight editor for building JavaScript based full applications. So while this installs, let's go and take a look at Visual Studio Code. So this is the Visual Studio Code editor, and this is the editor that we've installed directly, downloaded from visualstudiocode.com and installed it. And all we need to do is open up this folder that would be created with all the prerequisite files in it. We just say file open folder, and we would open that folder within our Visual Studio Code editor. So we'll give it a while until that application gets generated, and once it's created, we will again implement the component based design and architecture and the data flow between the components. And we'll also look at connecting to a live data source, which is a JSON set of characters that we would consume, which is a RESTful service. The set of music tracks exposed as a RESTful API endpoint by Spotify, which is a premium streaming service. We will connect to that, and we will look at accessing some of the music tracks on that website. Okay, so we've got the application created here. So let's minimize this, and we'll open up our editor. All we've got to say is file and open folder, and let me go to the React.js demo folder. So this is the music app that got created, and that's exactly what we're going to open up here. So we'll navigate to that folder. It's called music app. We'll select it and have it opened in our application. So you can see here we've got a node modules folder. This has all of the pre-installed packages that make up the React.js library. We've got a folder called public, which will have the index.html file. That's the root file that will launch. So this is the single page application that we typically create in React. You have a single page on which we're going to load multiple components. So that's the index.html, and then we could go and create our folder structure. Currently, if I open the source folder, we can see a single app.js file, and that basically is the file that has the source code in JavaScript for a single component, which we are interested in adding on to our page as of now. So we just have one component, which is the default root component. That's the app component, and it has its corresponding CSS file. And then we've got a public folder with the index.html file, which is going to be the root HTML file that launches when we run our application. So let's go right up here, and let's add a link to an additional file. So I'm going to link to another style sheet. Okay, so we'd say relationship is equal to style sheet, and the type is going to be text and CSS, and we will reference a file called reset.css, and this is a file that we'll look at adding up later on. It doesn't exist at this point in time, so we will connect this, and that's purely for styling purposes, so that we can have all of our CSS styles defined there. Next thing, I'll right click on the public folder. We'll create a new file. We'll name this file as reset.css. So that's going to be the CSS file that will have all of the CSS styling that we're going to apply. And I'm going to use a ready code snippet for the CSS code. So let me just, all I'll do is I'll just go and pick up a ready CSS file that I can just go and use. If you look here, I have a set of CSS files that are created that we're just going to use within our application, and that will avoid us spending a lot of time on the styling, so that we can focus on our core concepts, which is actually learning how component-based architecture works and how do we set up components and have data communication between them in React. So here is a file called reset.css. Let me just fire up Notepad, and I'll just open up this file, copy up the text here, and I'm going to just paste it within my reset.css. And if you look at the code, very simple. It's all about styling. So we've got article, aside, etc. all HTML5 tags set up as display blocks, so they take up the entire width of the page. We've got some padding, margin, and font size, etc. defined. We've removed list styling for the unordered and ordered lists, specifying the line height for the body tag. So basically just styling up tables, and so nothing to do with React here. It's just about simple CSS that we've added up, and now we need to actually go in and dive into creation of the components that we need. So let's right click on the source folder. So I'll select the source folder. We'll right click there, and that's where we're going to create a new folder which is called components. Okay, so this is the components folder now that's going to hold all of the components within it. Within the components folder, let me create another new folder, and I'm going to call it app. And this is exactly how we are expected to structure all of the code that we have. Now, I already have a CSS and an app.js, which are the root components that were added by default. And all I'm going to do is I'm going to move them within this folder called app. Okay, so there is a proper segregation of responsibility, and all of the code that deals with a particular component is all added into respective folders, and this really improves the maintainability of the application going forward. Now we'll need some images, and I'm just going to make use of some set of images that I've downloaded from the web, and here are the set of images that I have. So I'm just going to copy all of them, and we'll come to our music app, and we'll go into the components and app folder, and that's where we're going to add all of the files, and you've seen all of those image files getting added. So these are just icons and images we're going to use for our music tracks inside our application. Now let's move to the app.css file, and this is where we've actually got so the app.css file is the file that's going to style up all of the style rules that we've added into the root app component, and this is what we'll have to revamp. So I'll just get rid of this code, and we'll probably add something for the body tag, the HTML tag, and the root element. Let me say #root, and let's set the height to 100%. Coming to all of the HTML across the page, we'll give it a font size of 10 pixels, and the H1 elements, let me give it a padding of 0.77 and 0. Let's set a background color, give it a background color. I'll just select some random color here that can be applied. Then we'll set up the text alignment, which is going to be the center of the page. We'll set up the font family. The font family is, and this is part of sans serif. What else do we add? Let's add up the font size, 1.88, and also the color. So again, these are standard HTML and CSS elements, so nothing really that has to be done that is specific to React here. So again, we are bringing in the highlight class. So there is a class called highlight that we will create later in the HTML view of this component, and we'll set this to a red RGB component. So combination of 46, 113, and 238. Okay, so that's pretty much done. Let's move on and also add up for the anchor tag. Let's add up some text decoration and set it to none so that the anchor tags don't come up with those underlines. And of course, we'll provide a color of hash. Okay, so a white color there. Now coming to the H2 element. For the H2 element, let's have font family. And again, I'm going to use the font family that we defined here, bracket, and we'll change this to probably 1.55. Okay, now coming to the app tag, let me just save this and create a copy of it. There was some content that I did delete, and I can simply go and make use of it. So I've just undone all of the deletion. So this is something that I can, if I can use something, I can just probably use it from the tag below. So let me start with a height here, and let's say the height of the header is 100% of the app, sorry, not header. Padding 0, 17%, 10%, 17%. The background, and I'm going to change that to background URL. So the background URL, or let's say the background image, will have a URL property. Okay, and that URL is going to be ./pg1.jpg. So that's the image that we've added some in the previous step. Let's also add background size. So we'll add background size and set it to cover. I'll also need a background position, set it to center. Let's have background repeat, which is set to no repeat, so that we don't have the image in a grid format. And then I would need this, so get rid of it. Let's take up the font family. We'll maintain the same font family. Let's use font weight. The font weight is going to be 500, and the color is going to be hash, so that's a white color. Then we come to .app.playlist. So that's going to be another class that we are going to use, but app-playlist is what we're going to name it. And let me say that the display should be flexible display, and we will justify the content to leave spaces in between. All right, so that finishes that bit, and now let's write up a media query for the responsiveness of this page. So this is media for only screen, and max width is going to be 1020 pixels. Okay, and the class name that we'll provide later is obviously app playlist. So for this screen size, we would align all the items to the center, and we change the flex direction. Okay, so we seem to be good with the CSS for the app as of now, and that's the app.css that we created. Let me save everything. Okay, let's check for any kind of additional. So all free of errors, no errors now. Things are good in the app CSS, and it's time to move to the next step of building this application. Now we'll have to go and add up the code for the app.js file. So let's dive into the app.js file, and this is where we will actually need to go and add all of the code that is required for the app component. So all the code that's relevant to the app component, we are going to add up inside this specific component itself, which is going to be obviously the app.js file. So we have skeletal code, which is importing the React library, and let me get rid of the basic sample logo. We'll have app.css that's getting imported here. Besides that, a lot of other files that we'll have to get in. So let me import playlist, and these are the components that we'll create as we go forward, and we are going to get this from the playlist folder, and the component, the file is going to be called playlist, so we'll add that. Then we'll have to go and also import search bar. So what we're basically doing is we're going to split this app into different components. There's going to be one component that manages the playlist of all the tracks. One component will act as the search bar. So that's the search bar component that we're going to add. So searching for tracks will be managed by this. We'll have another component that we'll create that will get imported into the root app component, which is search results. So this is going to display the record set with the set of results as an outcome of the search criteria. So search results / search results. And finally, we'll go and import Spotify. That's the Spotify service from. So we'll create a utility folder which will hold the code that connects us to Spotify. So that's what we are adding up next. So all of the imports are done. One component that manages the search bar. So that's search bar, search results. Let me correct the spellings there. That's search results, that's Spotify, and playlist. So that's done. Now let's move on to the class that we're going to create here. So let's create a class app that goes and extends React.component. So that's going to be a React.js component. So that's a constructor. We discussed about props or properties and state management, and that's what we are implementing. We are using the super keyword as a best practice so that all the properties are initialized in the constructor, and also we pass the values up the chain to the super class, which is the root component class. Now we're going to initialize a variable called state that's going to manage the state, and we are interested in tracking our search results. So we'll have multiple results, so we'll store that as an array. The playlist would have different names, so we'll just call ours new playlist. That's the default name. And we will also store a list of tracks, which is going to be playlist tracks. So playlist tracks is going to be our list of tracks, and let's close this block. Okay, and this too is going to be initialized within the constructor, so we'll add it here. And now we need to do the binding. We discussed data binding, so let's look at creating a search variable which will hold this dot search dot bind and bind to the context of this very class. So we are passing this pointer. Then we'll create another variable called add track weights to this dot add track dot bind, and all this functionality is what we're going to add going forward. So right now we're just setting up the bindings. Then we'll have capability to remove a track, so we'll say remove track. So remove track equal to this dot remove track dot bind, and let's fix that. So, and all of this too is going to be initialized as part of the constructor, so that's where we're going to add it. Then we'll need to update the playlist name. So we'll need functionality that will help us to update the name of the playlist. So functionality that helps us to update the playlist name. So this dot update playlist name is equal to this dot update playlist name dot bind, and this is the pointer that we'll pass. I need to save the playlist, so this dot save playlist equal to this dot save playlist dot bind and pass this. And then I would also need to remove the track that has been searched for from the playlist. So remove track search equal to this dot remove track search and dot bind. And finally, one last function that executes all of these, which probably will bind to this context. So all the declarations are done in the constructor. Now we need to provide the definitions for all the methods that we actually have added here. So let me select this, tab inside, and let's start with the search function. So we'll define the search first. It takes some variable value that it searches on, and then I'm going to say Spotify dot search. I'm going to search for term dot then, and that's an observable. So the moment the search returns a value, it's going to call this callback function, and that's when we want to set the state, and we're going to set the state for search results to whatever is passed by the system. So the search results are going to be returned as a callback, and that's what we'll store as an updated state. Now coming to the add track method. So let's scroll up and we'll say add track, and this will take the track to be added. Let's declare a temporary variable called tracks equal to this dot the current state of all the tracks that are there in the playlist. Now if tracks dot find, I'm going to call the find method. So if we are able to find, which means that the track is already there in the playlist, then we would not want to add it. If it's not there in the playlist, that's when we would want to go and add it. The triple equal to is an equality operator that will check for both a value match and a match on the data type as well. Okay, so if the track is already saved, do nothing. If the track is not saved, just track the track ID, because that is the track that will have to be added. If it's already there, then just return. If it's not there, then we've got to go to this variable called tracks. We'll use the JavaScript method called push, and we will push the current track into this tracks array and then update the state. So we'll want to set the state of the playlist tracks, and this is how your state management that we discussed in detail is actually being practically implemented here. Okay, so the track has been added. Now let's talk about the remove track. So that's the remove track function, and that's the track that we want to remove. So let's let tracks equal to this dot state dot playlist tracks. Those are the set of current tracks that we have, and let track search, another temporary variable, equal to this dot the current state of the search results. Then let's take the tracks array equal to tracks dot filter. So filter is a JavaScript function that will again allow you to remove a certain value. Create a temporary variable called current track, use the lambda operator, and if the current track dot id is not equal to the track dot id, which means this particular track is not there in the list. Okay, so you need to remove that, and again I have a method called as unshift, which will actually get rid of the track in the array. And then we've got to, so we'll search whether that track is existing in the tracks array. If it is, then we simply want to remove it. If not, we do nothing. So we set the state. We need to update the state of the playlist because a track has been removed. So the playlist tracks will have to be updated with this tracks array. Okay, then we go for remove track search. That's the next method. That also will take a track as a parameter. Okay, here we are going to say let tracks, which is another temporary variable. We'll give it the current state of search results, and then we are going to say tracks equal to tracks dot filter current track dot id not be equal to the track dot id. And then this is where we would want to say this dot set state, and we'll pick up search results, and let's go and assign that to track. So that's the updated set of tracks after making that change. Let's remove this and correct it. Okay, so that's fine. So the remove track is now, the remove track and the remove track search is now in place. Let's add these functions, which actually again takes track as a parameter. And here we'll say this dot add track. Okay, so it adds the track and then it removes the track from the search criteria. So the search component, which is managing searching of the tracks, that will go and remove it from there after adding the new track. So that's a combined operation we want to execute. Then I've got update playlist name, which will take the name of the track to update. And this dot set state, the playlist name is what we need to update with the name that is passed to this function. Then we've got to save playlist. So here let me create a constant variable. Constants are variables whose values will not frequently change. We'll take all the track URIs. Dot state dot playlist tracks will be dot map, create a temporary variable called track dot URI. So we actually want to go and now save this on Spotify. So that's the reason we'll access Spotify's save playlist method. This dot state dot playlist name comma track URIs, and if that is successful, we then go and do a callback. So that's the callback anonymous function where we're going to say this dot set date, and the playlist name that we want to create on Spotify will be called new playlist. So that's the custom name that I want to provide. And the playlist tracks, define that. This closes here. Okay, so that's for the update on Spotify. Now here is where the render method is going to return the HTML. Now this HTML is the view, and React simplifies this by having the JavaScript and the HTML in the same file, so you can actually go and access the variables you've declared in the script directly in your HTML view and synchronize and bind the data together. So it helps from a maintainability perspective. So even though everything is in the same file, it's well classified and differentiated into different code blocks. So we'll add the anchor tag and we'll say href is HTTP localhost. So that's the default server port on which this application will run. Okay, and we want to give it a custom URL name of musicophile. So the h1 terminates. We'll then say div class name equal to app. Within that, this is how we're going to inject our search bar. That's going to be the search bar component injected here. And on search, so that's the custom event, we will call a method called search. So on search, we bind to a method called this dot search. Then we'll open up another div. Here we'll have class name equal to app dash playlist. And if you remember, that's exactly the CSS class name that we referred to in the CSS file. We have another component called search results that we're going to inject here, and that's going to be search results. Here search results will be equal to this dot state dot search results. So that's how we can actually go and bind. So that's simple data binding. The component is going to be displayed with the data bound. And if somebody says add, if I click on the add button for search results, do these. So it will add that new track to the playlist by calling binding to the do these function, and it will remove it from the search results text box. Then we have another component called playlist, and here the playlist tracks will be bound to this.state.playlist tracks. Okay, so on the top, if you look here, we started with defining all the function declarations in the constructor. Then we provided the function definitions. Okay, that's how. And this that we passed refers to the context of the current component itself. So whatever you put into the app component or into the respective component, those values will be then passed out here to these individual functions. Okay, so that's with the playlist. Couple of things we'll have to do is if somebody changes the name of the track. So on name change is going to be another custom event where we'll have to call this dot update playlist name. And we also have remove functionality. So to remove a track, we would say equal to this dot remove track on save equal to this dot save playlist. Okay, so that's done, and we close this. So we seem to be pretty much on track. The export app will make this all of these functions accessible across other components. It's very similar to the public access specifiers, etc., that you provide in other programming languages. So that's done. We've created our app component. Now let's create another folder under components, and we've got to define all our various components here. This folder is going to be for the search bar, so we'll name it search bar. We'll add 2 files within it, the search bar.css, okay, and another file that we'll need here is search bar.js. So that's in terms of the search bar. Let's start with the CSS file. So we'll start with first styling search bar. We will say that the display should be flex direction should be column. We want all the items to be aligned at the center, so that's align item center. Then we'll add up padding. So padding top is going to be 6.94 rem, and margin bottom is going to be 6.33 rem. All right, now let's add up for the search bar. So that's search bar. We'll add for the input element, we want the width to be 287 pixels, the padding to be 0.880, the border should be 1 pixel solid white. The border radius will give a slight rounded edge to give a web 3.0 look and feel, so we'll set up the border radius. Then we've got margin bottom, so we've got a bottom margin that we want to add up. Then we have color, so let's add up the color, C3F, so that's the color, black. Then let's add text alignment of center, and let's add up a font size of 1 rem. Okay, so that's how we've set this up. Let's add the search bar. Input is going to be, so if someone focuses, so focus is the got focus, so if someone clicks inside, so if the end user goes and clicks inside the text box, we change the outline to none. Okay, and so for the search bar, we are interested on input, and if the input is focus, so that's the event that we are looking for, and then we would have a button called search button. So on the search button, the cursor, we'll set it to pointer, so that's the cursor pointer. The width, we set it to 8.11 rem. The padding, we are going to set up to 0.77 rem and 0. The border radius, we'll set it to 54 pixels, so we get a slightly well-defined search button with a nice little border. Let's also add background color, #1db954. That gives me a color. Then I've got my text alignment. Let's set that to center. Then we've got our font family. Let's set up the font family to the same standard font, AT, and it's a part of the sans serif family. Then we'll set up the font size to 0.833 rem. Correct this. And finally, we will need transition. So all of these are basic CSS properties. So that will add a slight transitional effect with a delay of that many milliseconds. So transition, background color we've provided. What else? Let me scroll up. Let's also provide a border here. So we'll remove, in fact, let's remove the border. We would not want a border on the button, that would look odd. So I'll get rid of the border. And color we'll specify as per our standard color that we've been using. Okay, so that's the color we've specified, and then I've got font weight of 500. Finally, we'll take the search button, and on the search button we will register for the hover event. So if someone takes their mouse over the button, that's the hover event. In that case, if we hover around the button, we would want the background color to change, so it will appear to have a slight little glow there. A mouse pointer moves over the button. Okay, so that's the opacity and the RGB combination. So that completes the CSS file for the search bar, and we obviously now need to go and get the code in for our search bar component, and that's exactly what we are going to do next. So let's start with setting up the code for the search bar. First thing, let's go and import React from React. Next thing we would want to do is import the search bar dot CSS file. Then we define our class called search bar, which extends React dot component. We define our constructor, and we go and pass these parameters to the base class. We also define the state. We'll just need one variable here, which is the term to search for in the search bar. And then let's say this dot, we'll define a function called handle term change, which is going to be equal to this dot handle term change dot find. So that's going to be the first function. Then a function that will do the searching for us, which is this dot search. So that's the search function, and we'll have it bind to this. Then we've got this dot handle enter. So the moment we enter into that search text box, handle enter dot bind this. So the functions are ready. Now let's go for the first one, which is handle term change. We'll pass it a system defined keyword of event, this dot set state, and for the term we will use the event keyword. We will get the value that is there inside that text box the moment the search term the user has entered changes. So the search criteria changes, we trap the updated value. Then in the search function, we will update the local property props.on search. Okay, so we'll access the on search and pass it the updated term, and then we got the handle enter, on which we're also going to pass the system defined event keyword. So if there's any data flowing along with the event, we're interested in it. In this case, the data is the key code that the user is pressing, and if it is 13, that indicates that's the ASCII key code for the enter button. So if the enter is hit, then the user has completed entering the search criteria and we need to start searching. And that's where we write our render method that's going to render the HTML view, and we return the complete view here. So that's the view now that we want to return. Let's say div class name equal to search bar. Then on the input text box, we will use placeholder equal to enter song, album, or artist that you want to search for. On change, on the on change event, the moment the term changes, we connect that to handle term change. We already have a function that manages that. And the moment keys are pressed and released, so on key up is where we would want to connect to this dot handle enter. Okay, and this is brace bracket that I'll have to put up here. So in the render function, we're going to return a value. I shouldn't forget to export the search bar. Okay, so that's what I want to export. So we've exported that. Okay, so at the end of this, what we've done is we've written our render method. We've written our div tag. Here is where we'll go and close the div tag. We've added an input, and here is where I'm going to add a button, provide a class name called search button, and the moment the end user clicks on the button, we're going to connect it to this dot search, and we close the button tag. Within the button tag, search. So that completes the render function. So in the render function, again, let's run through all of what we've written. We started with extending React.component. We then added a constructor, passing props to the super class constructor. We created state. We set it to a value of term and null. So the state currently we defined as term. Then we said handle term changes, search and handle enter should be functions that we want to add. Then handle term changes we defined, search we defined, and handle enter we've also defined. Then we used render. Render we said is going to return to us the HTML that we've specified. Okay, we dumped all the HTML that we want this component to return to us. So on change and on key up are both two functions that or two events that we connected to, where we called handle term change and handle enter. Then we added a button where we registered for the click event and connected it to this dot search. So all the three functions that we had actually written. So two things we've completed now. In the app class, okay, if you look at the app class, we've actually defined a set of functions here that deal with the playlist and adding applications, etc., adding tracks, removing tracks. Then we've created the search bar. Okay, so we saw that the search bar also, we have specified a set of functions, and all the functions that we defined, we have taken care to structure every component separately. So the search component is doing something completely different, which is managing the search bar. We have the core, the root app component, in which we have imported all of the other set of JavaScript classes that we are creating. And that's how the entire application is now structured. So, and that's the core concept when you're working with React, where you would actually have every separate block of code or every separate functionality handled in a different component altogether. So we've completed the search bar component as well. So two components done and two components good to go. So we've got to start up on the next set of components that we will need to build. And the next component is the track component that will manage individual tracks. So a new folder, a new file called track.css and track.js. So that's going to manage the tracks for us. So let's start with .track. We would say display is flex, align items, center, border bottom, 1 pixel, solid, RGBA, 256, 256, 256, 0.8. That's the opacity. Then let's come to track action. So we'll use all of these classes when we write up the HTML view. We'll add a padding here of 0.5. We'll set up a font size of 1.05. Set up a transition color of 0.25s, border of 0 pixel, and a background color of RGBA 0000 color hash. So that's the color that we continue to use. Then we bring in track, another class, track action, and if we hover over this class, we want the RGB values change to 265, 265, 265, 5 as the last parameter. So that's the hover. Then we have track information. So track information is the next class that we're dealing with. We'll add the flex parameter first, display flex, and then flex direction is going to be column. Let's have justify content set up as center, and let's have height as 180 pixel. So that's track information. Let's have another track information and the h3 tags nested inside that. For all the h3 tags nested inside that, we'll need a margin bottom of 0.22 rem. Finally, let's have track information and paragraph tag. We'll have the font size of 0.83 rem and a font weight of 300 and a color as well that we'll add. So let's add up a color here, RGBA 256, 256 and 0.8. Okay, so that's in terms of the CSS. And let's move to the track and we'll move into the JavaScript file. So let's move into, so let me take what we added in the search bar. I'll go to the track.js. This will change to track.css. Okay, the constructor, this will change to add track. So add track, change this to add track. This is remove track, change this to remove track, get rid of this. And that's going to be the add track function. And here we are going to say this dot props. So we'll modify this dot props dot on add this dot props dot track. And then we have the remove track. So that's going to be the remove track function. This function is not required. So this dot props dot on remove, and this is the track that we would want to go and remove. We'll add up another function called render action. So this is going to be a function that we are defining called render action. And in this we'll just check if this dot props dot is remove. If this dot props dot is removal, so in that case we would want to return. So this is a view action method that we are adding, which is going to go and add this button with a class called as track action that we've already written the CSS for, and this button will actually get added via this render action function, and this dot remove track is what it's going to map to. Let's close this. This is going to bind to this specific function. So that's the closing button tag. Okay, so the closing button tag is what we've added there, and the binding is what we have done to this dot remove track. And we will terminate this here. So now the render action, let's also have the return here, and we just add up the button, and this is going to add track. So you can look at how the component is completely dynamic in nature. So we have two buttons that are going to be added. This button with a hyphen is going to remove the track. This button with a plus sign is going to add the track. And you can actually see how simply it was done in a render action function. So the render action function actually helped with checking that if on the value of the props, and if the user, depending on the action performed, you will actually be able to remove a track or add a track from the existing playlist. Okay, and then the class name here is now going to be track. The class name for the enclosing div inside it. So let me get rid of this. The class name for the enclosing div here is going to be track-information. Within it, we'll add h3. We'll bind to this dot props dot track dot name. So the name of the track is going to get bound here. Then in the paragraph, we will bind to this dot props dot track dot artist, and with some gap, this dot props dot track dot album. So that's what we've data bound to. And then let me add an iframe. An iframe allows us to very easily inject some content into the page within a small embedded window. The source parameter of the frame is going to be https open dot. So here I'm connecting to the Spotify stream, spotify.com/embed/track, and close this. So that's the Spotify stream that we are going to connect to, and this dot props dot track dot id. So that's the track ID. The width is going to be 300. The height parameter, the height parameter is going to be 80 of the iframe, and the frame border is going to be 0, and the allow transparency, so that's the opacity, we'll say true. Let's add allow encrypted media. So if Spotify has encrypted media, that also would be embedded here, and we can also have the title set to preview. So that's with the iframe. Okay, at the bottom is where we would want to, so this could be an empty element and we can close it right around here, so we wouldn't need this part. And then here I'm just going to say this dot render action. So we call the render action method, which will actually give us plus minus button to add and remove new element. Okay, and that's what we can actually go and add up there. So let's check now whether all that we've done is good to go. Fine, so everything looks good in terms of the track component now, and we have all of the functions in place. It's now time to jump into the next component that we would require after the track component, and that's going to be the track list. So this is going to be a list component that will comprise of a list of tracks inside it. So we'll create a new folder, call this track list, and that's going to have track list CSS, and it's going to have track list.js. So that's the track list component now, which we're going to go ahead and use. And the CSS, we don't need much, so let's just say track list, and we just provide a width of 100%. Okay, that's all we'll need in the CSS. So let me add this in the CSS file, save this, and come to the JS file now, which is going to have the track list code that we will need to add up. So here again, I'm going to say import React from React. We'd also want to import track list.css, and we'd also want to go and get track, because this component is going to be made up of a collection of tracks, individual tracks. So we want to get this from track/track, and we'll define class track list, which is going to go and extend React.component. We just need the render method here, because this just needs to go, it does not really have any state of itself. It simply goes and returns a list of individual tracks. So this class name is going to be track list, and we'll bind to this dot props dot tracks dot map, create a temporary variable, and this will go and return the track component, which is going to bind to individual track data. The key is going to be track.id. So the key is going to be track.id, and on adding a new track, we want to bind to this dot properties dot, and we already have on add defined, so that's what we connect to. We add up my brace bracket here. Okay, and then we would also need is removal equal to this dot props dot is removal, and the on remove will to this dot props dot on remove. So that's for the track removal. And so we've got our track list. Oh yes, we'll have to go and also close the div tag correctly, and also we'll need to go and export. So we'll have to go and export the track list. So we've got one more component done, which is track lists, and let's move on to the next component now. So we've got app, which is root. We've got the search bar that takes care of entering the search criteria. We've got individual tracks that are searched and returned, and we've got a track list that manages a set of track records. So the track is more relevant to the playlist, and then we've got the search results also to manage. Once we search for some set of tracks, so we'll add a new folder which manages search results, and this is going to have search results.css, and it's going to have search results.js. Okay, so we need a search results.css and JS, and here in the CSS file we'll keep it simple for the search results. So we'll say search results. We'll set up the width of 50%. We'll set up the height of 950 pixels. We'll say overflow Y is scroll. We'll say padding is 0.88 rem. Background color will be RGBA 95 23 23 0.7, and we will use the box model. So we'll provide a shadow, dropping shadow of 4 pixels, 2 pixels, 2 pixels, hash, and then let's add a scroll bar. So WebKit and MOZ are the constants specific to Mozilla and Chrome browsers. So they target certain animated features, etc., or properties that are specific to those individual browsers. And that's the reason we use those constants. And then we'll also add a media query that if it goes with a max width 1020 pixels, in that case dot search results width is 90% with a margin bottom of 2 rem. Okay, so forgot to add the hyphen, so it's hyphen WebKit scroll bar 0 pixel width, and we've set transparent background. So that's about it with the CSS. I need to get to the JS file. Now let's move to the search results JS file, and that's where we will now have to go and add up the component code for search results. And let me pick this up from track list, add it up here. This will be search results, and we'll need the results will return to us a list of tracks. So we'll have to get track list. This will be track list, and I'm just going to return class name will also be search results. So that's the component, and this is going to export out search results, so it's accessible across other components. Then we've got h2 with results. Let's go and create track list with a set of tracks, and we will bind it to this dot props dot search results. And on the on add, we are going to bind to this dot props dot on add. So we already have that. So that basically completes search results, and that leaves us with the last component, which is going to manage the playlist for us. So we'll add up a new folder in components, and that's going to be playlist, and within that we will have a playlist.css and a playlist.js. So that's our playlist component now that we're going to work with. And the playlist component is we'll first set up the CSS that we will need to add up to the playlist, and I'm just going to pick that up from my code snippet. So that's my playlist, and let me get all of that CSS here. So that's just a CSS for the playlist, nothing to do with React, again pure CSS. Let me get into the JS file, and that's where we will need to go and add all of our component code. So again, let me go to the track.js, the track list rather. Let me get this and add it out here. We'll make some small changes. This is going to be playlist. I need to import the track list because the playlist is going to contain a list of tracks. This is going to be playlist, and let me here, this will be playlist, and we'll leave this for later. Okay, let me also get the constructor in. So we'll add up the constructor here, and just one function that we will need here, which is handle name change. If I need to change the name of the playlist, so handle name change, and that's exactly the function that we will need to write code for. So that's the event, and this dot props dot on name change, that's when we'll say event dot target dot value. So we get the updated playlist name. Coming to the render, we'll now need the input. Input is going to be on change equal to this dot handle name change. The default value we have already provided with a hard-coded value, which is new playlist. So that's the default value. If not provided, then we'll just pick up the default value. Then we've got track list. So track list is what I will add. The tracks I'm going to bind to this dot props dot playlist tracks. So we're going to bind this to playlist tracks, and here we will say is removal equal to true, and on remove equal to, we'll bind that to this dot props dot on remove. Finally, we'll need a button. We will use class name equal to playlist dash save. That's what we've added in the CSS. Click equal to this dot props dot on save, and here we're going to say save to Spotify. So that's with playlist, and yes, we need to go and export playlist and not track list. Now we'll need to do a quick lookup in Spotify. So let's go to this website called developer.spotify.com, and once we sign in and create an ID, it takes us to our dashboard. That's where we can create a sample application. The name of the application will be musico file. Okay, and we'll say that we are building some kind of desktop app, for example, for which we want to connect this to, and we'll also need to provide so we'll say next, refresh the dashboard. Oh, it's asking me for a login, so let me log in once more. So moment I log in, that's going to be description, and I'll say maybe this is why I need it. I'll say no, not commercial integration, agree with the terms and conditions, and we will say submit, and that's the application that has got created. And now I can say edit settings, and the redirect URL here is what is important. So it should accept connections from HTTP localhost 3000. That's the port on which we will host our application. Okay, and we'll say save. Okay, so that's now there's a client ID that is generated here for my app, which is unique. So I'll just copy that up. Let me come up to my application. Under the source folder, I'm going to add a new folder called util, and under that a new file called spotify.js. So we will start with adding our code to the spotify.js file that we've just created as a new file within the newly created util folder. The first line of code is going to define a client ID variable that equates to the client ID that we will generate on Spotify. So this is going to be the Spotify generated client ID, which is a unique ID associated for the developer to connect to the Spotify API. And we will look at the source of that as we go through the demo. The next variable that we'll create is the redirect URL, or let's call it redirect URI, and that will equate to localhost :3000, which is the port, and we'll create another variable called the access token. Let's also create another constant variable called Spotify, and this will work like a function expression. So we'll equate it to a function called getAccessToken, and we will say if access token is true, then return the access token. Now let's declare a constant variable called accessTokenMatch, which will be equal to window.location.href.match, and we will say this is equal to access token, which will be equal to, and we will give a regex expression to do a pattern match ampersand, so that we can actually get into the URL and extract the token information from that, and hence the pattern match is crucial here. Another constant variable called expiresInMatch equal to window.location.href.match. Here we will read the expiry information using another regex expression from the URL ampersand asterisk. So that's the second constant variable we've created. Now we will say if access token match and expiresInMatch. In that case, the access token should be equal to access token match of 1. Then we create a variable called expiresIn equal to, we'll do a typecast to number, and we will take the first parameter from the expiresInMatch. That's done. Then we will say window.setTimeout, and we're going to say access token equal to comma expiresIn multiplied by 1000. Then we will say window.history.pushState, and we will say access token. We'll pass the second parameter as null, the last parameter as slash, and close this, and we will return access token. Else we will say const access URL equal to https accounts.spotify.com/authorize client underscore ID equal to $client ID ampersand response type equal to token ampersand scope equal to playlist dash modify. So we are actually building the URL that will now get generated. So we'll say modify dash public and redirect URL equal to $redirect URI. So we have constructed the URL now that will go out and get generated in the browser, and here we are going to say window.location equal to access URL. Then we'll add the search criteria function, which accepts a term as a parameter to search on. Here we will say constant access token equal to Spotify dot get access token. So we get a reference to the same access token. Return, we call the fetch function, and we're going to pass https API dot spotify.com/v1/search ? That's the query string that we will add. Type equal to track and ampersand g equal to $, and we will pass term, comma. As the header information, we will need to pass the authorization, where we will say that the bearer is $access token dot then response return response.json dot then. So the return of this function, once it completes, we will then call the next function, so JSON response, and then we will say return response dot JSON. After that, another then block, so we'll now say JSON response, and if not JSON response dot tracks, in that case we will return an empty array. Else we will return JSON response dot tracks dot items dot, and we will pass, we'll create track as a variable with a lambda expression, and we'll create a temporary JSON object with ID, and that's where we want to associate track.id. That was returned as the search result. The name is going to be associated with track.name. The artist is going to be associated with track.artist of 0.name. The album is going to be track.album.name, and the URI we will equate track.uri. So that completes this block. We'll open the next, and this will be the save playlist, which will take the name and the track URIs, and here we will check if not name or not track URIs dot len. In that case, we simply return out of the code, and then we declare a constant variable called access token, which will be equal to Spotify dot get access token. So we get a reference to the access token. We then declare headers. Authorization bearer is going to be $access token, and we'll create a user ID, and now we will return the fetch result, where we will pass https api.spotify.com/v1/me. So that's the URL, comma, headers will be the header information. Then we call the then function, declare response as a variable, use the lambda expression, and access response.json. We use the then block to declare JSON response. Here we say user ID equal to JSON response.id, and then we return fetch https api.spotify.com/v1/users/$of/user ID/playlist. So this is how we've constructed the URLs manually. Here we will assign headers to the headers variable. We'll assign method as post, so the data is sent as part of the body and not as part of the URL. And as the body, we will say json.stringify to convert this parameter name, and then we will generate a response variable to response.json, and then we'll create JSON response with the lambda operation. We'll create a constant playlist ID, which is equal to JSON response.id. We will return fetch https api.spotify.com v1/users$user ID/playlist/$. Again, we are constructing the URL. So playlist ID will be replaced here. Then we will say tracks and close this, comma. And here again, we will say headers would equate to the headers variable. Be constant headers, and this close here. Okay, everything fixed now. So here we are going to say headers should equate to headers, and the method is going to be post, and the body is going to be json.stringify URIs, track URIs. And we close this, we close this block, we close this block, and we close this block. So that completes our code. Of course, one more thing we'll have to do, which is export this class out. So export default Spotify. And that completes the code for the Spotify.js, which is part of our utils class. So let's move on now to the next step. So here is the client ID that we'll have to exactly match. So I'll copy this client ID and provide it here. So that's the client ID that we actually need, and we could also store it out here. So that's the client ID, and that's the redirect URL that we've also defined there. And we just create an access token. If the access token is true, we return access token. So the access token is something that we are going to do a match from the moment we try and connect with this particular URL. And you can look here that this is the access URL that we are trying to connect with, okay, with the client ID and postfixed with the redirect URL. right? And then I've got a simple search function which returns an observable. So we try to fetch data using the search term that we provided. Okay, we try to fetch data using the search term provided. If we are successful, we get a response of the data, and accordingly we'll iterate over the JSON response and get a list of tracks out of it and do a mapping of this JSON object to the track ID, name, artist information, album name, etc. And here, just like a data access layer, very similar to a data access layer, we've got a save function which will save this data to Spotify as well. So I've got a save playlist and I've got search. So these are the two functions which will go and connect to the Spotify service by using this client ID, and it will allow me to access that information in terms of returning a stream of JSON data, and will then allow me to go ahead and push that JSON data into our application. So now we'll actually need to start up the application. So I'll go to the terminal, and rather let me go to view and bring out the terminal. So this is the integrated terminal that's there in the tool, and it just opens PowerShell from which you can actually fire your commands. So I'm going to say node package manager npm start to actually start up this application. So that's going to do a full compile, and so we will fire this up, give access. So I'll need to grant access to that port 3000. Let's give it time to run. And that's the app now that you can actually see here. So this is the search bar that we actually had. Okay, then we had the results, we had the playlist. Now the results is going to consist of a set of tracks which are maintained by the track list, and then you can take individual tracks with the plus and minus button and add them into the playlist. Okay, so that's how it's typically going to work. Okay, so as you can view here, I'm just going to search for an artist, and we'll click on the search button. It goes to Spotify, tries to connect there, and says that I need to agree to the terms and conditions, and I've just agreed to that. So the very fact that it actually gave us a confirmation link the moment we tried to connect and execute our application, that's proof enough that it actually went and connected to the service there and tried to return a value to us. So this is what we did. We just added an artist, we said search, and you can see now it's successfully connected. I've got a list of tracks available from this artist, and you can see the plus buttons getting added on the fly. So that was the render action. These are buttons that got added onto this list of tracks dynamically the moment the search results returned a value. So I can click on this plus sign, and you can see that the track gets added to the playlist. Okay, as and when I click here. So I've added a couple of tracks. If I go back to my dashboard of my Musicophile application and that I've created here in the developers portal of Spotify on developers.spotify.com, it's blank. So now I'm going to click on save to Spotify. Okay, and that clears the playlist. So let me come here, and now when I come out here, we saw that it actually got successfully connected out here. Now I'll have to log in to, so this was the development app that we actually created on the developers portal of Spotify. Now we will go to spotify.com. So I'll just go to the Spotify website, and it says, do you want to launch the web player and all that? So let me click on that. So it just launches, and can you see here, this is the new playlist that just got added, right? And there were 4 songs that had actually added to the playlist, and you can see here those 4 songs have got added out here. Okay, so I can go here and I can delete this playlist and say I want to delete it. Okay, so there's no playlist now. I'll go back here, I'll add 2 tracks, and I'll say save to Spotify. So that's how you actually saw that the new playlist, you can see the new playlist has come back here. Okay, and that's the playlist. The playlist has got generated again, and that's the new playlist that got created. And we deleted it, but it still got created again, and that indicates the connectivity that we successfully created with this React app. And the core concept of the React app was breaking it down into components, which is the search component. Then we created the track component. We created the track list to maintain a list of tracks. Then we created the search results, which will generate a list of results which further contains a track list, and this is the embedded iframe which gave us the response which is scrollable here. And you can see that the iframes we created allowed us to scroll this with this embedded web page inside the iframe container. So with that, I hope we've been successful with explaining the concept of component-based design and architecture with React and how important it is to create individual components, and the benefit of that being that you can isolate change requests to a certain component, you can promote reusability. Wherever you want the same feature to be implemented on the page, you can just inject that same component, and the same implementation and the same features can be reused. So it promotes reusability, it promotes flexibility to change, it isolates your change request to single components, preventing the massive effort of recompiling and retesting the entire application as a whole.
In this session, we'll be comparing the three cutting-edge UI development technologies, that is React.js, Angular, and Vue. We learn about the key differences that make them so distinct. All of these technology stacks have been replacing pure server-side technologies, and we've slowly progressed from server-side applications to more distributed applications where a part of the job is done on the client side and a part on the server side. And now we've transitioned to something known as single-page applications, or SPA. And all of these technologies that you see on your screen right now are based purely on JavaScript. As a result, they're lightweight and aren't dependent on any third-party runtime tools. So let's compare the three technologies and learn about the factors that make them stand out. First, we'll look into the salient features. Now, React is a front-end JavaScript library, while Angular and Vue are JavaScript frameworks. Now, although the terms library and frameworks are used interchangeably, they're significantly different. Now, library is a set of classes or functions, and the user is in complete control to call them. Frameworks, on the other hand, are like models. They have limited choices and come with a blueprint of their own. And as a result, the user doesn't have much control. So JavaScript, being an interpreted language where code is executed line by line, makes all these tools very efficient. Mainly because converting the code into an intermediate code would require a runtime environment and would definitely encounter a delay. Now these are avoided, and as a result, these tools are fast. Moving on, React is used to develop mobile and web applications, and Angular is used for single-page applications, and you can also develop hybrid applications using this stack, mainly because it's purely based on CSS, HTML, JavaScript, and jQuery. Single-page applications, as the name suggests, are built using single page. Now, the entire page is broken down into several components, wherein each component performs a specific task. Say, for example, one component handles the login, the other one would display icons and images, and so on. All these bits or components are then put together to form a single page application. And moving on, React was developed and maintained by Facebook, while Angular was built by Google and Vue was developed by Evan You, an ex-Google employee. Now, React represents the Vue part of the MVC framework, and Angular is a full-fledged MVC framework in itself, and Vue, on the other hand, is focused on Vue and the model layer of the MVC framework. Now, what exactly is the MVC framework? Now, MVC framework is an object-oriented design principle that mandates the separation of control, meaning one thing can only do one thing. So the model deals with the entity classes, the data, and the business logic, while Vue deals with the representation and the UI logic of the application, and the controller drives the functionality of the two. Any changes can be easily factored and isolated, and as a result, testing becomes a whole lot easier. Moving on, now let's look at the use cases from the business perspective. In terms of React, we have top websites like Facebook, Instagram, Netflix that use React. On the other hand, we have Angular that is used by Nike, HBO, Forbes, Sony. And Vue is commonly used by Alibaba.com, Grammarly, 9gag, and Adobe. Moving on, we have performance. Now, performance is a very crucial feature. Now, the moment you build an HTML view and render it into the browser, this view to the user is basically just HTML tags. However, if you look at the internal working, the code is actually converted into a balanced tree structure. This B-tree algorithm is extremely fast. So when the user makes any changes to the UI, the changes are reflected immediately. This is facilitated by the B-tree algorithm. So as a result, the performance is improved. So how does React make use of this tool? It uses a virtual DOM. DOM is an API developed by W3C. It stands for Document Object Model and defines how the document is accessed and manipulated. This DOM parser converts the HTML code into an inverse balanced tree structure. So React uses the virtual DOM, while Angular uses the real DOM and Vue uses the virtual DOM again. Now the virtual DOM looks at the differences between the current and the previous HTML pages and only changes the parts that need to be updated. Angular, on the other hand, updates the entire tree structure regardless of any changes made or not. and Vue again only updates the ones that have changed. Since there is no time spent on making unnecessary changes to the entire tree, React is extremely fast. On the other hand, real DOM updation is time-consuming, risky, and error-prone. Vue also ensures faster and bug-free performance. Now let's talk about data binding, the core reason why we would use single-page applications. Now consider a scenario where you'd log into an e-commerce website as say user 1. Then you should be able to see the items in your shopping cart, while user 2 would be seeing different items in their shopping carts and so on. So identifying the user and retrieving data corresponding to that specific user is facilitated using the help of data binding. Data binding is a process that allows an internet user to manipulate web page elements using a web browser. Now it is used in interactive components such as calculators, tutorials, games, etc. Now React supports one-way data binding, meaning you can take the data from the view and push it to the model or vice versa. Angular, on the other hand, uses a two-way data binding, while Vue also uses a similar two-way data binding. In React, every time the model state updates, the view changes accordingly. However, the reverse is not true. In case of Angular, any changes made to the view are immediately reflected in the model part of the architecture. Vue follows the same principle. Now, this hugely influences the performance. Due to one-way data binding, React is modular and fast, improving the performance. Angular's two-way data binding adversely affects the performance, and Vue, on the other hand, performs according to the input type. Moving on to scripting languages, React combines UI templates and JavaScript logic, resulting in a new language called JSX. So React only requires the knowledge of JavaScript. Angular uses templates, again in HTML. You can also inject JavaScript code into HTML using a clever implementation in Angular called directives. So you can create a class and then inject it into HTML. Angular also does something better. You can also write code for an Angular application using a newer language developed by Microsoft called TypeScript. It is a compiled language and is very similar to Java and C# in terms of syntax. Now Vue again uses HTML-based template. It uses HTML5 throughout for the UI and a combination of JavaScript for business logic. All Vue templates are valid HTML and can be passed by HTML parsers. Let's move on to testing. Now, Jest is a framework or an API that is developed by Facebook and is used to run tests on React applications to ensure that they are bug-free. Now, it is embedded typically in every React library and requires zero configuration. Now, Angular, on the other hand, uses the Jasmine framework. Now, this framework allows various functionalities to write different kinds of test cases. This also ensures that the application is error-free. The Vue CLI or the command line interpreter has built-in options for unit testing with the help of Jest or Mocha. Now, Vue typically has single file components, and hence these components can be tested in isolation. This makes it modular and extremely fast. Now, let's talk about community support. Since all these tools are open source, they have a large developer community. There are a few popular GitHub repositories for React, such as React.js 101, ReactJS.org, and so on. You can raise queries, solve a few, and connect with the larger community that's working on React. Here are a few repositories for Angular. Vue also has a few popular repositories. You can commit, download third-party plugins, and also explore these stacks even deeper. All of them surely have a very happening community. At the time of writing, there were about 1 million repositories, 5 million commits, and 1 million issues with respect to React. Here are the figures for Angular, and here are the figures for Vue. According to NPM Stat, over the past 2 years, there have been approximately 360 million React.js downloads. There have been around 38 million downloads for Angular and around 63 million downloads for Vue. Now let's look at the future scope. Learning a new technology always comes with questions like what's in it for me, what's its growth potential, how far will it take me in my career, and so on. So let's go ahead and see the growth rate of React, Angular, and Vue. According to Google Trends, over the past 12 months, React has been on a way faster upward trajectory than Angular and Vue, which have considerably lost their momentum. Now, this indicates that React is growing faster than the other two with respect to popularity, industry adoption, and community support.
In this session, we are actually going to look at how do we connect React.js with Node.js. So a very warm welcome to this session on React.js connectivity with Node.js. And in this session, we are going to focus on how do we connect our React.js application with the Node.js platform. So we are going to dive into creating a hands-on demo, which will have two parts to it. We would have the client application that we will first create as a React application. We will then create an express.js application with Node.js, and we will then try to connect both of those applications together. So express.js is a rapid application development framework that allows us to create a web application very quickly on the Node.js platform, and we'll use it to create a custom API and then connect that endpoint to the React.js client application. So let's dive into our demo, and let's start with creating our client and Node Express applications and see how to set them up and then get them connected to each other. Let's start with our hands-on demo, and we will first go to the Node.js website, nodejs.org. We can download the LTS version, which is the stable version of Node.js. The moment I click on this, it will prompt me for a download. It will download the MSI file, and then all I need to do is double click on it, keep clicking on the next button and install. That would install Node.js for us. Next, we'll open our editor. You can use any editor of your choice. So I'm going to use an editor called Visual Studio Code, and let's open up the terminal here. And I also have the command prompt open where I've navigated to a folder that I've created called ReactJS demos. Now we'll invoke the npm package manager, which is invoked by the command npx. So npx will not only install packages but also execute them once they are installed. So once they are downloaded, it will execute the package, and we will use npx to go and create a React application called client. So while we give it time for the installation to complete, we can then open it within our editor. So we'll give it time so that the installation completes. So the installation is completed, and so we've seen here that the installation is now completed. And let's go and open up this project. So I will say file and open folder, and let me pick up that folder and we will open this application called client. So that's my client app. Let's fire up the terminal. So okay, so that has launched the terminal for us, and here all we need to do to fire up this application and get it running is npm start, which will compile and start up this application that is created. Let's close this. We'll go to the browser, and now let's say localhost 3000. So that gives us our startup page, the sample default startup page for the first client application. And this is going to work as our client. We'll now go and try to create the backend application, which is going to be another application that we will set up. And to create that, let's say npx express generator API. Okay, so this will create an express application on Node.js called API, and let's give it some time for installation. Okay, so that's done. Clear this screen. We'll come out here. We'll open another instance of the editor. We'll say open folder, and that's the API application. We'll say select folder, and the API application is opened. Let's go to the terminal. Now in the terminal, we will attempt to install all of the packages that are required that would be logged in the package.json file. So the package.json file here would be listed. So you can see we have a list of packages that it uses, and npm install will go and install all of these packages that were pre-listed here. So let me ensure it's executed correctly, and we'll fire that once more. That's done. So npm install has installed all of the packages required, and let me terminate this run by pressing a Control C. So this terminates the client application that was executing, and now we will say npm start so that this application executes, and let's refresh. So that's the standard Express application now that has got installed. Now let's go to the API application. We'll go into the bin folder, and here we'll have a file called www. We will change the default port number from 3000 to 9000. Let me stop this application from executing. We've just updated the port number. Now let's go to the routes, and we'll create a new file in the routes folder called testapi.js. Here we will say variable express equal to require express, and here we'll say variable router equal to express dot router, and here we will say router dot get. We'll open this. So that's the default route. Root route is going to be for which we'll add a callback function which will take the request and the response parameter and next pointer in case there is another function to call post that. And here we will just send a simple message saying API is working. Okay, a simple message sent out for the root default route, and we'll have to export this. So we'll say module dot exports equal to router. All right, so that's done. Let's go to the app.js file, and here let us import that. So here is where we will import this by saying app.use. We want to use the test API file, and that is test API router. And this is exactly the same variable name that we will declare here, which will be equal to require, and we are going to say routes test API. All right, so let's try launching this now. We would say npm start after adding this code. Let's go out here, and 3000 test API is going to be the URL to hit. It's not 3000 but 9000 now because we just updated the port. So 9000 test API, and there we have our message which says that the API is working properly. So this is tested. Now let's go to the client application. In the client application, let's go to the app.js file. Okay, this is the file that we would have to revamp a bit. So let's revamp this. Here we will declare a class app which extends, so that creates a new module. So it extends react.component, and here we have constructor. We will accept the props. Here I would pass props to the superclass constructor and set the state to API response. Currently it just has an empty value. Next we'll add up a new function called call API, which will generate a call to that API URL, which was HTTP localhost. 9000 was the port, and test API was the URL. Once this is called, we will then call the then function, declare response, generate a call to response.text, and then we will again say this dot set state API response is going to be equal to the response that comes in from that URL, which is nothing but a string which says API is working. Another function called component will mount. So the moment the component is initialized on the screen and loaded, we will generate a call to this function we created called call API. Then comes the render function. In the render function, we would go and return a div. Class name is app. This would be app header, the standard logo, after which in the paragraph, we wouldn't need the link here. Right after the header, we'll add a paragraph where we will print this dot state and the variable we created called API response, and we will data bind to that. So that largely completes the return. So we simply create this application, that's the React application that will talk to this API that is, and this URL that is hosted on Node, communicate with it, get a simple string as a response, print that string inside this React application. So once that's done, we have the component will mount, which is a lifecycle method here. It's a lifecycle event that gets triggered the moment the component loads, and that's when we have actually gone and executed the call API custom function. Let's go to the API application. We'll terminate the execution here. There's one more step that we'll have to perform, which is cross-origin resource sharing, which means that to allow the React application to communicate from another hosted domain to this particular domain server, we will actually have to enable cross-origin scripting and sharing. Otherwise, it will block the request coming from another application. So for that, we'll have to install globally cross-origin module, and -- save indicates that it's going to do a global install for all applications that are on this particular system. So we've installed this, and we'll clear the screen. Let's go to the app.js, and right here is where we would want it to go and use CORS. So we will say app.use CORS so that it uses this particular API, and here is where we will declare the CORS variable, and go and import the new library package that we just installed, which is CORS. So looks good. And now let's fire up this application with an npm start. Let's also fire up client with an npm start. And now when I go and try looking for localhost 3000, which is the React application, the React application should go and talk to the API that is hosted on Node.js, which returns to me that string message. So if I go and ping that API separately, which is localhost 9000 test API, you can see this is a standard message. So here I've directly pinged the API that's hosted in Node.js. Now we are consuming it through the React.js application. And if you scroll down, you can see the message returned from Node.js into React saying the API is working properly. So the practical impact of this is to actually host RESTful services, etc. on Node as a server, and you can go and consume the data that is returned there, could be in string, text, or JSON format directly into the React.js, acting as a client application.
Hello, this is Matthew with SimpliLearn, and today we're going to cover React with Redux. So why would you use Redux? Well, the reason why you'd want to use Redux is that Redux actually understands and helps manage the state of an object. And Redux was introduced to help address some problems that you were having with React. So the state of an object stores values and properties that belong to components that could potentially change over time. So the state could be modified by actions in your network. There could be changes to the re-render of the component in the browser. The object could also then potentially store multiple properties. And then with Redux, it actually takes in and actually will create a large application that you could create with React and breaks it down to several components instead of having this massive number of states you have to manage. And so every time that an application will then switch from a current with React, you'd actually be then changing the states. And this is a really big problem. Because when you're doing that switching back and forth, there is the potential for applications to be re-rendered, which reduces the efficiency of your application. And so this is why Redux was introduced. So, what is Redux? So Redux is a way to be able to have a predictable state container for your JavaScript applications. And it'll allow you to run your applications in multiple different variants. So whether it's a client solution, a server solution, or a native app solution. And then more importantly, or one of the key elements that I like about Redux is that it's really easy to test. And so with Redux, you're able to manage the state of your tool. You can actually use it to work with any JavaScript framework or library. And you can actually then store the application and the components in a state store, which makes it easy to be able to manage the state of your application. So in simple words, Redux stores all the state objects in a single store and organizes it. It provides information about the current state of the application. Any changes in the state of the application can be described to the store by the user, and then it notifies any modifications made to the state of that application. So let's jump into the key principles of Redux. And there's three key areas I want to focus in. So the first one is that Redux provides a single source of truth. And that source of truth is being able to store the state of your whole application in an object tree in a single store. And this makes it easier for you to debug and inspect components of your application. It also enables you to be able to persist your app state for development and improve faster development cycles. The second principle is that its state is read-only. That's why you're able to describe more effectively what's happening because it is read-only. And this ensures that no events like network callbacks would create any issues with the code and the re-rendering of your application. And that object actions become then just plain objects. And then finally, changes are made with pure functions. And so what do we mean by this? So we can actually take actions and transform the state tree with pure reducers. And we'll go into a demo later on to show you this. But a reducer is essentially a function that accepts an accumulation value, and then it takes back and returns that as a new accumulation. And this allows you to have a single source of truth value. The user can return the new state objects instead of mutating to previous state. The user can start with a single reducer, and as the app grows, it can then split off into smaller reducers. And then finally, the reducers just become functions. So let's talk about the pillars of Redux. And so there are three key areas. We have the store, the actions, and then reducers. And then the store itself is the actual main object that holds the application tree state. And there are four key states. There's get state, which returns the current state of the store. And when we actually run the demo later on, you'll be able to see that we'll be able to open up our terminal window and be able to get the state store from our terminal window. The second state is dispatch, and this is an action. It's the only way to update the application state. And here we have an action on a button change to actually change the state of the application. And then the final two are subscribe and unsubscribe. And these are ways in which you can actually change the listener to the state. So an action is a plain object that represents an intention to change the state. So with actions, you have payloads of information that send data back and forth to your application store. So you can send any kind of data that can go back and forth. And that actions must also have then a type field that indicates the type of action that has been performed. And then finally, with reducers are specify how the application state changes in response to actions sent to the store. And so actions only describe what's happened, but don't describe the application state change. A reducer is a function that accepts the current state and an action and then returns a new state with the action performed. And then finally, you can use combine reducers utility, which can then combine reducers in an app into a single index. So let's look at the pros and cons of using Redux, because nothing is perfect. So a pro for working with Redux is that Redux provides a single source of truth, which is the store. So there's no confusion over where you're getting your values. This then leads to having a predictable and strict outcome. Redux is more stringent about how the code is organized. This makes it easier to onboard developers because there is a very structured way of writing Redux code. This makes it also then easier for the initial render, which allows you to make your solution really optimized as an experience. And then finally, developers can track everything that's going on inside the app in real time. The cons. So one of the plate code, so this kind of takes us back to the structured code format. It is strict in its setup, and it is memory intensive. So with that, let's go in and look at a demo of using Redux to reformat a React application. So in this demo, we're going to use React to show how Redux can work. First thing we want to do is go ahead and download Node.js. We're going to go to nodejs.org to get the latest download. The downloads are available in Windows, Mac OS, and Linux. You can also download and recompile the source code if you want. I encourage you to go with the latest LTS version. It's the latest stable version. There are other versions you can use, but that's the one you would want to use. I already have it installed, so I just want to show you how that looks. So I'm just going to go in and put node -- version. It's going to give me the version number, so that shows it's installed. I'm going to also use npm, which is Node Package Manager, because we'll be using that. Validate that it's installed by doing node npm -- version. So, okay, so we're looking good. And we're going to go ahead and create a folder on our desktop. Normally you wouldn't put a project folder on your desktop, but this is just for an experiment. So we're going to call this one Redux React, because we're going to be taking a React project, and we're going to show what it looks like as a standard project, and then what it will look like as a project that's being taken through Redux. So let's just move our cursor to the correct folder. And so we're going to go to cd redux react, and there we are. We're at the correct folder using our command prompt. You use terminal on Mac OS. So let's just type in npx, that's for our Redux, and we're going to do create-react-app. So we're going to create a default React app, and then we're going to also install Redux-app. And these are the two components that we need to be able to build out our solution. One is React, and it's React.js, and the second is Redux. And we hit return. And this is going to go ahead and download the latest versions of both of these applications and install them into the folder that we just created on our desktop. I'll just give that a moment. And so it's installing the different packages: React, React-DOM, React scripts, and there we are. I have everything installed. Great. And these are just different commands you can use. And it's recommending that we select npm start to get everything up and running. So we're going to use Visual Studio Code to do most of our work here. VS Code is an open source solution for scripting. It's available on all leading platforms. It is from Microsoft, but it is open source. And there's just a ton of stuff here, but we're going to go ahead and we're going to open up the folder we just created on our desktop. And so here is Redux React app. And we're going to select that folder. And on the left-hand side, you'll see all the files from that folder. We're just going to get rid of the welcome screen. We don't need that anymore. You'll see there's some commands we can use. We can do Control plus. I'm not sure what that's called again. Anyway, it gets us to the terminal window. Not an exclamation point. So you'll see that in our project folder, we have all of the files we need for our solution. We have both the node modules and then the public files. The public files is just the application itself. So we're here on the index.html. You see the index file there. And we're going to actually show what this looks like inside of a as it's broadcast from a web browser in a moment. Now, we're going to create a very simple application here, and the application is going to look exactly the same in both just standard React and Redux React. It's the optimization that's going to be improved. So we just did npm-start. It's going to take us to localhost 3000. Give it a moment, and then we should get our floating logo showing that the application's up and running. There we are. We can go ahead and edit app.js to create our application. Okay, so let's go in and we're going to go into app.js. And we are going to create an application called newcomp.js. And we actually have some code that we've already created that you can download as part of this application. But we're just going to type in here, import React, and then component from React. So I'm going to pull in our React library, and we also import connect from React Redux, and that's the package that we're working in. We'll terminate the batch job, yes, and then I'll rerun npm install -- save React Redux. And here we go. Takes a moment just to install that. So our goal here is to show how you can optimize your solution with Redux for the using the store and reducers in Redux. Again, the solution is going to look exactly the same. What's going to change is the performance of the solution. And this is what Redux gives you. All right, so we're going to go ahead and we're going to go in, we're going to type in class newcomp extends component, and then we're just going to select our constructor, props, and then we want to add in the super props, and then this state equals, we have a message here, subscribe. to simply learn. Very simple little app. Don't forget to save your work as you go along. And we're just going to apply some styles. Let's just apply some font style. Make it italics. And we're going to make the color purple. And let's have a button that we're going to press, a button change equals this set state. Oh, sorry, get state. And we'll have a message that comes up basically saying thank you for subscribing. There we go. We have our button. We'll change the state here in a moment. And very simple little application. And we want to run that on the screen. We just have some basic HTML for where we're going to place everything. We use a div tag for our app. Again, we're going to keep this really simple. And we're going to reference this styles for this H3 tag. And so our message is going to be subscribe to Simply Learn. And it's all being created dynamically. We're going to use our style. We're going to add in a button. We have a on click action. Subscribe. And oh, change too many S's. We'll save that. And save it. Now let's run that script. Go to app.js. And we're going to actually import that into our app.js script. Get rid of this. And then we'll extend the NewsCorp.js component into here. Play around font style here. And I'll render this correctly. And we'll pull in the text and styles. Again, very simple little application. I'm going to pull in from News Corp. So we'll actually have a welcome screen, a welcome line, and then pull in 2 lines of code. All right, let's run that. npm start. And here we go. Refreshes our page. So what we've just created is a basic standard state object. And let's see now. Oh, yeah, this is good. Now we actually can show you that we didn't actually write all our code correctly. So let's go back and fix that. It's newscomp.js, and we have to make sure that we have a correct export feature here, so that everything can be exported effectively. In import, we also need to have an export. All right, let's run that again. Okay, should take care of our problem. Hey, there we go. So welcome. And then we have the standard state object of subscribe to SimpliLearn. We hit subscribe and we change the text to thank you for subscribing. Okay, so let's kind of go in and modify this now. So it goes from being a standard state object to one that uses store and reduces. So we're going to go ahead and terminate our batch job and essentially reset everything. And what we're going to do now is install Redux. This is what's going to help us. It takes a moment to install Redux. All right, so we have Redux installed. That's good. And now we want to start our package. And it looks the same, but now we're going to make some changes. So let's go to our index file, index.js. And here's our React DOM. Now we're going to add in const store. So this is going to be our React. This is going to be our Redux store. So we're going to create a new store. And it's going to be a reducer. And we're going to pull in strict mode. Okay, reducer is not defined. Let's go ahead and define that. So we're going to come over to our new comp.js file. And what we want to do here is we're going to take out the one class file that we just created. And just kind of stripping it down here. Now let's go in and let's map our state to props equals state, and we're going to do return message is state.message, and then construct map dispatcher props, and this is going to be our dispatch. And we're going to be return, and we have our button change. For dispatch, we'll type in what the message is. And we can have message change. It's type from the button. Okay. So we'll pass the value over. All right. And now we're actually connect as part of our export, and in our connection, we want to do map state props and map dispatch props. All right, now we're going to go in, and it's going to be for our new comp. Now we want to switch over, and we're going to just change some of our linking variables here. So instead of to button change, we're going to do props.button change. Otherwise, we won't be able to find it in our code. This is some pathing. And we go ahead and create a new folder, and then this one is going to be our store. And again, this is going to be our Redux store. We're going to call the store reducer.js. And const initial state equals. This is what the default state will be for when the page loads, which will be subscribe to SimpliLearn. And then the reducer, we're going to point to where the reducer is. And const new state. And it's going to be any of action dot type. I'm going to change the message. Here's our news comp. So that's the action there. We're going to pull that so it's identical. And then new state dot message equals thank you for subscribing. So we have the default, and now we have the new message. Again, this might seem like extra work, but it actually makes your whole application much more efficient. Export default, reducer. All right, so make sure we saved all our files, which we have. And now let's go ahead. So we have, let's just inspect everything. It's all looking good. All right, now terminal window, we're going to do npm start. Let's see what happens. And our web browser should load up. Oh, we have an error. That's good. So now we're learning stuff. And this is all part of standard coding, is just hunting down errors in your code. So let's go to index.js. And looks like we're going to pull in here. So we have reduce, and this should actually be spelled correctly. There we go. Okay, all right, everything is now as it should be. Let's go back, recompile. Let's rerun our file. Do we want to move our file? Let's just go ahead and move the store. I'm going to update all the links to the store. And we're going to be making sure our provider store is referenced correctly. Okay, let's rewrite our application. And there we are. So let's go back through. Our application is running much faster now. We're able to manage our changes and our elements of our application as different objects. We're able to change the messages after you click, and it's able to then create the new message. Again, this is a very simple application, but you can see how for more complex solutions, how this become useful, and you can start using the different components you create for your whole solution. And that's our demo.
If you wish to build mobile applications and are confused as to which tool to use, then you're in the right place. This video on React Native will explain what React Native is and guide you through it. But wait, before beginning, if you haven't subscribed to our channel already, then make sure to hit the subscribe button and the bell icon to never miss an update. So here's what you'll be learning in this session. First, we'll understand what exactly React Native is. Then, we'll look at why React Native is being so widely used of lately. Moving ahead, we'll look at the differences between React Native applications and platform-specific applications. After understanding why React Native is used, we'll understand some of the prerequisites for building applications using React Native. Then, we'll understand React Native fundamentals like view, state, props, and style. And lastly, we'll end the session by looking at some of the industry trends of React Native. So let's begin. What exactly is React Native? Now, React Native is a framework that combines the best parts of native development with React to build user interfaces. These applications that are developed using React Native are downloadable on Google Play Store and Apple Store. Plus, because most of the code you write can be shared between platforms, React Native offers a wide collection of UI kits and makes it easy to simultaneously develop for both Android and iOS devices. But you must be wondering, why is React Native used? So let's look at some of the reasons why React Native is used. First up is cross-platform. Cross-platform means that the applications can easily be run on Microsoft Windows, Linux, and macOS. So you can build your code base once and then run it on any platform as opposed to software built natively for a specific platform. Next up is performance. Now, the React Native apps are compiled into natively written code, which enables it to not only work on both the operating systems, but also functions the same way on both the platforms with no lags at all. Moving ahead, there's quicker development. Now, React Native offers excellent developer experience. It provides strong developer and debugging tools with meaningful error messages. So working with this tool becomes very easy. A large developer community. Now there are several GitHub repositories on React Native and groups on Facebook. Stack Overflow is an excellent website with several developers interacting about issues on a regular basis. Next up is wider audience. Now since React Native applications run on both iOS and Android devices, there's a huge user base. And lastly, React Native has a great career scope. Considering the pace at which the framework took over the market and its simple approach to resolving development problems, the future of React Native looks more promising than ever. So these were some of the reasons why React Native is being widely adopted. So now let's go ahead and look at some of the differences between React Native applications and platform-specific applications. As discussed earlier, React applications work on multiple platforms. While in the case of platform-specific applications, as the name suggests, these applications are built for the specific platform only. Developers have a stronger web development background, while in the case of platform-specific apps, they have a very strong platforms language background. In this case, when you consider iOS, developers have a very strong hold of Swift, which is a programming language used to develop iOS applications, and talking about Android, developers have a very strong hold on Java. When it comes to React Native, it has a faster build time and is less suitable for complex applications. Comparatively, platform-specific applications have a slower build time and are suitable for complex applications. React Native is best for small development teams with limited resources, while in the case of platform-specific applications, it is best used by experienced developers who have adequate experience in building mobile apps. So now that you know what exactly is the difference between React Native and platform-specific applications, let's look at some of the prerequisites for building apps using React Native. First up, you should have a stronghold in programming concepts like functions, objects, arrays, and to a lesser extent, classes. Now, understanding JavaScript and all the JavaScript libraries and frameworks is crucial. And lastly, you need to be familiar with HTML and CSS concepts. So as long as you have a strong hold of these, then React Native development becomes very easy. So now that you know what React Native is, you've understood why it's being used, some of the prerequisites for React Native, let's look at the basic concepts like view, state, props, and styling in React Native. Let's begin with view. Now, view is the most fundamental component of building a UI. It is a container that supports layout with flexbox, style, some touch handling, and accessibility controls. Now, view maps directly to the native view, equivalent on whatever platform React Native is running on. So here you can see there's a simple code snippet and the output for it. So as you can see, there's a hello world message in a render method, and the same is being rendered. And the view component here is being imported from React Native. Now view, as mentioned earlier, acts as a container with support for flexbox layout and other styles. So flexbox is designed to provide a consistent layout on different screen sizes. Moving on to state. Now there are two types of data that control a component. One is props and the other one is state. Now props are generally set by the parent and are fixed throughout the lifetime of a component. But for data that is going to change, we make use of state. So here you can see I've made use of the this.state.myState in my render method. You can also use the setState method when you want to change it. Moving on, let's look at props. Most components can be customized when they're created with different parameters. These created parameters are called props, short for properties. Now props are passed from one container to another as a way of passing data between them. So here, using the name as a prop lets us customize the message in the component. So we can reuse our component for each of our TV shows here. So this is how we can use props in our component. Lastly, talking about style, React Native uses the conventional JavaScript styling for components. So the style names and values are similar to how CSS works. Now to style, we either use inline style or style sheet. So you can see here we've provided inline styling with a background color, a color and a font size, and accordingly the output is displayed. Moving ahead to our last and final section, let's look at the industry trends today. Talking about salaries, the average salary of a React Native developer in India is around 6 lakh Indian rupees per annum, and the salary of a React Native developer in the US is around $96,000 per annum. Now, as you can see, React Native has a higher growth trajectory compared to other frameworks. As a result, it's being readily deployed by many companies. Applications like Facebook, Instagram, Netflix, Pinterest, Uber, Uber Eats, among others, are developed using React Native.
In this session, we would look at identifying some of the differences between the React Native and Flutter frameworks. Let's start with understanding the core areas of comparison as part of this session. We will be looking at key aspects to identify differences between both the frameworks, predominantly on the language front, the UI aspect, the performance, the documentation, the popularity, the community support that is available for both these frameworks, along with the industry trends in terms of the industry adoption for both these platforms. The core objective of the session would be that at the end, you should be able to decide and make an informed decision as to which framework is the best among those available. Let's start from a language perspective. Now, if you look at React, React is basically completely written and built in JavaScript using the React.js API. On the other hand, if you look at Flutter, it is basically written in a very new language called as Dart, and we do not have too many developers that are skilled on Dart. However, every browser and every platform being shipped with an inbuilt JavaScript execution environment, that makes JavaScript platform the language of choice for developers. So every browser today or every browser manufacturer would have inbuilt support for executing JavaScript programs. Similarly, most popular platforms, mobility platforms like Android and iOS, have default support for executing JavaScript programs. And that's the reason when you compare this with Flutter, Flutter uses Dart, which is predominantly a newer language, and you really do not have too many developers who are skilled on this. So that really is the selling point and the USP of React Native, because when you work with React Native, you really do not have to relearn a lot. You don't have a sharp learning curve. Most of the JavaScript developers who are working with MeanStack, already working with HTML, CSS, and DHTML can easily align to this. That, as we have discussed, is pretty new in the industry and would not have that much of penetration in the developer community. From a UI perspective, when you talk about React Native, it's based pretty much on native components for the Android and the iOS platform. And Flutter, on the other hand, uses a very proprietary set of widgets, and it has its own page structure that needs to be set up. So it's a closed ecosystem as compared to an open ecosystem in React Native, which allows you to go and implement third-party widgets and UI frameworks as well. Now, this is really what allows you to pick and choose with React Native, because you can go and decide whether you want to use Kendo UI or a set of Telerik controls or any other third-party UI framework can be implemented. But for Flutter, you have a pretty closed ecosystem, and that's the reason the UI components that are available out of the box and built into the platform are all that you can use. From a performance perspective, when you talk about React Native, it basically is built and uses JavaScript out of the box, and that's the reason when you want to write any code in JavaScript that connects and tries to access native services on that specific platform, it uses a bridge to do that. But when you're using Flutter, on the other hand, Flutter does not need any kind of bridge. So there's no concept of you write Flutter code and then it uses a bridge to go and connect to the native set of components to interact with. And this is what really impacts the speed and the performance aspect of developing and executing applications between both these frameworks. Because if you look at React, the speed of development is a little bit slower when you compare that with Flutter. And that's because it has an intermediate bridge that it has to communicate with, and every layer of additional communication and computation that you put in between two tiers in an application that you build obviously would have a performance impact. From a documentation perspective, if we were to compare, Flutter typically has a very well-defined documentation repository, and it allows developers to go through it in a very simple manner. So it's all structured, it's all organized. Unlike what you see on React Native, because in React Native, it actually, since React Native is an open ecosystem, it allows you to implement third-party widgets, and you can do a lot of configuration and plug and play. And that's the reason the documentation also is not very strong, well-organized, and impactful. And that's the reason most developers would find it a little challenging to go through the React Native documentation when you compare that to the documentation available in terms of Flutter. Popularity is always a key when working with platforms, and that should be a crucial decision maker, because when it comes to open source technologies and you're stuck somewhere, you obviously go to the community to go and find out how best you can solution the problem. Now, Flutter being relatively a new entrant into the market, it does not have a lot of developer penetration, and that's the reason the popularity in the community is not very strong. React Native being there for a while now, it's been around for some time, and that's the reason it's pretty popular among developers. Also, since it uses JavaScript, it's a natural transition and a progression path for those who are working with HTML5, CSS, and are building web applications or have been building hybrid mobile apps. Find it very easy to migrate to this, because Flutter requires you to learn a new programming language. which is Dart. And that is one more reason why the popularity of this is much, much better on the React Native front as compared to Flutter. Again, if you look at Google Trends, you could actually look at both of the lines here. The red line indicating Flutter, it started on a very positive note, and then there was a plateau and then suddenly a spike. React Native has been much more steady in terms of its growth, and ultimately if you look at it now, both of them seem to be trending at par with each other. So the community support, as we were speaking about, if you look at Stack Overflow, which is one of the most popular websites to go for any kind of developer trends and movements, and for a Q&A that most developers would have, you can actually look at the number of questions here. And also React Native is part of GitHub as it's open source. It was released in 2015, and it's because of the huge community support that it becomes easier to implement this. You have a lot of confidence as a developer when you start building on this stack. Because if you're stuck somewhere, you will have a lot of help available on the way. On the other hand, if you compare that with Flutter, you can look at the question count here on Stack Overflow. And this being a new entrant in the market, it has a smaller footprint on the community aspect, but of course, that keeps increasing every day. Again, from a React Native perspective, and you talk about stability in terms of stable releases, there again, you would see that React Native does a much better job as compared to Flutter. So the industry trends are something which all of us have to be aware of, specifically if we would need to make a decision in terms of our careers, the technology that we are learning, what is the growth aspect, what is the industry adoption, and how we could really move ahead on our career graphs in terms of the opportunities market, the job market, etc. So again, getting back to Stack Overflow, which is the benchmark for understanding technology trends in IT sphere and on software development. If you look at a recent survey conducted in 2019, 62.5% of developers seem to have shown interest in React Native as compared to a marginal rise of 65.4% where Flutter seems to be doing much better. And of course, that could be due to the time frames that both these technologies have been around. React has been around for quite a while, and hence the job prospects are much better. A lot of organizations implementing this. Flutter has been a new entrant, and hence slightly fewer opportunities, as the penetration still needs to happen in the opportunities job market and from a developer skills perspective. So these are some of the big names that are using React Native in their implementations, right from Facebook to Pinterest to Wix, Skype, Tesla, Insta, Bloomberg. You can actually look at the implementation across industry, which is absolutely crucial when you're learning something new, because when you want to join a large logo, obviously, if there are a lot of logos using this, that enhances the credibility of what you're learning, puts a justification to why you would want to learn this technology. Flutter, on the other hand, associated with big names like Google, Sonos, Alibaba, the largest retailer out there. From a conclusion perspective, if we were to conclude on what we've discussed from a language perspective, obviously we said React is much more popular since it is a natural progression for developers to work on JavaScript and then move to this, as compared to Dart, which is relatively a new language. From a UI perspective, the open source plug and play capability of configuring and adopting seamlessly to newer platforms of widgets and third-party UI platforms are much better as compared to Flutter, which is a closed ecosystem and depends on inbuilt widgets to implement. The performance aspect we discussed, because of the bridge from the code that you write to the native component access, exists in React and is isolated and not any longer required in Flutter, and hence the performance is impacted because of the additional layer in between. The documentation much better in Flutter because it's a closed ecosystem and they can control what you can use. React Native being open-ended, it really has a lot of third-party integration you can do, and hence the documentation is not really well organized. The popularity perspective, React Native much more popular among HTML5, CSS3, MERN, mean stack developers, since it's all JavaScript. Flutter needs you to learn new skills and you need to spend additional time for that. From a community support, React Native has been there for a longer time as compared to Flutter, and hence has a stronger community support as compared to Flutter. And that translates into better job prospects in the industry for React Native as compared to Flutter. So if we were to give it a score, React scores much better with a total score of 5, leaving Flutter with a total score of 2. So I hope we were able to understand the differences between the React Native and Flutter, and this will help you make better decisions with planning your career and deciding which technology you should latch on to.
Welcome to this session on React.js interview questions. Through this session, we will explore the most commonly posed interview questions that you would face if you walk up to a developer interview on React.js. Let's start with going through and exploring the general set of React.js interview questions that would be commonly asked in an interview. The first question would be, what are the features of React.js? Now, right through this session, we would follow a common methodology where we would explore the question and then look at the best way in which you could have answered that question if posed to you during a React.js interview. So starting with the first question, what are the features of React? So React has many extensions for complete application architecture support. JSX is used with React to describe what the user interface should typically look like. React is broken into small components. So you look at the complete application you want to build, break it down into individual components, and a component is typically a piece of user interface like a function that would return a stream of HTML characters. Speedy performance is one of the core features of React, as only the updated components need to be re-rendered on the screen and not the entire page. The one-way data binding feature, on the other hand, keeps everything modular and fast. The virtual DOM is also a lightweight representation of the real DOM, which is again a feature which helps speed up performance and avoids a full page refresh and a full DOM tree shake, which really speeds up performance. So what is JSX? How do you answer this? So JSX is typically the extension used for React, and it's nothing but an extension to the JavaScript programming language, because all that you can use inside your browser for execution typically has to be JavaScript, because in HTML5 you cannot have any third-party plugins installed in the browser, and that's the reason the browser would only ship by default with a JavaScript runtime engine. So by using JSX, you can write HTML structures in the same file that would contain your JavaScript code as well, making the updates to the code very simple. So it's simple to update and make modifications to your code, because the code and the data and the business logic is all composed in a single file. So because the code and the business logic is in a single file, it makes updating and incorporating change requests to the code very simple and easy. So it's basically used with React to describe what your user interface should look like, and it's what you typically would term as the HTML template or the view. Coming to the next question, can JSX be directly read by the web browser? So web browsers cannot read JSX directly. Now why is that? Well, the reason is simple. It's because they are only built to read regular JavaScript objects, and JSX is not a regular JavaScript object. It's a React component. So for a web browser to read a JSX file, the file needs to be transformed into a regular JavaScript object, and for this there is a JavaScript API called Babel, which is internally used by React. So what do you understand by the virtual DOM that we've been speaking about in React? So React gives a very lightweight representation of the real DOM, the actual DOM structure of the page. So DOM is document object model. It is an API created by W3C, and it creates an in-memory representation of the HTML elements as a inverted tree structure, a balanced tree structure, which is the fastest search algorithm when you want to search for HTML elements and do a dynamic update on them. But again, updating the basic DOM tree structure of the page causes a full page refresh, and if you only want to update a specific component, you wouldn't need the entire page to be refreshed, and that is where React comes in. It uses a virtual DOM, which is a layer on top of the actual DOM, which ensures that only a certain part of the page is refreshed, and that speeds up performance. So when the state of an object changes, virtual DOM changes only that object in the real DOM instead of updating all the objects, and this is what makes things really fast. So why use React instead of other frameworks like Angular? First of all, it's very easy to create dynamic web pages, HTML, where you can update the view or the template at runtime. The components are reusable, so you reuse rather than reinvent. The performance is great. since you're working with the virtual DOM, you don't need a full page refresh. The unidirectional data flow makes data move one way. There's no two-way data binding by default, and that's the reason the page does not have to do a lot of heavy lifting of remembering whether the view is changing, whether the base JavaScript entity class is changing, and that saves a lot of processing time. Again, to debug React is much more simpler, and that's what makes it more popular in terms of its simplicity and speed as compared to other frameworks like Angular. What is the difference between ES5 and ES6 standard? So these are scripting standards, okay, that are defined by the European Computer Manufacturers Association, or ECMA, and all of the scripting languages are a subset of the standard and are derived from these standards to ensure that the code will execute on all browsers, and the code that we are writing is standards based. So these are a few instances where ES6 syntax has changed from ES5. If you look at the ES5 syntax on the top, we are creating a simple React class component, and the render function just returns a stream of HTML content. In ES6, there's a new keyword that comes in, which is extends. So you are extending from the base React component and creating a custom component and then returning a stream of characters. Also, the function keyword no longer needs to be used. So the exports versus export also changes. So you use exports to export out class from a module so that it can be accessed from another module. In ES6, you simply say export and the component. Require versus import. So you would require a third-party component or an API into your JavaScript file to use it. In ES6, it's replaced with the import statement, very similar to the syntax that we use in core Java. So how do you go and create a React app? First, you install Node.js as a base platform, which you can download from the Node.js website. Next, any text editor of your choice, could be Atom, Visual Studio Code, or Sublime Text. Third, you create a React app using a command prompt terminal. Depending on the OS you are using, the command to give is create-react space my first app. Okay, so the command that you would give to create a new React app is create-react-app space and the name of the application you would want to create. In this case, it is my-first-app, and that could be a custom name of your choice. So what is an event in React? Well, on the web, when you talk about dynamic HTML, it's all about interacting with the user. So the user performs some interaction event with the web page, which could be a click of a button, a mouse move, and these events in action can be triggered by a user or any system, or could be pressing a key or a mouse click, etc. And in response to that event, you would execute a block of code, which is called an event handler. So here we have class simple, which is a custom class that extends the base React component, the name of the function work, which triggers a simple alert message box, and a render function which returns HTML. When you click on the button, we would want to bind that to the event handler this.work, and that's how you connect a click event to an event handler function. What are synthetic events in React? Well, a synthetic event is an object which acts as a cross-browser wrapper around the browser's native event. It combines the behavior of different browsers' native events into one API, which makes sure that the events are consistent across different browsers. And this brings in the standards-based development to ensure in this digital age, the code that we are creating for different browsers have consistency in terms of its execution. So here we see a function action link. We see a function handle click, which takes E as an event parameter. E.prevent default ensures that there is no error that the browser is raising in case the event function call is not directly compatible with that specific browser. So prevent default is used to suppress any browser specific errors or crashes, and a simple console.log which will log into the developer tools window which says you just clicked a link. And then we've got the return, where we are returning the view to, or the HTML template, where on click we connect to this event handler called handle click. So handle click is basically a wrapper, and the entire action link is a wrapper object which is a synthetic event. We don't directly go and bind to the on click and then associate a function with it. We actually associate a synthetic object with it, which binds the base default event that could be specific to a browser. So some browsers would probably understand an on click, another browser would understand a click. And to ensure there is consistency of syntax, and from a development perspective, the code that we write will run on all browsers, we need to take care of using the synthetic events which isolate the developer out from the complexity of writing code specific to different browsers. So you just write generic code which will work on different browsers. So how do lists work in React? So the lists display data in an ordered format. The traversal of lists is done using the map function. So here we see there is a function called list of names which takes a variable props as a parameter. Props.names will allow us to get a reference to all of the array of names that are passed. Constant list names is another variable created equal to names.map. And we are using the arrow operator, which is now an ECMAScript standard. And again, we are using the opening tag of the li HTML element. The key is equal to the name attribute. So the brace bracket will bind that to the name attribute. Then we just print the name itself and we close the li tag. So that's the names.map function. And finally, we return in an unordered list the list names themselves. So the map function will run through and iterate over the list of names, list them in the li tag. The li tag will get injected into the unordered list and will finally get returned out as a stream of HTML elements. In the next code snippet below, we create a constant variable names. We are associating it with a set of 5 names, and we simply say render list of names, names equal to names. The moment we do that, we are using list of names as a custom HTML element which is not system defined. It starts looking for the function list of names, passes the names array to it, iterates over it using the map function, which is an inbuilt React function, brings out all of the lists. It's very similar to a for loop that you would write for iteration in other programming languages. And then finally what you get returned in the getElementById app is nothing but a list of simple names wrapped in a li element that are printed on the view. So why is there a need of using keys in lists? So keys are very important in the code snippet that we saw due to the following reasons. The first reason, the key is a unique identifier if you would want to search for a name in the list. It is used to identify which items have changed, updated, or deleted from the list. So if you want to perform CRUD operations on the data, you would want to search for which element do you want to update or delete or change. It also helps to determine which components need to be re-rendered instead of re-rendering all the components every time, and it increases performance as only the changed components have to be re-rendered and not all the components on the page. What are forms in React? So using forms, users can interact with the application and enter required information whenever needed. So forms can contain certain elements such as text fields, buttons, checkboxes, radio buttons, etc. And forms are also used for many different tasks such as user authentication, searching, filtering, etc. How do you create a form? Pretty simple. Again, create a custom component called nameFrom that will extend React.component. We create a state variable. This .state is equal to value. We handle the change by writing a handle change event, and we handle the submit by writing a handle submit event. In the change event, we just change the state by saying set state of the value to event.target.value, event being a system defined keyword passed as a parameter. And in the submit, we simply alert that a certain name was entered, and we trap the value that was entered into the form. Prevent default to suppress the browser from raising any errors. On the render function, we return a form. On the submit, we connect to the handle submit event and we bind the data submitted from the form to the handle submit event, and we pass the this pointer, which is a reference to the current context of the view itself. We open a label, specify the name, we then specify an input box as text. The value is set to this .state.value, and on change, we simply connect to the handle change event and bind to it and pass the context of the text box itself. So the moment we change the value in the text box as we are typing, the handle change event will receive the updated value and set the state. And when we click on the submit button, the handle submit event handler executes and we alert out the current value printed in the text box, and that's it. So how do you write comments in React? When you're a developer, if you want to comment out some code or if you want to set comments to enhance the maintainability of the code, a single line comment is as simple as given in most other programming languages, \* to open, * to close. Multi-line comments follow the same syntax and can span multiple lines to add comments to functions in terms of what the function can do and what are the types that it can return. What is the arrow function and how is it used? So an arrow function is a shorter way of writing a function in React. If you look at the snippet on the top, my input on change equal to, we are connecting to this dot handle change dot bind, and that's the longer version of how you can connect it to an event handler. The shorter version is on change equal to e arrow operator this dot handle on change. So you don't need to call the bind explicitly. You can replace that with the arrow operator and reduce the amount of code that you typically write. How is React different from React Native? So React and React Native are completely different. React was released in 2013. It's a web-based platform. It is HTML compliant. It generates HTML views. It uses CSS for styling, and it's based on JavaScript, HTML, and CSS. React Native, on the other hand, is targeted to mobility devices. It's meant to create installable apps on Android and iOS. Released in 2015, not based on HTML and CSS, and it basically requires the React.js API to create these installable apps for these mobility ecosystems. How is React different from Angular, another popular framework by Google? So Angular, created by Google, completely based on the model view controller pattern, works on the real DOM layer and requires a full tree shake at the DOM layer to update views and components. Supports bidirectional data binding. The rendering is purely done on the client side. The performance comparatively slow. React.js, on the other hand, created by Facebook, it's the view layer of the model view controller pattern. It works at the virtual DOM layer and is hence faster. It's unidirectional data binding and not two-way. And the rendering is typically what is done at the server side, and what you get as a response on the client is a stream of HTML characters as an output. Let's talk about and discuss some questions around React components. So what are components in React? So these are the building blocks. You can think of them as Lego blocks. So you break your problem down into small parts, each part identifying a certain solution of the problem, which is what we define as a component. So they are building blocks of a React application, and a single app usually consists of multiple components. So it splits the UI into independent reusable pieces that can be processed separately. A component is essentially a piece of the user interface or the HTML view. What is the use of render method in React? So it is compulsory for each component to have a render method. If not, there wouldn't be any HTML for the component to render on your view. So the render function returns the HTML, which is to be displayed within a component. Like you see on the screen, there is a class app that extends the React component, and it returns a simple h1 element called hello simply learn. And of course, do remember to export the app out so that it can be accessed from other components as well. If you need to render more than one element, all the elements must be inside a single parent tag like a div or a form. What is state in React? The state of a component is an object that holds some data within it. The data would influence the output of the component. Now, how do you implement state in React? So state holds the data that a component renders on the web application. For example, here we've created in the constructor this.state equal to, and this temporary anonymous object has two attributes, car and bike. When we return, we simply return this.state.car and this.state.bike. Now this is how you would create stateful components and access the state properties within the view. How do you update the state of a component? By using the built-in setState method, you can go ahead and update the state of the component. So here we have a simple render function that returns the state itself, state.message, and on the onClick connects to a button press function. The moment you click on the button press function sets the state to another message. So the initial message in the constructor is welcome to simply learn. The moment you click on the button, the setState triggers and changes it to best place to learn. So the data on the view would be updated. What are props in React? Well, props is just a short form for properties, and that is what allows us to pass arguments or data to a component. Props are passed to components in the way similar to that of attributes that are passed to an HTML element. So how do you pass props between two components? So let's say we have an app.js component on the top and a main.js component at the bottom. At the top, we are trying to return this.props.car and the bike. So two car and bike attributes associated with this props of the app component. In the main component, when you look at the render function, We are associating car prop equal to a value of 1600 cc and bike prop equal to value of 150 cc. And to access it, if you look at the import statement, we are importing app from app.jsx. And this is how you can cross-access properties from one component within the other. So what are the difference between state and props? Well, state holds information about the components. They are mutable. They can be changed. They cannot be accessed by child components, and they cannot have state. Props allow to pass data from one component to the other as an argument. They are immutable. They are read-only, and props can be accessed by the child component, and they can have props as well. What is a higher order component in React? So these act as a container for other components, which helps in keeping components simple and induces the reusability factor. They are generally used when a common logic has to be used by multiple components. That's when you group together a set of components within a higher order component in React. How can you embed two or more components into one? This code snippet demonstrates the app component, which returns a hello text, and it has a custom tag called simple. The simple tag is defined in the component below, and it returns text called SimpliLearn. And in the render of the React DOM, we simply go and render the app component. So hello SimpliLearn would be the final output, and that's how you can embed one component into the other using this methodology. What are the differences between class and functional components? So stateful components would extend React component in this case. And if you could look at the render, it simply renders this .props.title. The constant stateless component would be equal to props. The div tag returns this .props.title. So you can look at the style, very different in terms of class and functional components. One using the arrow operator, one using the traditional class and render method. So the class component can hold or manage state. Complex as compared to stateless components, can work all of the lifecycle methods of the component, and it can be reused. The functional component cannot hold or manage state. They are simple and easy to understand. It does not work with any lifecycle method, and it cannot be reused. Let's explain the lifecycle methods of components. We've got initial state, which is executed before the creation of the component. Component did mount, which is executed when the component gets rendered and placed on the DOM. Should component update, which is invoked when a component decides any changes to the DOM and returns true or false value based on certain conditions. Component did update, it is invoked immediately after the rendering takes place. Component will unmount, which is invoked immediately before a component is destroyed and unmounted permanently. Let's move to the React Redux set of questions. So what is Redux? It's an open source JavaScript library used to manage application state, and React uses Redux for building the user interface. What are components of Redux? The first is the store, which holds the state of the application. Store contains state, which defines the user interface, which triggers a set of actions, which are then sent to the reducer. So store holds the state, action is the source information for the store, and reducer specifies how the application state changes in response to actions sent to the store. What is Flux? Well, Flux is the application architecture that Facebook uses for building web applications. And it works in this way. The action is triggered, which is sent to the dispatcher. The dispatcher sends it to the store. The store sends it to the view, and the view sends it back to the action. And that's exactly how the steps would continue in sequence. So when we trigger an action, the dispatcher will get notified. Once the dispatcher has dealt with an action, the store's listening to it will get triggered. The view gets updated when the state of the store changes. User action at the view is sent to the dispatcher to then be processed. How is Redux different from Flux? Redux is an open source JavaScript library used to manage application state. The store state is immutable. It can only have a single store, and it uses the concept of reducer. Flux, on the other hand, is an architecture and not a framework or library. The store state is mutable. It can have multiple stores, and it uses the concept of dispatcher. Let's look at some React router questions. What is a React router? A React router is a package which is used to create routing in a React application. React Router is used for developing single-page web applications. It allows multiple views in a single application by defining multiple routes in that React application. How is React routing different from conventional routing? React routing has a single HTML page. It uses, or the end user rather, would navigate multiple views within the same file. called a single page app. The page does not refresh since it's a single page file, and there is improved performance since you're not navigating across multiple pages. Conventional routing, each view is a separate HTML file. The user would navigate multiple files for each view. The page would refresh every time the user navigates, which would hence result in slower performance. How do you implement React routing? You can implement React routing using a very simple method. Considering the above components, let's say you've got a component called app, about, and contact. So here you can specify the route path. If the route path is just slash the root default route, it takes you to the app component. If the route is slash about in the URL given by the end user, you automatically navigate and activate and load the about component. And if the URL is slash contact, it would take you to the contact component. Let's talk about React styling questions. How do you style React components? Either you use inline styling by using simple CSS, by simply saying color blue, and that's going to be the output of the H1 element. Or I could use a JavaScript object by specifying a constant simple style object and specifying a key pair value of color, background color, margin, font family, and apply that object as the style parameter, which would result in this styled output. How do you style React components using a CSS style sheet? So here's an external style sheet. So we've written all the styling rules in a separate CSS file, app.css. We've imported that at the top of the app.js React class, and lo and behold, you have the output simplified as generated on your page. Let's explain the use of CSS modules in React. So a CSS module file is created. .module.css is the extension. The CSS inside a module file is available only for the component that is importing it, so there are no naming conflicts. So .button is the CSS styling inside button.module.css, and that is what we've imported from in the app.js file. So when you view the button, styles.button is the styling picked up from the button.module.css file.
And with that, we have come to an end of this full course tutorial. I hope it was informative and interesting. If you have any question about the topics covered in this video, feel free to put them in the comments section. Our team will help you solve your queries. Thank you for watching, keep coding, and stay tuned to SimpliCode.